coil.
But if I use this cable with adapter to 3mm, does it affect?
I think
Because
you can try that.
no, I mean in general, not today.
In general, I think not, because the principle is you have the positive wave and the negative wave sending through the DC cable, plus minus of the ground.
Yeah.
And when some noise coils on the cable and the receiving the device changes the polarity of the negative and
This becomes
as
worse.
used to the previous one when there is a noise.
Yeah.
So it changes the noise and the noise goes to the zero level. So that's the
Basically, I need a new camera.
with symmetry hinges, of course, it's all dependent on the. If you are dragging long lines, symmetrical cable is always probably only solution.
This camera is quite old.
But
Można sobie rozstawić co się chce. No i dobra.
Yeah, I'll check.
I tu będzie dobre miejsce na to. Jest może najbliższe. No tam sobie będę chodził z komputerem. Meidi? Varna skoko mikrofona? No je. Taka, że w przypadku dynamicznych obiektów automatycznie reguluje ostrość kręgu, żeby robić temperatury.
No test one.
Który przynajmniej nie wyłączać tego nie trzeba.
It's okay for you? The level is fine, or you more or less?
It's all okay.
What purpose is there?
Do you have a second microphone?
Sure. Nie wezmę więcej.
Good morning. Good morning. That's much better. So, welcome to the 10th European MOM. So, we have been here for 10 years already. 9 years, 10 times. Let's be precise. So, this is MikroTik update. So, you will see all the new stuff that's coming that we are ready to announce for you. So if you have some colleagues that can't be here in this room, there is a live stream on our main webpage so they can see the same presentations live. So you can text them right now so that they can also follow this and all the next presentations live afterwards. So we already had more than 80 MOMs around the world, so we even have a map with all the dots that we have been. So this is already third time here in Prague, but there's many new exciting places coming, so if you want us to visit your country with the MOM event, you can always write to us and should suggest us something, because we are open for all those suggestions. So, just for those who are here for the first time, sorry for all those that already know this information, but so we are located here in Europe, in Latvia. We already have more than 150 employees. So those who are following every hour presentation, you can see the speed that we are growing. We were established in 1996. We decided to start making our own software RouterOS in 1997. First router board, first hardware in 2002. And first MOM was here in Prague in 2006, so 9 years ago. And so far, the biggest MOM was last year in Indonesia. It was 2,000 people in the event. So for those who have never heard of Latvia, it's around there, the green one. So Northern Europe, Eastern Europe, how do you look? Somewhere there. And basically what does MikroTik do? So we provide routing and wireless equipment for all the possible setups that are out there. So if we are missing something, you should write to us and ask some features that we are missing. Most likely we'll eventually implement those so that we can continue to say that you can do everything with MikroTik that is necessary networking. So, and basically routers have I would say the biggest set of features that any networking router OS have around here, so there's that. So basically RouterOS is an operating system. You can't install it on your Windows or on your Mac OS. You need a separate system for that. And you can also have it on our hardware, which we call the router board hardware. Of course, there's cloud core routers, cloud router switches. So basically, RouterOS comes with all MikroTik stuff. And you can do routing, firewall, bandwidth manager, wireless, lots of wireless stuff, backhaul links, hotspots, and lots of VPNs. So currently, we are using Linux kernel 3.3.5. Some of you guys already will say that it's quite old. Don't worry, RouterOS version 7 is coming. And it will have the newest kernel at this time. So, sales slide. So why choose us? So we already have millions of RouterOS devices around the world. So it's a big chance that you will go somewhere and it will be a requirement to know how to configure RouterOS because its device is already there. So we've been around already for 18 years in all the networking and hardware designing, so we have lots of experience. And the last thing, we already have 20,000, more than 20,000 trained and certified network engineers. So there's lots of people that can help you if you decide to switch or introduce MikroTik solutions to your company or your network. So if you have questions where those 20,000 people are located, here is a small map. Each dot is either certified consultant, trainer, or distributor. So these places you can find. If there's no dots near you, you can always can become one, just with little work. So if you are interested, we want to hear from you. So who are here today? So first of all, of course, our CTO, John Tully, he's over there in the back. So if you have some really interesting business talks or ideas that you want to discuss with him, yeah, you can maybe find his time and discuss something. Near him is our CEO, Anis Reksniņš, in blue. So the same goes to him. So if you have very interesting high-level requirements, you can ask the questions there. But mostly you will have to work with other guys, like for example, our sales department. So we have Jānis Jankovskis in red shirt, one of the tall guys there. Next to him is Edmunds Aperants, also sales. And then we have new guys that are first months for them, but in time they will become as experienced as others. There's Karls Woga, also sales. As you notice, all the sales guys so far is very tall, so they are easy to see. But we also, for the less colored people, we also have one just properly sized. That's Raivis, also from sales. So you can talk with all these four guys. They are well instructed to answer all your sales questions. Then, of course, there's many technical questions. So you can ask them to 6 persons in the MAM. So first is me, Jānis Meģis. Then there is our wireless guru. It's Uldis Čarnievskis over there. So if you have wireless-related questions, very tough wireless questions, you can ask him. Then we have Sergejs, who basically knows everything about anything in RotorS. So if he doesn't know the answer, he will find in 10 minutes. So you can always ask him. So, and then there we have 2 new guys. They are coming in right now. Also first months from them, but you can still ask them tough support questions. It's Martin Strotz and Krišjānis Pumpurs. So these are the guys who will hopefully take some months off our hands, so we can travel to more places and so on. So, and last but not least, it's Normons, who is always organizing all the stuff. Where is Normons? Okay, look. Yeah, he is the only one working at the moment. So yes, there is Normans. So he is our face and design guy and everything. So if you want something, make some beautiful advertisements or something, you can always talk to him. So as you can see, 12 people here. So if you can't find the MikroTik guy, most of us are in the red shirts with the stuff on the back. So we should be well noticeable and so on. So let's go on. So if you missed some presentations or you are very interested in some of the presentations, you can have presentation slides afterwards on our wiki page. Videos, we are making all the videos, will be available on TikTok. Live stream is available now. And you know that everyone who attended have a free RotorS license, so it will be automatically signed to your account at mikrotik.com after the event. So let's jump into the most interesting stuff. Let's talk about new software features. And this is probably a surprise for you, because first and biggest feature that we want to introduce is a new protocol, Router Management Overlay Network, so ROMA. So have you any ideas what's that? I know that everyone accepted RotorS version 7, but... So basically, it works similarly to neighbor discovery, but it works over multiple hops. So it's a secure level 2 style access to all MikroTik devices with a physical connection through a layer 2 tunnel. So idea is very simple network, which is complicated structure. You just need to connect to one of those points into that network. If that network has Roman enabled, you can manage all the devices in that network remotely. You don't have to be physically in that network. So it's much easier to do, so you can discover, manage, upgrade the entire network with this tool. And if you want a simple catchphrase, then basically it's a Mac Winbox, SSH, and ping on steroids. So you can now much more easier manage remote networks, entire remote networks. You don't have to remember to connect to one device through another, through another, through another. You can now enable Roman on that network and have all at your disposal over there. So basically this feature will be available in one of the release versions of version 6, maybe even next. It depends on our testing progress. But in one of the next versions, you will be available to test our first releases of this protocol and suggest features, report some bugs or something. So basically, it's already almost here. So it should make much more easier life for all our consultants, trainers, and everyone who's doing remote management of the network. So, of course, to introduce this new protocol, we will also, we had to upgrade our Winbox tool. So Winbox version 3 is slowly coming. Some of you might maybe already used RC version. So all of you will have to use this RC version because you just got Hoplite. And, or sorry, but Hoplite only works with Winbox 3. So, and soon this Roman protocol will be introduced in the Winbox 3, so you will be able to do everything from one tool. So right now, the new features in Winbox 3, you can save, load, move the whole lists of devices. You can finally save Windows layout on each of your Winbox. So if you like that when you open the Winbox, there's 4 or 5 windows like interface stats, link status, connection with table stats, and so on. You can now create a view, save it, and open your each Winbox with that view. So that's Winbox version 3. Okay, let's move to the hardware part, recently introduced. So everyone who got the bag, who registered, got a Hoplite. So it's our very affordable home access point. So HAP stands for Home Access Point. It has full rotor-S functionality, dual chain, 2.4 GHz, 802.11n wireless card, 4 fast internets, 650 MHz CPU, and it's powered from 5 volts or USB. So you can connect it to your PC through USB cable and it will be well powered. And the best thing is price. So finally you can you can take on all those usual home access points that have the same price range, but this time you can offer the full rotor-S feature set in return. So it should be a very nice product to fight in that market. So we were very surprised at the beginning when we introduced CCR series that many wanted to use this CCR at home or at office or near the place they operate. So they really wanted to get a silent mode without any fans and so on. So we had to make one. So this is CCR 9-core passive cooling. So basically it's completely silent It has 8 gigabit Ethernets, one SFP and one SFP+. So basically similar to the previous model, with only exception by default, it's only 1 gigahertz, but it's overclockable if you need it, but it will of course get hotter a little bit, but you can always access to all the frequencies that's available on previous models also. So it was introduced some time ago. The next thing is PowerBox. So basically everyone liked our product 7050 UP. That's already for a few years around. But everyone wanted to put it outside to power other devices, so we introduced outdoor box of the same, basically 750 UP, only this time it's without USB, because usually outside you don't need USB. So this goes 1 PoE in and 4 PoE out. Same feature set as a 750 UP that you might already have. So a little bit more powerful CPU only. So it's waterproof and all mountable. Also, we slowly are building our selection of SFP and SFP Plus modules to have a full set that's necessary to our clients. So if you're still missing some specific modules offered by MikroTik, you need to let us know, because the only way we know that you need it is if you write us. So there was big demand on this type of modules, so it's a bidirectional 10G module kit. So it comes in a kit of 2 modules, and it's up to 10 kilometers if necessary. Okay, the most important part of presentation. New products. So, what do you want to see? So, no suggestion? Yes? So, PONs. 72 core CCR. Okay, anyone else? Okay, so I hear that there's many different products that you're waiting from us. Okay, let's start. So, as HAP Lite already suggested, there will be a regular model also, so HAP. So basically it's an upgrade for our 951.2N. It has dual chain 2.4 GHz N card, 5 fast Ethernets, 650 MHz CPU, 300 MHz DDR2, 1 PoE in and 1 PoE out on port 5. So and it will be only $45 list price. Then, of course, we will have AC products. So our first dual concurrent home access point. So it has dual chain 2.4 GHz N and 1 chain 5 GHz AC. It has 5 fast Ethernets, 650 MHz CPU, 300 MHz DDR2, PoE in and PoE out, and it's in the small form factors similar to the HAP and HAP Lite.
Those are 2 different wireless cards inside?
Yes, dual concurrent, so you will have both 2.4 and 5 GHz access points at the same time. Okay, if already for that, you notice that this is HAP AC Lite, yes? HAP AC. So the all information that we are ready to announce is here. So if the price is not here, we are not ready to announce it yet. But it will be as usually as good as possible, so don't worry about that. So first gigabit dual concurrent home access point. So 2-chain 2.4 gigahertz, so high power 2-chain 2.4 gigahertz N, and 3-chain 5 gigahertz AC, also high power. It will have 5 gigabit Ethernets, one SFP cage, 720 megahertz CPU, DDR2, one PoE in and one PoE out. So basically you already can see that some of the features are consistent through all the home access point line, so we are trying to make it that way. So this will be our most powerful, at this moment, home access point, dual concurrent home access point. And it will be available, as you can see, in the first quarter, and so on. So, next one. We got some feedback from you from our CRS products, so our cloud router switches, and some guys suggested that they need a little bit more SFP cages with 8 Ethernets, so here you go. So CCR 112, 8 gigabit ports, 4 SFP ports in an indoor box, so one of them to make our CRS line more complete, and it will be available basically in second quarter. Next one, Mini PCI Express card, 5 gigahertz triple chain AC. So basically, now you can upgrade all the existing Mini PCI Express cards to this new 802.11 AC standard. So, next, I heard this one was expected. So QRT5, basically exactly the same as QRT5 that you already have, but with addition of 802.11 AC. So, of course, inside there is improved design of antenna, and basically it's just an easy upgrade for you, because from installation point of view, and nothing really changes. It's the same principles as QRT5 that you already seen before. And you can see that it's already Q2, and you see that we're already ready to announce the price. So 179 list price. Next thing, High Gain 5 also will be upgraded to IC. So this device also have new 720 MHz CPU, DDR2, and is 17 dBi. So also not much changes from the outside. It's the same design, same principles as A60 High Gain 5 previous model, but this time it comes with AC. And the next one, so upgrade for our 2011 series, 3011. And you can welcome us to our first 1.2 GHz ARM CPU. So RouterOS gone ARM finally. Many of you already proposed that it should be a good idea some years ago. So we are ready to announce that yes, we will have a router board on ARM technology. So basically, performance-wise, it will be more than 2 times more faster or higher throughput than current 2011. Also, if in 2011 you had 5 gigabit Ethernets and 5 100 megabit Ethernets, then here you will have 10 1 gig Ethernets, so all 10 ports will be the same speed. And also you will have 1 SFP port, which I forgot to write here. So SFP port stays, so don't worry about that. Also there will be regular USB 3, and currently we are ready to announce rack mount and indoor access point versions. Board will have a mini PCI slot, Yeah, sorry, SFP port is over there. So, basically, also, nothing really changes. The looks are almost the same. And we are also ready to announce the prices for rack mount version is $179, and indoor access point version that will come in with the mini PCI card, dual chain N card, it's $199. So it's easy way to upgrade your current installations that uses to 2011 to more powerful 3011. So, next little things that we try to work on. So, some of you guys also suggested they can't find really easy solution for SSD mounting. We have a quick mount series coming. So currently we are ready to show you two modules, two devices that we are working on. So basically you will be able to mount two SSD units, for example, for repeater setup. And there will be Pro model that allows you precise alignment of SXTs. So you will be able to buy these together with SXTs in Q3, according to our plan so far. Then we have new series coming. Nobody has seen this before. It's 802.11ac outdoor device. It's called Dynatic 5. So it's ideal for long distance point-to-point links. So 5 GHz dual chain board with 23 dBi dish that has 8-degree beam width. So again, 720 MHz CPU, 300 MHz DDR2, and 1 gigabit Ethernet port. It will be only $179, and it will look something like this. So, thank you for coming for first presentation, and enjoy the rest of the presentation, and enjoy the mom. Thank you.
So we're ready for our next presentation. It will be about Capsman from MikroTik from Sweden. Okay, enjoy it.
Good morning, everyone. Are you everyone awake? I don't hear you. Come on. It's marvelous to see so many coming here. This is actually, as I said before, the 10th European month. And from the beginning it was a small event, and now let's look at yourself. Marvelous. Okay, I'm going to have a small presentation about Caps Manager. And the thing is with this, it's been announced before, it's 1-year-old feature, but still, I haven't seen it being done live, and that's what we're going to do. So, who I am? Yeah, I have a family, 2 kids, beekeeping as hobby, but that's not why I'm here. Why I'm here is because I'm a consultant. I was on the first training course in Poland with the certificate of 003 as a trainer, and I'm here as a 10-year anniversary as distributor for MikroTik. The objects for this is to give you a view of how you put MikroTik Caps Manager up and running. It's not that complicated, it's rather easy. Both layer 2 and layer 3 are routed, so you could have, for instance, a sub-office that you want to be surfing on the same network and have to get that one up and running. And this is going to be a live lab here, so I'm going to do some configurations, and you see as I'm building it up from scratch. As it is for the moment, I don't even have DHCP to my laptop yet. So we're starting from real bottom and bring it up from scratch. Are you ready for that? How many is using Caps Manager already? Okay, I could go directly. So, Caps Manager features. Let's start up with that. It's the central management of access points. It provisions all your access points, so you don't need to do all the work on each one. MAC and IP layer communications directly locally or routed through the network internet. Certificate support, and that's what we're actually going to pull up for this lab also. Full and local forwarding, so you could have all traffic going to the Caps Manager and then third route on the internet. So you bring them together in one network. Or you're in the sub-office, you drop it off on the local network to have your internet connectivity locally and not through the head office. Radius MAC authentication, as on all access points, we have the same feature built into the Caps Manager. And you can do some extra custom configuration if you want to. It also supports dual band access points in provisioning. In Capsman 2, that's the one we're going to be running. You have automatic upgrade of the CAP clients, so you could get all the access point upgraded directly from your CAPS manager instead of you going around doing it manually. Saves you a lot of headache. One of my access points is not upgraded, and one is actually upgraded a little bit too far. It's a better protocol. It works faster in updating. We have the name format. We could put in a prefix for instance, 2.4 access points or 5 gigahertz access points, so you see directly in the interface list which one is actually running. And you could also see much easier when the client is roaming from one access point to the other one inside directly in the log. It also finds out the layer 2 MAC level MTU, because the thing is, if you route it through the internet, you're not 100% sure what MTU is actually on the link. It could be over a PPTP, it could be on any kind of network. So this slide, I just put it here so you have it as a note later on. How to upgrade from CAPS Manager to 1 to 2. The problem is CAPS Manager 2 and 1 is not compatible at all with each other. So if you have a client that's running version 1, it's not going to connect to version 2, vice versa. There's two ways to do it. Either you pull in a new CAPS Manager with the new version on it and upgrade one by one of the clients. Or you upload all the files to the client, put in a script, and schedule the reboot. Once the reboot is done, you're going to be running CAPS Manager 2 on the clients. Then you could go back to your head-end CAPS Manager, start up the configuration there, or actually just plug in CAPS Manager 2, reboot at the same time. You can have very short outage of service. So to prepare for the CAPS Manager, we need to do some things. We need to have the IP setup done. We need to make the bridge for the interfaces, IP on the bridge, DHCP server for the client, and preferably also for your CAPS. And you also need to be running 6.11 or later. Now is when I'm switching down to what's on the table here and running it locally. So give me just a couple of seconds. You see the same as me? Yeah. We are now in our CAPS Manager. That's not configured at all. That's why I'm actually also communicating for the moment on the Mac level, as my laptop doesn't even have an IP for the moment, because that part is not done. So the first thing I'm going to do is bring up a bridge where I'm actually going to have administrative accounts for our technicians on the access point. So I've been running double SSID, one for the technicians and one for normal guests. So I start out by building the two bridges. One that's going to be for the technician network, and the other one is going to be for guests. So we bring up the tech one, and that's the technician one. I'm going to add the port that's actually the master port of my CRS down on the table here to that bridge one. That gives me two benefits. As later on when I'm connected to that engineering network, I'm going to be able to see all my CAPs because they're going to come in on the same interface. Because otherwise, in CAPS Manager, you're isolating your network so you don't see the physical interfaces or the physical access points. So let's bring an IP on that interface. It's actually already there, but we don't have a DHCP server. Makes it much easier for me to run. Take it down to a little bit lower release time. Now my computer should start getting an IP at least. One of my access points have already got its IP. And I'm now connected with IP instead. Second of all, we go to the next part. We bring up a new bridge. This is just going to be for the clients, our guest network. So just put a name onto it and you put it as guest mum. I don't have internet connectivity to my router, so I'm not going to have internet on this access point for the moment. We put an IP on this one too. Preferably something else than we had on the other one. So 10.20.1.24. This is going to be the IPs for my clients connected to the guest network later on. We do the same thing here. We put a DHCP server on it. Just run the guide quickly. As it's going to be a guest network, I think we should put it down to about 20 minutes lease time, so we save our IP addresses. Now the basic IP setups are done. That needs to be done for every client later on. So let's go in and start doing the CAPS manager. This is actually the time we're going to be a little bit Arabic. We're going to read from the right to the left, because that's actually the way you put it up, because then everything's going to come together in the end. Registration table, that's where we're going to have our clients later on. Radio is where we're going to find all our radio interfaces, all the information about them. Remote cap is also going to show you exactly what caps are actually connected to the system. Their software version, their ID, and everything is going to come up. But let's start up with the roaming part and put in 2 access list rules. And these ones are going to be done on the signal level version. Because the thing is, we don't want to have 2 weak clients coming in on the caps. It's better than starting to roam to another one or trying to go to another access point in your network, especially if you have a big network with plus 50 access points. So we make first an accept rule. That's going to cover down to -80 in signal strength and up to 120. And that's just an accept rule. I forgot to put in accept actually. There, we're accepting those clients. Next rule we're going to put in is -81 as maximum, and this is going to be a react instead. When the clients comes in or become too weak, you're going to see in the log 2 weak signal. It actually tells you that in the log directly, nice and easy. If there is any questions, just put up your hand, okay? Now let's go for the security. As the tech network, we want to have an encrypted network. You don't want to have your clients be able to go into that one. So I'm going to go for WPA2, an AES encryption. And let's take tech mum 2015. Now we have then the security configuration for our technicians. It's not for our main clients in our end. And we do a guest one. And that one is just going to be an open network, so we don't need to put any information in at all. We just run it as it is. Now it comes to the data path. Same thing here, we want to have a tech data path, because that one is going to be connected to that tech bridge that we created earlier. So we have that IP addresses for all our cabs, we have that addresses for all our clients coming in on that network. We put it into the bridge tech. We don't need to do anything else in this case, because we don't want to isolate client-to-client communication here. We don't want to isolate in between different access points and so on, because this is our technician network. We go to the guest network. Here, of course, we need to put it into the bridge that we created. That's the guest network. We're going to add bridge horizon to it. With the trick, which was just put in a number here, you're going to isolate traffic from one access point to the other access point. And then on the client side, you could also limit down so the clients are not having client-to-client communication on the access point. This way, they're only going to get internet straight through, and they're not going to have their broadcast traffic going over the network over the other access points. It's only going to be local traffic straight to the internet. And client-to-client, here's where we actually decide if the clients are able to talk to each other or not. And we don't want them to do that. Now we come to the next thing. Actually, another presentation later on today going to show you this a little bit more exact. But we have 3 working channels on 2.4. It's 2412 is one of them, 37 and 62. So let's bring these ones up now. We're going to use them later on to actually spread out our access points that we're going to put here. So when we make the channels, and it doesn't make sense to do this if you just have 3 or 2 access points. But when you have 50 of them, it's very easy to just drop down and change. So we put in the name, same as the frequency. We have a 20 megahertz channel. We say BGN. And we disable the extension channel. Otherwise, you're not going to be able to run 3 access points in the same space. We put down that we want to have a TH power of 20. Later on, when we go into the client's caps, we're going to show exactly where small things you need to do to actually end it up as 20 when you use it. So we do the same thing with 2437. BGN mode, disable, and 20 dBm is TX power. And we do the same thing. $62, 20 BDN mode. I don't have any dual band ones here. It didn't give me one of these nice new things. Now I have the 3 channels configured that we're going to be able to use later on when the interfaces are running. Now we're going to combine all these settings that we already done into some configurations. One for the technicians and one for the guest network. We start with the guest network. It's going to be in access point mode. And in this case, I'm going to put it into MUM 2015-guest test. This is just a test network, so you're going to later on be able to see it. I didn't find Czech Republic in the regulatory domain listing. Is it just me that's looking wrong? No? So we put it into Sweden. It's the same regulatory domain. What was it? I start with C. There it is, yeah. Thank you. We don't need to do anything else on this one. We don't do any channels for the moment, because we do that later on when the interfaces are showing up in the Caps Manager. But we need, of course, to put in a data path. And this place is going to be guest, and we put in the guest as security setting also. That's the master configuration for the guest network. And we do the same thing with tech network. That would be in Arabic again. So we go security tech, data path, tech, channels, we didn't do anything. Here we are. And Czech Republic. There it is. No. There it is. Access point, SSID, tech network. This is the configurations that are provisioned out by the Caps Manager once we've done the provisioning in settings. Let's go to provisioning, because that's the next part we want to do. We don't want to go in and configure each client cap. We want that to be done automatically on the fly. You just plug them in and everything is good. So we start with putting in a bunch of zeros as MAC address, because we want this one to hit all caps coming in. Except that in this case I want to have them as GN support. This is what I have here. If I would come with an AC card, I would put in a configuration that's going to look for AC cards. If it has AC cards, I'll do the settings for AC. Because what I'm also doing down here later on is we create them enabled. We have the guest network as the first configuration. I actually missed to put the name on the second configuration here. So let's do that. So it becomes a little bit more visible for us, what we're doing. We have the tech network, we put in that one as master in this case. And then we have the slave configuration that's going to be the guest. And then we have a small setting that's the name format. How we want these names of the interfaces to come up. And I want to have a prefix, and then on top of that, the identity of my access points. This could be next to door number what in a hotel. It could be access point 1, 2, 3, whatever. But that's you decide. Put that name in, and you're easy to find them later on when you troubleshoot. At this point, I'm putting in 2.4 gigahertz hyphen. This is the prefix I'm putting in, and this is going to be the name of all the interfaces later on. Now we need to turn off the Caps Manager. By default, it's not turned on. So we go in and enable our Caps Manager. Tick it in, enable. Certificate, we put them into Outlook. Because we're actually going to run the certificates here now. So you see that I actually managed to do everything for you. I put in a folder on my machine called Caps with files for other types of clients. Because if the clients are running the same architecture as you are running on your master, they're going to be upgraded directly from the master without the installation files. But if you, for instance, in my case here, have a PowerPC, or you have a HAP here, like for instance, that's running on a different architecture, you need to have the upgrade files locally on the machine. So in this case, I've made a folder called Caps, and in that one, I'm putting the upgrade files for those systems. And I'm requiring the same version. This is the way you get Caps Manager to upgrade all your clients in one go. Just do apply here and give it a couple of seconds. You can see there's the first certificate coming in. And there's another one. Now everything on our controller is done. You do this setup once, or when you do any changes. So just minimize this one for the moment and go into the first access point. This is my access point client. And as the ones looking a little bit extra, you see that it's 6.28 RC12. This is me doing just because I want to show a certain thing. So I actually went a little bit further with this one. We go to wireless on it. As you see, the wireless card is disabled. I'm going to advanced mode and put it into Czech Republic. Register domain. The thing here is, once this done, and you put in the antenna gain that you have on this radio, then CAPS Manager is actually pulling that information. So if you have a 14 dBi antenna, 10 dBi or 7 or whatever, it's going to be calculated in so you have the output power out to 20 dBm. And it's going to be done by the CAPS Manager. But you need to do this setting on each client because CAPS Manager can't know up front what antenna you are using or what antenna array you're using. In this case, normal 2.4 antenna. If it's an external antenna, it would be about 7 dBi, so I'm putting that one in. And now we go to CAPS, because here's where we have the client part to actually connect to the CAPS Manager. We need to enable it, of course. We're telling to the CAPS Manager what radio card are you allowed to run. In this case, there's only one in the unit, so it's going to be a wireless LAN 1. I'm going to request a certificate to actually be using certificates in between the CAPS and the CAPS Manager. This doesn't mean that the traffic itself is encrypted, the data load. That needs to be secured by other means, for instance IPsec or whatever. At least it's securing the communication in between the two units. And I'm going to tell the unit what interface is actually facing towards the CAPS Manager. Now I need to check. It's number 1 in this case. I could also put in log to CAPS Manager. In that case, it's going to use the certificate that it gets from the CAPS Manager and lock down to that one. So you never can be able to change the CAPS Manager. You can't have a rogue CAPS Manager coming into the network. We're not doing that for the moment. And we just do apply. Give it a couple of seconds. Yeah, it is enabled. You don't need to enable the wireless interface, actually, because CAPS Manager is taking over that. Doesn't matter in this case. It's my certificate that's become wrong. Thanks, server is wrong. Just for the sake of the lab. No, we do it like this instead. I need to clear the logs of my old security. There is an old certificate that's sitting there that didn't clear out as it should. Now you should actually see both the SSIDs coming out of this one. But as you see, it still runs 28 RC12. If we go in and look in the log, it's actually going to say that it's okay because of that it's a newer version than it had in the first one. So it says it's same or newer. It doesn't do a downgrade for you. It only stays on the same version in this case. So the access point 1 is done. Don't be scared by it says that it's grayed down here. The only reason for that is that it's not a local forwarding. All the traffic goes directly to the CAPS manager, and the SSIDs are up and running. And if you do connect to these ones, you would get the DHCP directly from my server. So now let's go to CAPS manager client number 2. And as you see, there's not an IP there. So we connect directly on the MAC address. Same thing here, the interface is disabled. So let's go to here. We go to advanced mode, put in Czech Republic. We go to the cap. All of you remember that we don't have an IP here now. You did that? Did you see that? So we just do like this, interface. And then this one is actually number 2. There's still no IP on the cap. But as you see here now, it's starting to download something because it says here 3 megabit of traffic. So let's see what this is. We go to our manager. We go into the log. And it says, should upgrade. Ask to upgrade to 627. It's rebooting. The upgrade is done directly to that unit now. It didn't have an IP. It didn't get an IP, and it was not supposed to do that in this lab, but it still did the upgrade. And the one that's sitting here in front probably heard a small beep here. We see the first 2 interfaces from the first one, and here now access point 2 is coming also. You get the prefix for 2.4 gigahertz, access point 1, and then we have access point 2 here. Now I have an extra access point here. This one is running, sitting behind one of my access points. It's going to be running routed in. And to do this a little bit more interesting, I'm actually going to do this with OSPF. So we do routing. We do OSPF. So we need to add at least the network for the interfaces that we're having here. And that was 10, 10, 10, 0/24. We just add that to the backbone. You see here, disconnected registered to other interface. But someone is connecting here, so they're moving in between. We go to access point 1. This is the one actually having an interface facing towards my extra access point. Let's check first what networks is here. It's 1050.01. This one is actually running a DHCP server, so I know that my client sitting behind it is having an IP. We go to networks. We put in the 10 series network here. To the backbone. And we add the 1050 0/there /30. There's a 0 that disappeared. There it is. If I now look into my controller, I should have got that IP coming in. Yes, we have communication to our extra access point. So let's go into that one. 1050.0.2. This is my extra access point. This is small MAP. So let's do the same thing here. We just go in, we go to the wireless, advanced mode, Czech Republic. So we follow the regulations in this country at least. Or at least try. I don't know if everything is going to work. We go to the cab. And here instead we have our wireless LAN interface. And we don't put it in a Discover interface. It's not directly connected, so we need to route it. So instead we're going to put in the IP that the controller is having. And apply. Here is the last interface is coming up. So now we have 3 access points. Let's go in here, Caps Manager. You see all the 3 access points here? The only problem is we're not controlling for the moment what frequency they are. So we can't guarantee that they're not overlapping frequencies. Now that comes in those 3 channels I made earlier. We tap in to the first interface. We change it to 2412, channel 1. Let's go to access point 2, 6, 37, and then we go to 62. Now we have locked down these ones for 3 different frequencies. If this would be a very big installation, for instance, you would have a lot of these access points, so then you needed to do this on a lot of interfaces. And it takes longer time to type in all the settings here in the frequency setting of the interface than just do it directly on the channel. You just choose the channel. Yes, you are. You could use the outer channel. The problem is that you can't guarantee it's going to be correct answers, even if they have the outer channel. If you don't put in the frequency, either here or on the channel, it's going to do an outer channeling by default if you don't put anything in. Yep, with the scan list. Scan list is done on the clients. So it's using the standard scan list. If we now look into our Caps Manager, there it is. We go to Remote Cap. You see that you have 627 on 2 of them and 28 RC12. And the RC12 is because it's not downgrading, it's only upgrading. This was a very small installation. I have a small, on my presentation here, we have a small installation in Sweden. Can you see in the bottom what it says down there? It is 236 virtual interfaces running. This is running on a 1009 controller. It's in a hotel. They have more than 50 access points, and they have peaked over 800 clients online. And we've never seen more load on this system than about 2 to 3%. But they have a gigabit fiber coming in. Any questions? It can't be that good, so there's no questions. That's the microphone coming.
How can I use AAA configuration in Subsman interface side in Vbox?
What did you say?
AAA configuration in the interfaces under Subsman on Vbox. How can I use it?
First of all, you need to configure this part here in AAA. You need to put in the radius client also. It's the wrong. Thanks. First you go to AAA here and do the configuration part here, exactly as you would do on a normal access point. There's no difference at all. Where's the radio server? There it is. And then after that, you need to configure radios. And it should be wireless here. Okay. Correct me if I'm wrong with this.
Okay, so there is no possibility to configure use radios to count set.
Count what?
APs.
No, not to count the APs itself. That's not done by the radios. Okay. Because for the radio server, the only thing you're going to see is the caps manager. You're not going to see each individual access point from a radius part scene.
Understood. Thanks.
You're welcome. There's one more here. We should have had 2 microphones. Or you get a lot of exercise. I maybe should do that myself. It's on?
Yeah. I got a question, and it's about virtual interfaces or virtual access points and local forwarding. It's not possible with automatic bridges?
Yes, it is.
It is?
Yeah. Because if you have local forwarding, let's go into a client here.
I got a problem because they always get a new name, and I can't put it.
The thing is, if you create them static, as I'm doing here, just create enable, not dynamic enable. They're not changing name. So I think that's the answer to your question.
Okay, I think so. Have to try.
Oh, that was one in the behind there.
Hi.
Hi.
I was wondering why should we use this Castman instead of API that MikroTik has already?
What did you say?
API. MikroTik has API, so we can control every access point on network with API.
Yeah, but the thing is with this is when you want to put in a new SSID, going to put in a new encryption key, you do it in one place. That's why you do this. And it goes directly. It's an instant on all access point in one click. You just put in a new passphrase in the security configuration, done. And that's what we want.
Okay.
Yeah, and you have one place to monitor the clients. That was coming here in the front. You just go to the registration table, and there is clients on it, at least it was, yeah. So far I've had 5 clients online on mine.
Another question.
Yes?
There is impossible to config Craftsman like cluster or HA?
Not really, but you could have more than one capsman running on a network, so if one of them goes down and it has the same configuration, it's going to take over.
Yeah, but
in that case you would run it as dynamic interfaces, because if you lose the main one, you don't want to have one that's coming all the time.
Okay, but both of the capsman have to have the same configuration. Yeah?
Yes.
There is some impossible to push that configuration on the both of capsman.
No, but what you do is you do an export of the first one and cut and paste into the other one, and import it. That's the fastest way to do it, at least. Was a lot of questions. I must have done a bad presentation here.
Is there a way to get Capsman to create the VLANs as well?
Yes, there is.
On the Ethernet interface, though.
Yeah. What you do is that in the data path setting, as we showed, but you have in the bottom here, you have VLAN mode.
Isn't that only on the wireless interface?
No, it's also on the interface itself. You have it also in the setting for the client. If you go into the client, oh no, I didn't have the client up here. Let's go to the client. Now use it on the bridge there. But it's not VLAN tagged, if I'm correct, out. It's going to come directly on the local forwarding. It's going to come VLAN tagged on the local.
So far, all I've tested doesn't get it. I will try again.
I think you're running version 1.
No, version 2.
Is that correct, Ulrich? We were discussing that earlier if it was working as it should, but I don't think it is.
Actually, if you're using local forwarding, first you do in the caps manager add that VLAN mode on which AP you assign that VLAN. Then that VLAN is tagged into that AP, but you need to add a VLAN interface on the Ethernet side where your capsman is located. Currently, there's no way around it at the moment.
I think that was the problem you had, wasn't it? Yeah. Answer from the right guy directly.
Hi.
Hi.
Is there any way to push a default configuration to the cap with Capsman or with the DHCP server on the Capsman?
No, not in this way. What you do is you use FlashFig for all your clients that are going to use.
Okay, but it wouldn't run automatically.
No, and you just do that and enable the Capsman setting, and then the rest is done by the Caps manager. You don't need any, as you saw here, you don't even need an IP. You just get it to actually say, this is the VLANs that's going to be running, and this is the discovery interface. That's more or less the only thing that needs to be done on the client side.
Okay, thank you.
Theoretically, if you have like board cap button, for example, MAB, you can hold it when you boot, and there's some specific seconds. When you release it, it will get cap mode. So you don't even need to log into the router.
That feature I haven't tried, so I'll need to try that later on.
Hello, let me ask you please 2 questions.
Yeah.
Maybe I missed it in your presentation. Is there any limit of the maximum access points managed by one capsman? And if yes, is there any system of centralized management of many capsmans if I exceed this limit? Thank you.
There is no limit, only the hardware, how many APs you can put. You have seen more than I think 500 or 800 caps connected, managed by capsman.
That was the question answered directly. I think that's it. Now there's one more here in the front. And then we'll draw the line, I think.
Hi.
That was 2 in the front.
Hi, my question is regarding the channel selection. You said that the actual AP is scanning its neighborhood for free channels.
Yeah.
But actually, is it possible or is it configurable that the capsman collects this information and selects the right channels or the best channels for the particular APs?
For the moment there is none, but we could maybe discuss with the MikroTik guys to implement it.
Thank you.
That was the last one.
Hi. How does Capsman influence or help with roaming?
The main thing is, it's actually in this case we're kicking them out on a certain frequency. But the thing is, what I've noticed so far, it makes it much easier for the clients to move from one access point to another one, because the traffic is coming in a different way. So the switches in between is not doing a problem with the packages. But it's actually, in this case, I'm just kicking it out. Exactly how they are doing it, I can't, that's Ulrich better to answer that question.
It's a secret, but basically all the roaming depends on the client. If it's Windows, Apple, or some Linux box, all the roaming settings are usually in the client. Some roaming aggressiveness, if you should stay the most time on the same AP or roam to some different AP, faster or not. So basically it's all done on the client side. Of course, not every driver or Apple will allow to choose that setting, but usually it's done so.
Okay, that's thanks for me, and enjoy the rest of the month.
Our next presentation will be from Tom Smith. He'll just set it up.
1, 2, 1, 2. Yeah, thanks. Alright guys, if you grab a seat there, we'll start. Can you all hear me okay? Cool. So, my name is Tom Smith. I'm from a company called Wireless Connect in Ireland. We operate a small ISP in the Midlands, and we also provide extensive consulting services to clients from service providers, financial institutions and stuff like that regarding network security and bespoke solutions. I suppose why I'm here is I suppose I was inspired by others who lead the charge, so their names there, and I suppose I've often found when I started in the MikroTik community that the videos were quite helpful in actually setting up my own ISP when I knew pretty much nothing about MikroTik, so that's why I'm here. I'm a trainer since 2007, and I'm pretty much passionate. I quite like MikroTik root OS a lot, and I suppose it's like a relationship with a girlfriend. Sometimes we argue, but there is a lot of love there. But and I do like exchanging ideas and talking about problems on networks and solutions, of course, for them. So if you catch me on the floor later or possibly at the bar, I'd be happy to have a chat with you later. So basically our company's been with MikroTik since 2006, and I've presented about 11 presentations so far in all the months in various locations around the world. So our favourite routing product, just to start off, would be kind of an x86 router with running MikroTik root OS, and I particularly like it with the hot lava cards because you get the 10 gig. So we find the performance on them quite good. Obviously, the cost is significantly higher than the cloud course, but we feel that with the performance, it's actually quite good as well. So what are my presentation objectives? So it's kind of along the theme if you've been tracking some of my presentations around the world. It's about BGP and denial of service. My good friend Matthew Chianter will be doing a similar presentation later, and I'm looking forward to the exchange of ideas and learning stuff from him because he's a great guy. I was in training with him back in 2007, so I'm really looking forward to that presentation. I also think the topic is quite expansive, and it's actually a huge area. There's lots of different nuances, and every time I have to deal with an attack, I always have to learn something new, you know, and it's always a continuous learning process and refinement in your technique. So basically, we use MikroTik if we can route, or if MikroTik can do it, we generally use it. So we use MikroTik extensively as a routing platform, full route tables, over 60 peers, redundant route reflectors, using eBGP with around 60 upstream peers, so and 2 transit providers. So it's a very capable platform, and it can scale to that, and it delivers it at a significant cost reduction when you compare it with the, let's say, the bigger incumbent hardware providers on networking in general. So BGP in brief, why am I talking about BGP? Because BGP is, I suppose it's a protocol that links the internet together, but it also allows for signaling. It allows ISPs give each other information about specific routes. So it's not just about saying this route is reachable via me, but it's showing you how the traffic actually arrived at your location, what's the nature of the traffic. If you have, let's say, peering with a TRAT or like supported, they actually send communities based on IP of the traffic, or the source country, so you can actually get information about where traffic is coming from or where prefixes are coming from. And it's precisely because of this signaling capability is why BGP is so useful in both, obviously, propagating the internet tables, but also in propagating responses to denial of service attacks. And we'll be discussing that in some detail today, and I'm sure Matthew will be following up later on as well, and I'm really looking forward to his presentation. Just under the bonnet of BGP, just to briefly, I'm not going to go into too much detail, but it uses TCP, Transport Protocol, for the communication of messages, because the sessions stay up for quite some time, and obviously it's important that if routes are withdrawn or updated or added, that the message between the two routers that are talking, the message actually gets there, so that there's not black holing of routes or slowdowns in conversions or inconsistent conversions in the tables. So, denial of service attacks, I'm sure you've all probably had one or two of them in your time, and it's not a pleasant experience, and generally there's different modes. The one we're going to actually talk about today is pretty much network denial of service attacks, so kind of saturation of resources on your upstream provider links, saturation of CPU resources on your core routers, as opposed to, let's say, targeting a particular vulnerability on a website, for example. Okay, so but the attacker's objective is pretty much to either embarrass you or shut you down. Embarrassing you is probably the least of your concerns when it's happening, and obviously shutting you down. And there have been cases where sustained denial of service attacks not being properly managed have resulted in the closure of ISPs or hosted providers. So it is a significant threat, and unfortunately it's getting more and more common. So the types of denial of service attacks, you have your simple kind of single source denial of service attacks. So you've got the attack, you know roughly where it's coming from, or at least it has a consistent source. And they're probably the more easier. They can still be potent, but they're actually easier to kind of thwart, because now you know, okay, it's consistently this source address. Then we move into the distributed denial of service, and these ones tend to be obviously even more potent. They're also quite difficult. They're more difficult to kind of track down where it's coming from, and particularly, you know, you have to react quickly. And generally, the reaction, as we'll discuss later on, is the reaction is to actually take out the victim IP so that you're actually reduce the traffic. So effectively, you complete the attacker's objective momentarily, to save your other customers. So then we go for reflected application attack, and we go through these in more details. But this is where you spoof traffic against what we would call facilitators or misconfigured routers on the internet. And effectively, you would actually use their bandwidth to attack the other person. And those ones tend to be the biggest hitters, because you could actually amplify whatever the attacker is using, is effectively using each one of these people who have misconfigured their routers or their servers as a force multiplier. We'll discuss that in more detail. So what's so difficult about DDoS? The most difficult thing is there's absolutely nothing specific on your router that you can change. I will contradict this later, but there's nothing specific on your router that you can change to actually stop the DDoS. There's nothing. What you actually have to do is you have to look outside of your own ISP. You have to think outside the box and actually ask the guys above you who have better bandwidth and better capabilities to actually help you solve the problem. And that is the key, I suppose. So if you take anything, I'll leave if you want now, but if you take that as being the way you have to respond to a DDoS, that's effectively it. That you have to get help from your peers and your transit providers. Sorry. So out of the box thinking, so if we talk about that, the problem is that when the traffic arrives at your router, it's too late. You've saturated your link, the resources have been wasted, and effectively legitimate traffic has been displaced by malicious traffic. And that is the core of the problem. That's why denial of service attacks are popular with the people who use them, and are quite invasive on the people who the attacks are inflicted upon. So if we were looking at the DDoS traffic sources, generally it's infected or compromised machines. Compromised machines, say inadequate passwords on hosted systems, or basically out-of-date desktops or even Android phones or Apple phones that actually might be, believe it or not, participating in a botnet. And we're going to talk about the various different things, but the attack can last for about 5 minutes to up to a couple of days. So it's obviously you have to be very careful with that. So DDoS is used as CPEs or computers. So any device that responds to UDP with a larger message than the requester actually made can actually be used in a denial of service attack. And MikroTik CPEs, like any other make and model of CPEs, are no exception. So basically, if you have a DNS responder, if you say give me google.com or give me, you can use DNS extensions, there's actually significant, you can just send a tiny packet to the router and it will send a very large response, lots of information. So if you spoof someone's request, and we'll talk about this in a few minutes, you can actually really hammer them with this. And you probably a lot of you, because I certainly see this on my network where I may have misconfigured a router or two, and was going, where is all this upload traffic coming from? So if you're seeing large upload traffic from your routers in your ISPs, quite likely that there's a lot of misconfigured CPEs on your network. And it is quite common. I've come across at least 3 different, let's say, customers that we deal with. And in fairness, I have to hold my hand up, I got it wrong myself. So NTP is another one which was quite common. It was flagged years ago for ages, but I think it was when it was used to take out spam house for a day or something like that. It got notoriety because they managed to, I think it was something like 750 gigabits per second, they managed to amount in the denial of service attack, which is a truly frightening number. So DDoS using misconfigured servers. You've got various different ones. You've got DNS, NTP, SNMP. So all those ones obviously are feature sets in MikroTik that can actually be misused to attack you or just other people on the internet. So what services are most in this? Well, attackers love using DNS, NTP, and SNMP for reflection attacks. And the reason is they use UDP. So UDP is the connection-oriented protocol. You can basically send it, forget it, and you can, like a mortgage application form, you can lie about the source IP address or how much money you make. So it's exactly the same. You can say it was from him. I'm sending you a packet from him. Can you please tell him, send him loads of data, please? And you could do that multiple times and you can cause lots of problems. Generally, the amplification factor comes in that the difference between the size of the request going to the misconfigured server and the response from the misconfigured server. So, in terms of DNS, the types of stuff that can be used for amplification, if you look at a domain with lots of MX records, for example, or DNS extensions, get bulk requests, get net requests, or if you can imagine an SNMP query on asking for the root table on a full PHP with the full root tables will be PHP router with the full root tables. That will be a significant problem. So in NTP, you can also query the clients on some of older NTP servers. This was a case. It's not the case with OpenNTPD from the OpenBSD project, but it's obviously the other implementation of NTPD is quite common. So from this is a table of data from the US CERT team, and the key, I suppose I just want to show you what type of figures you're talking about. So if you look at DNS, the amplification factor of an attack is anywhere between 28 and 54. NTP is staggeringly scary at 556, and that's why you got that nice large figure hitting spam house who do an excellent job of controlling spam on the internet today. And then obviously you've got Cargen, which is basically 358. So thankfully Cargen is not, it's kind of more of a legacy thing. It's generally turned off on most modern Unix systems or network operated systems. So that's the key thing. So if we look at how the reflected application will work, you can see there that you've got your misconfigured open resolvers. What do I mean by an open resolver? It means that potentially your MikroTik CPE is listening for DNS requests on the internet interface. Okay? So rather than, obviously you set up DNS to forwarder on your MikroTik CPE to provide local DNS proxy and caching for the user. You don't do it for the rest of the internet. So if you do allow the requests in, what will actually happen is effectively you'll become a facilitator, an open resolver. And what you'll also find is after a while, you'll start to see that that client will have a significant upload problem as opposed to what he's downloading. And the reason is he's getting lots of spoof traffic and he's participating unwittingly in a denial of service attack on the destination for all those responses. And that's effectively what is happening. So what we see here is obviously on the bottom left-hand corner, you have a compromised host, and he's generating about 500 megs of spoofed requests. Okay, so he's sending it to a load of resolvers around the internet, and effectively he's saying, give it to Arnis over there. So he's using Arnis's IP, and he's actually saying, Arnis wants to know this from all of you guys. And then all of the open resolvers basically dutifully respond to what they think is Arnis's genuine request, and Arnis gets absolutely clobbered at a kind of pace of basically a factor of 54 times whatever was spoofed from the original attacker. And what's really difficult is the attacker, Arnis, if he runs a scan and he's analysing the traffic coming to him, he actually doesn't see who his real attacker is. You know, he only sees the people who are just misconfigured. And that's the kind of the aspect of it. So it is pretty nasty. So in that case, Arnis would have been hit with something around 27 gigabits per second. If he had only a gig interface on his upstream provider, then he would be pretty much taken out. But his carriers and his carriers' carriers, so his upstream ISPs, would have been seeing something of the order of 27 gigabits per second in that case. And that's why you now start to see why the upstream ISPs become such an important player in mitigating a denial of service attack. So what can you do? Well, you can filter. So all you guys see, you can filter inbound traffic to your public-facing infrastructure, which you should be doing anyway. And generally, it's usually, a lot of people are very busy and you can make mistakes, you know, late at night. And generally that's where the misconfigurations come. But just correct them and maybe do an audit from time to time. And we'd be happy to do the audit for you. Okay, that was a shameless plug there, but anyway. So, can you all hear me okay? Okay, cool. That's cool. So basically, what MikroTik could possibly do to help, so if there was maybe some subtle changes to the operation of the device, is possibly implement a CPE mode, so where you have a default route pointing out that effectively the DNS server that the MikroTik CPE has would effectively be prevented from listening on that particular interface. So that could be particularly useful. Obviously, that has limitations that if it can only really be done in a CPE context, because if you do use MikroTik as a DNS server, and it has a default route just onto a LAN, obviously then that wouldn't work. So it's only for, let's say, CPE deployment that I would be suggesting this. But in fairness, and Yanis was at pains to mention this to me before, the default configuration out of the box does prevent this from happening. I will accept that. The only thing about it is, probably like most service providers, the first thing you do is you remove the configuration and then you apply your own template. It's just clear that it's just important for you guys to update your template so that you are actually implementing that filter. Okay. So does everyone get that? Is everyone understanding? Is the pace okay? Am I talking too fast? Sorry about that, guys. It's a habit. So what could ISPs do? So what if you're an ISP or a service provider or even a host, enterprise client to a network, you could actually protect other people's networks. This is kind of weird. BCP38 is kind of this whole pay it forward scenario. What I mean by that is, if everyone implemented BCP38, it would be a world, okay? The problem is not everyone does, because they don't know it or they don't care. So, but the key thing is, if you actually filter any traffic that leaves your network, should only have a source address of a device on your network. It's very simple. So if you have a public IP address of 1.2.3.4, you should never see, your next hop should never see traffic coming from a 10 address or from any weird IP address. And this is what actually happens, is that you have these botnets on people's PCs and effectively they generate bad spoof traffic. And if ISPs actually all just blocked that traffic out of the outbound, it would actually make a massive difference to the effectiveness of amplified attacks. So just to give you an example of how those rule sets would look, is effectively you would just simply use a forward rule in your filters, and effectively on all your outbound interfaces you would say, if it's going out on this interface, so it's going out, leaving my network, you would say only allow traffic from my IPs, and then you'd have a rule below it saying deny traffic from anywhere else. So any traffic leaving your network should only have your source address. So the slides will be uploaded later. I'm conscious of it, but I'm just hoping you got that there. So you can see there, rule number 10, I'm saying, rule number 10 in particular there is drop spoofed IP. So I'm saying if it's not from my prefix lists, please, or list of IP, assigned IP address, drop it. And then you can say, you can see where on, let's say, number 12, I've said allow our IP addresses explicitly. So that's a very simple rule set. It's not that hard on the router, on your core routers, and it actually makes a big difference to everyone else. Fortunately for you, it's not that big a deal, but if everyone did it, it'd be a lot better. So what should ISPs do to protect yourselves? Well, there are some things you should do to protect yourself. The first thing is, if you have an IP allocation of, let's say, 1.0.0/8, on any of the traffic coming in, so you have that IP address range, on any of the traffic coming in from the internet, should never have that source address, because they're yours, they're on your network. So you should actually be blocking traffic appearing to be sourced from your network coming from the internet, because that's clearly spoofed. And if it is UDP based, it will actually probably attack, it will be most likely tested to attack your NTP servers, your SNMP listeners, and it will also attack your DNS server. So it's pretty much any UDP based service. So it's important to do it. It also prevents misconfiguration where you might actually be transiting local traffic through upstream ISPs. So it prevents this from happening. So it actually is a security feature as well. So ISPs protected themselves. You can see here rule number 8 and 9. I'm saying drop traffic inbound to our network from our own IP ranges. So effectively on the in interface, which was our upstream links, basically drop it from the source address list as a list of all the IPs that I have. Okay? So let's look at BCP and illustrate it for you, kind of to show what I'm talking about. Effectively, you would implement it on your border router predominantly, or at the very minimum, that's where you should implement it. Okay? And effectively, you can see here that there's router 1 there, border router 1, and you can see we obviously have an IP allocation of 185.55.204.0/22. So what I should be doing is saying, allow traffic from my network to go out to the internet, but drop everything else. And that would actually protect the rest of the internet from any infected hosts on my network. And that's an important point. Again, you can see that the amount of protection it offers you is pretty minimal. If everyone did it, as I said, the world would be a lot better. So it's a classic pay-it-forward scheme, and as you know, we're all just selfish feckers. So we don't have that altruism that we need on the internet. So if a few, and here's the thing, it could be just a handful of large ISPs could actually ruin it for everyone else, because if they have a significant number of clients and they're not implementing BCP, so if, let's say, everyone bar 10 ISPs on the internet were actually implemented, it could still be a fairly big threat of a reflected amplification attack, because those 10 major carriers weren't doing the heavy lifting that they should be. So it's kind of like vaccination. If you want to eradicate it, everyone has to get the jab. So what's the benefits? Well, as it becomes more widely implemented, it'll actually change botnet behavior, because they'll become less reliant on reflected amplification attacks, and they'll probably evolve. But the reflected amplifications are very disruptive for amplification attacks, are very disruptive for core networks anyway. So that will be a plus in itself. And effectively, because they're less, the reason why botnets wouldn't use it as much is because effectively it's not that effective anymore for them. Malware would react, and the way they probably would react is limit the amount of the way in which they spoof. So they likely learn your IP address. So I would see that this would be probably a future trend. If you have a zombie device on your network, effectively you would look at its public IP, look up what AS is advertising that IP, and say, well, I probably can get away with spoofing anyone from these few thousand addresses. So they can still mask themselves as a source of an attack. And that's a significant issue. Luckily, there are ways around that of protecting. So if you only implement it at the border, this is a problem. However, what we can do in responding to that malware evolution is we can actually specifically start filtering on client access subnets. And what I mean by that is, you can see here I've added in a configuration built here on access router 1. And effectively what I'm saying is it has a /24 network allocated to customers. So if we actually filter the traffic coming from them, that's going up to our core network, we basically say, we've allocated this /24 network, we'll allow that traffic from this outbound, but nothing else. So again, it's just like a small... The problem with this, of course, is it's very difficult to maintain. And this is where a brilliant feature in the Linux kernel, which is called reverse path verification or reverse path forwarding, was implemented. And MikroTik brought it in, I think, around 2012, late 2012. They basically unlocked the feature for us. I appreciate the work of the guys who do this. After the presentation in New Orleans, I think was when I was suggested it. It's a really good feature. And effectively what it does is it uses the configuration you already have on your router. Obviously, if you want all your networks to work together, they have route configuration. So effectively, what it does is we actually analyze, when traffic comes in on the interface, we look, do we have a route back to the source on that interface? If it is, then it's valid. If it's not, we need to make a decision. And we'll talk about that later, where we'll actually go in more detail on this. So if you want to turn on unicast reverse path forwarding, I have to give you a health warning on multipath networks. You have to probably use loose mode more so than strict. But where you have a single path, strict is always the preferred option and far more effective. But the problem is with strict is that if you had multiple paths, possible paths through your network, it will only select the best route. So even if it was legitimate traffic coming in on the interface, it goes, this is the proper way it should be going, I'm dropping it, so it can disrupt your network. So you just have to be careful. But I have turned on loose across most of my core network routers, and it has not caused any issue whatsoever. So route traffic based on the traffic of which interface the traffic came in on. So strict URPF will basically forward packets if the source of the traffic matches the best possible route to that source. Well, let me rephrase that. It'll match if traffic comes in on a given interface, it will forward the traffic if the best possible route to that source is on that interface. If it's not on that interface, it'll actually drop it. Loose URPF will just say, does the route exist? Okay, let it on. And that's the key thing. So that's the key thing. And if the route points to a black hole, and I'll explain that concept in a couple of minutes, then it won't forward the traffic. So, pros. Well, you have full visibility. The other thing is, if you are using URPF and you're using full, you're transiting on the internet, you're better off using the full route tables because you actually get to do some sort of source validation. So you look at normally you use the default route. The problem with the default route is that effectively with unicast reverse verification, that's kind of saying everything is okay on that interface. While if you had the full route tables, the 500,000 or so prefixes on the internet, you could actually determine which ones are actually, in some way, which ones are spoofed and which ones are not. So the full route tables are the area of your network that has full route tables should never have a default route configured. And that's called the default free zone, and it's a good reason for it. And it's to allow mitigation using URPF, and that's one of the reasons for doing it. So what are the symptoms of a DDoS? Well, it's basically massive packet loss. It's usually a good one. The phone hopping is another one, and you'll see that links are fully utilised to inbound to probably, depending on the type of attack, your uplinks, your outbound traffic could be increased. That generally is only for traffic such as TCP, SID attacks, because obviously you're trying to acknowledge all these SID requests that are spoofed. So in terms of a TCP one, you would actually see a different traffic profile to, let's say, a standard UDP flood. What you'll also, so how do I protect the network? Well, do your best and hope that it will prevail over the network. And we are actually going to go through some scenarios what you can do, very practical ones, and you can do it even without that much configuration. The key thing in all this is that you have a provider that is 24/7 cover, and you have a provider who, when you ring and ask to make a change, like a black hole, you could actually just manually ask for a black hole, that they can do it immediately and not have to call an engineer and stuff like that, because at the time all that bureaucracy goes, probably the attack could have subsided. So it's important to be able to do that if you're not prepared. So if you get hit in the morning, hopefully some of these slides will actually be helpful to you. So how do I defend? Well, keep calm, work through it, and you'll be back up soon. So plan your response. The first thing it says, you need to talk to your upstream provider about capabilities. A lot of upstream providers, and it's out of self-interest, it's not just because they love you so much that they want to do this for you, but they actually want to reduce malicious traffic across their network. So if you recognize that you're being hit with malicious traffic, they're more than happy to drop it. Because whatever you're being hit with, particularly if you have a gigabit interface, that gigabit interface is the limit of what you're going to see. It could be multiple times that what the actual provider is having to deal with. And unfortunately, obviously, their hardware and their infrastructure will probably be much better able to cope with it. So prepare an incident response plan. One time with that is kind of who's in control of the situation, change control, what are you allowed to do and what not. You have to have procedures in place so that people aren't paralysed by, oh, I can't get a hold of a manager. Sometimes you just got to get rough with it, deal with it straight. And it's better ask those questions of your managers ahead of time so that you have effectively the nod to respond as appropriate when the unfortunate situation of a DDoS occurs. So identify weak points in your system, mitigate them. Okay, what I mean by that is, like, if you have a core router that's literally running at 80% capacity, you really have to look at, well, that means all they need to do is just put another 20% on and you're going to start having unhappy customers. So that's the key thing there, is to have capacity there to deal with some of these issues. And also just plan on how to deal with it. So if I look at the DDoS back, so a couple of days ago, one of our clients was actually hit with a DDoS there. So you see the background traffic of around 200 megs on this particular transit link. And we see that there's actually about 800 megs on, at a particular time in the middle. And you see a follow-on attack at the end, which actually approached maxing out the link. So, so in this case, those spikes are most certainly denial of service attacks. And if you look at the packets per second, you can get an understanding. So obviously you've got bandwidth, so what size are the packets that are hitting you as well? So you can look at the packets per second, and often a packets per second based denial of service attack mightn't generate that much actual traffic in terms of bulk, but it's actually giving your routers a significantly harder time to forward. So that one there is a key one that I would say that is a key indicator of the severity of the attack. So the monitoring tools, basically what I'd be saying is have alerts, have thresholds that if you're going at 70, if you're normally potted along at 30-40% of the link capacity, which is good practice, and then you see that you're at 60-70%, so you're just, the denial of service is just ramping up. You really want to be aware of that so that someone can actually check net flow, check torch, deal with that and actually analyze it. So there are a couple of monitoring tools there from the DUDE, obviously, which is MikroTik's monitoring platform, NetXMS, which Thomas Kernack, wherever he is, hi Tom, he suggested to me it's a great product as well, and it's free as well. So that one is the best. There's a lot of free products out there that allow you to monitor links, and then there are ones that will allow you to alert. So you send an email to your NOC or an SMS to your NOC just to say you need to get on a router, you need to check in your net flow analyzers to actually deal with it. So if I was looking at just an example of a few days ago of a couple of attacks that happened in one day, so we were just, I suppose the customer was unlucky that day. But we can see that in terms of we had a peak of about 800 megabits per second on the first attack, and about 100,000 packets per second was the hit. Then a few hours later, we had the same number of packets per second hit. You can see that they're roughly the same peaks there in attack 2 on the top graph. And it's about 100, but still this one actually managed to max out the link. And then obviously in attack 3 was a significantly different attack, and what it was for another client on the network. So what we could safely say is that attack 1 and 2 had a very similar signature in terms of packets per second and the potency or the ability of the attacker. However, attack 3, believe it or not, was much more, even though they didn't possibly reach the high bit rate on their link, they managed to push through around 460,000 packets per second above average, above normal. And so that was actually a more potent one. So there, you can see there were very different styles of attack. You can also see the response, as you can see the green traffic is actually our upload traffic on those transit links. And you can see that the traffic there dips significantly. So I'm going to just discuss that. But the reason why we look at those graphs briefly, don't dwell on it, but is that if you're finding it very difficult to find the source of attack, like you're just seeing it coming in from everywhere, or you're not sure where it's going, you can start looking at the size of the packets per second and try and understand. So if you take the packets per second that's coming in on the interface and you divide it by the bandwidth of the interface, you can actually measure the size of the packets that are in the attack, roughly speaking. And so there, I'm not going to go into too much detail for the sake of time, but it's in the slides there, but it's fairly simple. So we divided 500 megabits per second by 60,000, and we got roughly, there was a 1 that was being used in that attack. However, in the attack 3, it was a significantly different one. It was a load of small, tiny 162 byte packets. Again, this is an approximation. And the reason why it's an approximation is that I've subtracted what I think is our steady state traffic from it. But you can actually see, if we look at this one, the denial of service attack actually impacts your own normal traffic levels. So you can see in attack 2 that actually our uplink traffic increased significantly, most likely because of this TCP SIM attack against the client. While you see in attack 3, there's a significant drop off in upload. And the reason for that is it's probably just UDP. So they've effectively displaced all of our traffic. So the figures that I was quoting you there were probably the most pessimistic or optimistic about the attack, that it could have been a lot worse. But it's just to give you an idea of the ballpark you're in and then deal with it. So to remove uncertainty, if you want to actually be absolutely prepared for this eventuality, is using professional or using open source NetFlow products such as EdTop or PeakFlow, which actually do have obviously systems that you can use to actually automatically mitigate denial of service attacks as they happen. So MikroTik implements NetFlow, which is a full kind of feature based on this, I believe, Cisco standard back in the day. It's quite widely used now, but the NetFlow can give you your network an awful lot of information about how it works and whose traffic is going where, and what's the trend. So you should be able to see who's been attacked in the last 5-minute window very easily through NetFlow. SFlow is similar to NetFlow, and I think it's a possibility that it's something that maybe MikroTik could consider, particularly for their higher capacity routers, so that rather than actually try to account for each packet, just do a sampled flow, which would obviously be more scalable and less resource intensive on the routers themselves. The real attack obviously can be measured then, before and after. It requires effort and resources to set up, so if you get attacked in the morning, you do not start going to install NetFlow analyzers and stuff, because by the time it's working, your either business will be shut down or the attack will be gone already. So the key thing is, the way to get around that is, don't worry, it happens to everyone, including my good self, and that's why Torch exists, so it allows you to shine a light in a very dark place. So to give an example, so NetFlow is kind of like a poor man's, Torch is like a poor man's NetFlow, and NetFlow is like a rich man's Torch, so that's the way I kind of describe it. But as you can see here, you literally just put it on your external, you select the external interface of your transit provider or one of the transit links, and you just start seeing where's the destination traffic going. And that should outline where the traffic is hitting for your victim, and then just organize it by the bit rate. You can also select protocol and port, and then you'll actually see the nature of the attack, because once you know the IP address, you should be able to see the destination, and you should see thousands of connections per second just going into them. Usually empty, not much traffic on it, but you'll just see just thousands of them there. So implement the plan. So try to identify the target of the attack. That's the first thing you got to do in denial of service. Who's being attacked? We need to actually black hole them. So we're going to talk about that concept. Work with the interests of the provider. So you ring the victim, your customer, and you say, you're getting hit with a denial of service. We're going to black hole you. We're going to have to give you a new IP that's temporary. This is kind of a quick and dirty way of getting around it. It is dirty because obviously that requires customer cooperation and reconfiguration of their systems. But it's the only way they're going to get back online. So, victim profiles, generally, the most common one that I've seen is either gamers or trolls, or gamer trolls, or gamer trolls, or trolls who are gamers, or gamers who taunt people, gamers who are... Anyway, moving swiftly on, sorry, I didn't want to dwell on that. Gamers though, seriously, would you stop giving out to each other? So basically what they do is they buy the services of some cyber criminals to stress test an IP, which then bumps off the gamer who's been slagging them off and allows the person to proceed to the next level. So that's a common use or misuse of denial of service attacks against some of our clients. Then obviously you have the more, let's say, genuine cases where, and probably more serious, and these are the ones that are more serious, where it's politically motivated or commercially motivated with a lot of money involved. So they're the ones that are the most difficult to deal with, and I would say probably the most genuine victims, I suppose, if you could. I'm not saying that they're all bad, but anyway, moving swiftly on, it just makes my life more interesting, I suppose. But yeah, so work with the victim and inform them, let them know what the problem is. They're under attack, you're trying to get around it and get them back on the air. And make it as easy as possible for them to get on the air, so work with them. So prepare them to migrate to the new one. Assist them with DNS moves, that's the key thing there. So short TTLs, that type of stuff. It's all kind of really, but you have to do this like really quick, obviously a quick response. So it is kind of important that the client is moving quickly with you to deal with it, because effectively you should black hole them straight away so that your other clients are not taken off the air as collateral damage. So the real intended victim is that particular person, but anyone who's in their network, neighbourhood, is actually going to be taken out as well. So what are black hole routes? And I've been talking about it there. It's very simple. It's effectively a way of dropping traffic. So your standard firewall filtering that you would be familiar with is you have a three-stage process. So you go through a mangle. Every packet going through a router would go through a mangle, which is pre-routing. It would then go through a routing decision, where is it going, and then through the forward filter, and you would block it at the forward filter. Black holing allows you to do it with the route table. So you actually move the decision forward to the actual routing decision. And that allows you to block traffic a lot quicker with less CPU cycles. When you're actually dealing with large packet per second throughputs, that's a very important aspect to kind of extend your router's capacity when it's under the most stress. So it's important that you do that. And it's efficient, and that's why we do it. So if you want to do a black hole route, so when we actually rig our upstream providers, or we advertise a route to them, they effectively create a black hole route. A MikroTik also allows you to create those. So if you're a service provider for an enterprise, you can use this technique to black hole traffic. And simply what you do is you generally enter in a route like you normally would, like a static route, and instead of using the type unicast, black hole. Very straightforward. And that will actually start discarding traffic for them. Once that step is completed, the level of traffic will decrease and your network will return to normal. And you'll have to start then migrating your client back on, to a new IP. And you may have to repeat that depending on how much they have annoyed the other adversary. So it's just an important thing. So faster response to DDoS issues, obviously that's very manual and very labor intensive. And is there a way of actually automating it? Yes, there is. And the way we do it is with remote trigger black holes. And what we do is we actually use BGP and extended communities feature of BGP to actually communicate with our transit providers or our peers, IPs we wish to black hole on their networks. And they will do that because it's out of their own. Simple as that. So if I was just to give you an example of what I mean, the internet simplified, you've got your various different carriers there with different size links. So what you can see is my AS. Now I remember I had a spell check misfortune in the US, and instead of AS it kind of said, do you mean AS instead of AS? So it's definitely AS. So if you see AS anywhere, we are talking about autonomous systems. But as you can see here, we have two 1 gig links upstream, and then obviously all these upstream providers then have 10 gig links or 40 gig or 100 gig links between them. And so they can actually be better able to deal with the attack. So you enter the zombie armies and the botnets, so they're all there lurking away. So then someone hands over a few quid to, I suppose what they call a cyber criminal or something like that. And so they start generating traffic, which they want to hit your network with. Okay, so the float will converge to your network. You'll only see, in this case, probably 2 gigs of traffic, while everyone else has to go, all the other transit providers are probably dealing with significant multiples of that. So what do you do? Well, if we advertise upstream with BGP, and it's the same way you would advertise your IPs, but instead of advertising your own allocations, you just actually advertise to a special root server called a black hole root server, the actual IP of the victim. It'll automatically be propagated on your service provider's network to actually drop the traffic. That is the piece of the resistance. That's the one that actually will allow you to quickly do it without ever actually contacting your provider. So it's as a good friend of mine, Conor Flynn, would say, an ounce of preparation is better than a ton of cure. So, and for you, I suppose you're all European, that would be like a kilogram of preparation is better than a metric ton of cure. So that's basically the story there. So by actually signaling that with your upstream through BGP and extended communities, and each one of your providers, when they give you a handover pack, you'll often find that there's an extended community on your existing peering sessions with them, or in the case of Cogent, which is my preferred option, Cogent will actually say, here's our black hole root server, you can peer with it if you want. So it's a completely separate system to your actual core routing infrastructure. What's really neat about it is that router that advertises those IPs can be as small as a 750. So your smallest your smallest good value router could actually do it. So if you were stuck and said, I don't have a router, just go down to the stores and pick even a client unit and configure it as a peer to that black hole root server. And all it's doing is send it a signal of 32 byte IP address, and it just send it to it. And that's what's really neat about that, And you're just doing a signal. It's like a hydraulic, servo. You're just putting that little signal out there, and then you're allowing a massive machine to clobber the data that's hitting your network. So it's the key thing there. So, how am I doing on time? I'm going well over, am I? I'm on time. Okay, cool. So, I'm not finished yet. So, okay, reduce the eco attack. So, we're talking about that. So, let's say you've really annoyed someone and they're actually hitting your entire prefix range. It's rare, thankfully, and it's very difficult to deal with. So, if you have a typical ISP, you have your internet, you have your peer networks, which you can see. You have your core infrastructure, you've got your backhaul subnets, and you have customer access networks. So what we're actually saying is now our entire IP range is being hit by this phantom menace, and we're trying to actually deal with it. So if you started to look at what IPs what do I need to keep on, and what IPs do I not need to have internet access, you can start to rationalize that and start reducing the traffic by actually blackholing significant portions of your network. And believe it or not, it's actually possible to blackhole significant portions of your network without affecting user experience. That's a really key point. So for instance here, what we're obviously saying is customers' IPs are ones that you can't really blackhole. You try to avoid doing them. Some core infrastructure IPs, obviously websites, ticketing systems, DNS, and all this type of stuff. But not much else actually needs to be routable on your infrastructure. So, what IPs don't have to be? Well, if you look at our lovely diagram there, we can backhaul subnets can be pretty much removed. So, like subnets between routers, management IPs if you're using public or unique global IPs but are not publicly routable. Unallocated for IPs. So if you have a let's say an allocation of 8,000 IPs and you only have 4,000 customers, you can probably drop off the latter 4,000 addresses without causing an impact. So that's the other one. So our unused IPs, and I'll discuss that. And that's where someone says, I need /25 because I'm so important in a big organization. But if you ever did a scan of their network, you'll always see that there's about 2 devices connected. So they have 120 odd addresses, but they actually only have 2 connected. So that's a key one there. So if an IP address doesn't need to be internet accessible, then can we simply blackhole it? And the answer is yes, it can. So let's just, for an analysis, and this is taken from a presentation I did in the US, but basically you'll see some analysis of /30. Now if you look at this /30, you've got obviously 4 IPs that are there. You've got your network address and your broadcast address, the default gateway, which is your desktop, and the client's router as well. Okay? So what IPs need to be accessed from the internet? Well, I can safely say client IP address. And we can safely block the broadcast address and the network address because we never use them anyway, as in for connectivity. So we can actually blackhole them. And so we've blackholed 0 and 3 on that example. So now we've actually reduced that network attack surface by 50%. Can we lock it down further? I think so. And what we can actually do is we can also blackhole our own desktop. Say that the router interface that's based on our router that's facing the client. That doesn't need to be accessible. All the customer needs to be able to access it and route packets to it, but no one on the internet needs to talk to it. So you can blackhole that. So by that, you've actually reduced your attack surface on that particular subnet by 75%. The customer IP is unaffected by that change. That's pretty slick, in my humble opinion. So downside, trace routes from your network to clients and from external people on the internet won't work. Boo-hoo-hoo, who cares? It's actually worked it. So you'll have gaps in your trace routes. It's a small price to pay, particularly if you're being attacked. So it'll increase the sizes of your router tables. So this was a controversial comment from the US, but I basically say if you're worried about that, just buy bigger routers. Matches. So you can do that. And obviously, MikroTik are going to bring out 64-bit router OS x86 edition. Didn't see the announcement this morning, but I know it's happening. That right, Aaron? Well, hopefully, anyway. He's nodding. I think it's coming. So what about /29? So we can apply the same logic again. I'm glad you asked. We can apply the same logic. So we've gotten rid of 3 IPs out of the 8 possible ones there. So 3 of the 8 IPs have gone, so we've reduced our attack surface by about 37.5%. And more improvements, well, yeah, we can. How many IPs are active on the client side? If it's just a 1 IP, you could just black hole the rest of them. Or perhaps they're using VRRP or HSRP, so they have actually they're using 3 IPs. So you can see here we've got 4, 5, and 6 are the real IP. 4 and 5 are real IPs, and 6 is the HSRP or the VRRP IP or virtual IP on the load balancer or router that's connected. So in this case, we've actually achieved a 62.5% reduction in attack surface. If there's only 2 used IP addresses, well then you can do 6 of 8, so you're back to a 75% reduction. And if the customer just used 1 because they just asked for /29 just in case, you could actually black hole 7 of the 8 IPs in that subnet, and you would actually effectively reduce it by 87.5%. So if my entire network was under attack, the effect of doing this technique is that you could actually reduce the traffic hitting your network by the order of the number of black hole IPs divided by the number of IPs in your entire allocation. The number of IPs that are actually being attacked in your allocation. So start planning your defense is my advice, and use the network plan. And when you're getting really desperate and you're trying to find those ARP scanning, that's what you get your help desk guys to do to try and reduce your attack surface further. So if you're not sure how many customers are actually deploying more devices than just the 1 IP and a /29, get your help desk guys monitoring that, and compile effectively like an Excel spreadsheet and dump it in then to your black hole router configuration. So it's a really important thing. And if things get really scary, as I was just saying there, ARP scanning. Just if there's no ARP entry on the /29 subnet, then the IP address doesn't exist. So whatever you do, don't just do ping to see if they're alive. Do ARP scanning locally, because if there's a device as a firewall, it could well be blocking ICMP ping. But no matter what way the device is configured, except for static ARP, of course, but for dynamic ARP, there will always be an ARP entry in your table if they're actually using it. So do a scan and you should be able to see it. And by doing that, if you had a /24 of, so you have a /24 allocation and you had a load of /30s there, you could actually, reduce your attack surface by about 90%, which is pretty impressive. So filter based on source. So the only thing I would say, so obviously you could do filter based on source. You can only do that within your own network because a lot of the source traffic will be spoofed. But if you feel that this particular traffic is blocking, causing you a hassle, you can do it. There are issues though. If it's 8.8.8 is the apparent IP that's hammering your network, you're going to ruin everyone's DNS service, so you'll have to work around that. Thankfully, MikroTik has lots of features to do that, so you could do destination apps, so divert the 8.8 request to a local DNS server and black hole the 8.8.8 service. If someone spoofed that and tried to screw your network. So automatic remote trigger black holes between ISPs are a very useful feature. And just remember to only 5 minutes. Thank you. Cheers. Sorry about that. So basically, the main thing is to only ever advertise IPs, like only allow black holing of IPs that are within your own network to your upstream providers. They should only allow you to black hole IPs in your own network. You should be able to, like if Arnis and me were connected to the same ISP, I should be able to say, actually, can you blacklist MikroTik.com? It's been hit. So they should be filtering that I can't do that, even if we're connected to the same upstream provider. It's a key important thing. So I'm going to Yeah. I think it's probably better I answer a few questions, but you can catch me anywhere. I'm reasonably approachable. I don't bite unless you're a lady. And I'm joking. Sorry. Can't move swiftly on. But thanks for your attention.
Thank you, Tom. Your questions will be answered at the bar.
Yes, absolutely.
And our next presentation will be by Patrick. While Patrick is setting up, I would like to tell you that few of the new products that are announced now will be this year can be seen in the exhibition hall where our MikroTik staff guys are. So during the lunchtime, we will also touch of the one few of the new products.
Okay guys, Patrick Shaw is going to present about public Wi-Fi now, and after his presentation we will have lunchtime. Those of you who have the lunch tickets can have the lunch for free. If you do not have the lunch tickets, there is a shopping mall connected to the hotel. There are many restaurants there. So, and lunchtime, after the lunch break, we'll continue with the presentations. The schedule is outside the door. So when you're going to the lunch, you can check what presentations we will have after the lunch.
So, hello. Thanks for attending the MUM and welcome to another user meeting in Prague. It's been a while since we've been here. I think it was 2009, the last time here. My name is Patrick Schaub. I'm going to talk about public Wi-Fi today. And before we start with the topic, I want to tell you a few words about our company. Try to switch the microphone, just hang on a second. Okay, yes, here we go. Okay, I'm Patrick Schaub from FMS Internet Service in Germany. We are a value-added distributor. We've been on the market for 17 years now, so we bring quite a bit of networking experience with us. And in terms of distribution, MikroTik is one of our core products. So MikroTik and MikroTik accessories are things that we're dealing with every day. And We're also rather big in professional wireless point-to-point links, like microwaves or V and E-band solutions. And we're a general supplier for alternative ISPs or alternative carriers. If you're interested in our products, you're welcome to have a look at our online shop, and you'll see most there. Next to distribution, we are offering a few services. First of all, quite a lot of training. We are a MikroTik training partner since 2007 and have been the first training partner in the German-speaking countries. So we're doing that for quite a while, and my colleague Sebastian is doing about half of his time MikroTik trainings. He's qualified to do all the engineer level certifications, but we're also working for some other vendors by now and doing certification for their equipment. Next to training, we're offering consultancy services, sometimes to enterprise customers, but usually also to ISPs and alternative carriers. We have an upcoming training of Capsman. It's actually the first Capsman training we're doing. It'll take place in Austria at the premises of our partner Assmann24. And since this is relating to my topic today, I want to make you aware of that. So if you're interested, it's in German language, obviously. You're welcome to participate. You're also welcome to drop by at our distributor table here in the exhibition area. We brought access nodes from Alcatel-Lucent, whom we are a distributor for. So if you're interested in DSL or GPON or active Ethernet, that might be something for you. And we brought quite a bit of equipment from South Technica, which is our preferred vendor for microwave installations. So if you want to see their measurement tools, their spectrum analyzers, their signal generators, or their microwaves, you're also welcome to pay us a visit. Next to that, we've got V-band equipment from Sub-10, short-haul gigabit links, also available at our exhibition table. Next to that, we've got two products with us that are relating to the presentation today. That is a site survey software and a custom-made access point based on MikroTik or with MikroTik inside. Actually, MikroTik will give you almost all you need in terms of software and hardware to build professional Wi-Fi services. But site survey software is not yet something they came up with. And site survey software is pretty handy in the planning phase when you want to simulate your network, like read in CAD files, place virtual access points, and get an idea what the coverage will be like. But also after you deployed your installations, when you want to do passive or active surveys, that is, draw a weather map of the signals on the different floors, or get an idea what the real throughput, the real bandwidth in different areas is. Our solution also supports GPS and automatic map download, so if you're doing surveys for outdoor areas, that's pretty handy too, since all you need is to plug in your GPS receiver and you will get the maps for the area you're walking through automatically. The second product on the right-hand side is a custom-made access point with a MikroTik mainboard and MikroTik Wi-Fi interface. But what we found, especially for professional installations, is that customers today are demanding dual band devices. Today, finally, we got a dual band device introduced, an upcoming one, but so far there was no possibility to have complete dual band systems, especially not with AC standard. So that's something we are providing. If you're interested in OEM-based access points, come by. It's also possible to have your own logo or your own color for these devices. Public Wi-Fi altogether is more or less a boring topic. If you look at that, it's been around for a long time and the concepts did not really change. But in distribution, we saw that the turnover for public Wi-Fi projects is starting to rise again since about 1.5 years. And we tried to find out what the reasons for this are. Actually, we think there are like 3 stages in the public Wi-Fi history. During the first stage, like 10 years ago, some people thought it might be a nice marketing idea to offer Wi-Fi in their hotel or conference room, but they never thought it's a really important service, so they didn't really care on the coverage or anything else. Definitely changed at latest 5 years ago when these companies found out that Wi-Fi or Wi-Fi services will help them to earn more money, to get more customers, and they started to care for the quality. They wanted to have good coverage, and they started to care about legal issues they might run into, so they wanted to have access control. And the first, today we call it cloud-based Wi-Fi services, started to pop up and offer complete solutions for hotels, hospitals, and all the other potential customers. But today the situation again has changed. Wi-Fi will not help you to make extra money anymore. It's the other way around. If you're not offering Wi-Fi in certain businesses, you will definitely start to lose money. You're not going to get bookings, you're not going to get big conferences. And losing money is even worse than not earning extra money. So today, the customers are really looking at what they're going to deploy if they're having a new Wi-Fi installation. And they also start to push their old installations, that is, they're starting to redo things. And they're looking for a high throughput. They want to have dual band coverage across their complete premises. That means you need to have more access points, since 5 gigahertz coverage will be more of a hassle in an indoor environment. More access points will lead to more administration overhead. So it's getting more complicated. And the customers are also starting to look at multiple services. It's not only about surfing the internet and email anymore, but people want to do video streaming, they want to do voice over IP. All the services that they're used from their homes should be working in the hotel or conference destination too. Another thing that customers are starting to come up with is dual use of their Wi-Fi infrastructure. That is, they don't want to deploy a second Wi-Fi for internal usage, but when they're investing money in good coverage, they want to make sure they can use this Wi-Fi also for their stuff, maybe their machine-to-machine communication in some companies. So this is something that's adding up to the requirements of a modern Wi-Fi network. And just to complete this, one of the recent changes definitely is also, at least in Germany, that these Wi-Fis are offered as a free service. So payment gateways, for example, are getting less important. So like the summary of the latest requirements is that Wi-Fi has to be easy to use with all devices. It must be easy to operate and without any legal risks for the company who's running it. It should be very reliable and bring you high throughputs. Dual use for public and internal networking should be possible. And many customers require a tight integration into their back-end processes and customization in their corporate design. So luckily, MikroTik brings us almost all we need to build all sorts of Wi-Fi services. And before we start to look at real Wi-Fi services and build some of them together, I want to introduce the basic components that are being used. First of all, we have hotspot. Probably most of you know what a hotspot is. It's MikroTik's implementation of a captive portal. That is, it's that piece of software that will allow you to do HTTP authentication for your clients. That is, enter your user credentials on a web page instead of using an encryption or some other technology. How it's working is pretty easy. A firewall will block all traffic from the internal to the external network until it sees the first HTTP packets to arrive, and these packets will be forwarded to an internal login page and present the user with username and password fields instead of the website that he actually wanted to open. And once this has been verified, the firewall is opening for all subsequent traffic of the same user. A hotspot or captive portal is definitely the core concept of all public Wi-Fi services, and of course there are quite a few more vendors than MikroTik. But MikroTik's implementation is free for you, it's free of charge, it's an additional package for RouterOS, so all you have to do is to configure it. Maybe you should take a look at the license level you're using, that everything fits, but basically there's no extra payment, although the hotspot feature will give you quite a lot of flexibility. User authentication means a local user database as well as a radius database that you can use, powerful accounting settings to give you access to websites without authentication. So check out the whole list in the wiki if you're interested in that. And the second big topic, or the second big package that MikroTik is offering you, is User Manager. It's, let's say, Radius implementation with a web interface that will let you easily manage the user database. It's working together with Hotspot, that is, your hotspot can be configured to ask User Manager for the accounts, verify them, and then open the firewall and let the customer go to the internet. For User Manager, it's the same. It's a free package. You will have to install it separately. It's not in the core installation, so you have to download it, get it. You can run it on your box. Maybe you don't want to use an RV750 or something very small, but in general, it would already do the job. It's an alternative to complex Radius installations, and it brings you an easy-to-use graphical interface. So you might even be able to pass the login to User Manager to your customers, since the User Manager login will not allow them to configure their router. User Manager also supports multiple NAS and multiple services, so you can not only use it for hotspot, you can do single logon for VPN, for example, at the same time. And it has some ticket creation features. It supports templates for tickets. You can do bulk ticket printing, like printing 200 tickets and pass it to the reception. And it also has payment gateways, which are, at least in our customer base, not used very often. More interesting might be the session log that will give you a long-term log about what your users really did. The third feature, and that's maybe more interesting since it's a bit newer, it's CapsMan. It's MikroTik's implementation of a Wi-Fi controller. And MikroTik's Wi-Fi controller does basically two things. It'll deploy configuration to your access points. It can optionally also handle traffic of the access points. That's what you see here. All access point traffic can be pushed to the CapsMan, but it will also allow you a local forwarding node that is pushing traffic to the local network. CapsMan also is a free router as package. I think that's pretty good to know, since quite a few companies are earning money by selling their controller-based software. And it's also very good that it runs on Router OS, so you will not need dedicated hardware at your customer side if you're having a small installation with a local Caps Manager. As I said, it will do the central configuration and provisioning of the access points. It will allow you to do central Router OS updates if you want to do so. It will allow management of user traffic, and you can use it in layer 2 or layer 3 deployments. We'll have examples on that later on. So next to the three big packages, Hotspot, User Manager, CapsMan, Router OS comes with a lot of standard features that will make it very easy to build professional Wi-Fi services. As in such services, you will usually have to adapt to special network situations or special customer needs. And all of you know MikroTik gives us a lot of capabilities. I just want to name a few that come in very handy with these installations. Wi-Fi-based features are the virtual access points, for example, or the connect list that will let you kick out users if their signal is not sufficient, for example. But also access-based technologies like a wireless distribution set or mesh might be handy if you have to use a wireless backbone for your access points. Wireless backbone usually is one of the headaches that customers will run in, so we do not really suggest to use it. We would prefer a cable-based installation, but still MikroTik gives you all the means you need to react in special situations. And there are also quite a few very common features that you need to build a professional service. VLANs, rapid spanning tree that can also work together with WDS, load balancing if you have multiple broadband lines to balance your traffic on, 3G, 4G as alternative uplinks if you don't have broadband lines available, VPN to tunnel your infrastructure to a central data center, or scripting and NetFlow. So when you look at professional Wi-Fi services, companies who are really deploying Wi-Fi for a lot of sites, there are three basic concepts. We have local setups. In a local setup, you will have your hotspot, your user manager, and your access points all on site. And this is something that is typically used by customers directly. That is, it's not a typical setup for Wi-Fi service providers. It's very easy, it doesn't need any external services, traffic will be forwarded locally, and you have no tunneling overhead. The second general possibility is to use remote user management. That is, you will still have all your equipment at your customer site. You're only moving the user manager to a data center or any other radio system to a data center. And this is still a pretty simple setup, as you will not have tunneling. You will still forward all your traffic locally, but you have a central user management, which you can, for example, use to give single log on to multiple hotels belonging to one chain. And this is a type of setup which is quite common, even for bigger professional Wi-Fi operators. And positioning in the data center also allows better hosting capabilities for big user management systems, as they might need bigger platforms and come with the typical requirements. Here is just an example for two sites being connected to the same user manager. Of course, you can connect a third and fourth and fifth one. So this, the remote setup is probably what most, at least in our customer base, most professional Wi-Fi service operators run. Today you would probably call it a cloud service, as actually everything is happening in the data center. On the customer side, you're only building a tunnel, a layer 2 tunnel into the data center, and even the traffic is being forwarded to the data center. So the local broadband connection is only needed for traffic forwarding. In our example here, I'm still referring to Ethernet over IP as a tunnel technology. That's actually not necessary today anymore. In the older days, Ethernet over IP has been the only mean to get a transparent layer 2 tunnel. Today you could simply bridge VPN interfaces. But since we still have so many installations around, I wanted to show the complete picture. So in a remote setup, traffic will not be forwarded locally. It'll go to the data center and it will leave from the data center. So from an external point of view, user traffic is starting at the data center, and this is going to shift the complete responsibility, the legal responsibility, from the owner of the broadband connection to the company that is operating the data center or the service in the data center. Of course, you can also cover multiple sites on this setup, and based on this remote setup, I want to show you two implementations, one using Capsman and one without Capsman, on how an actual service could look like. So this is an example, or let's say the first step of a complete remotely managed public Wi-Fi service. What you see is the access points here on site, the tunnel router, everything here is bridged together. So all the traffic is being forwarded to the tunnel router and through the EOIP tunnel to the hotspot and the data center. Hotspot is going to pass DHCP leases to the local access points. Of course, you'll need, or you might need PPPoE to connect to your DSL line, and maybe a VPN connection to run your EOIP tunnel through. This gives you some overhead, but this is still a setup which is in place at a lot of installations, also big installations, so it's worth to take a look at. And here on that slide you see all the infrastructure that you need for the transparent layer 2 connection. After your connection is up and running and your clients are getting DHCP from the data center, you want to configure user manager, which is also placed in the data center. What you have to do is you go to your hotspot profile and tell it to use radios for authentication. So hotspot is not only looking at the local user database, but also asking the radio server for that given user. But you also have to set up the radio's connection to that radio server. So in the main menu, you choose radius on the hotspot, enable it, give it an IP address, or tell it the radius service, enter the secret, and finally check the box at hotspot so that your router knows it should use this radius for hotspot authentication. So by now you already have a layer 2 connection from your site to the data center. You have the hotspot asking user manager who is going to store all the accounts. So basically the complete service is up and running already. If you're offering something bigger, you will most likely have to adapt HTML and the account creation process. Luckily, we do not have to use the internal HTML pages of the hotspot. We can do so, you can adapt them, that is change them. You have a simple scripting facility there, but usually you will need more. You will want to integrate in a content management system. You want to have real scripting features or CSS or all the fancy HTML stuff today. So what you can do is you can tell hotspot to forward the login attempt to an external web server, and the external web server can use all standard HTML features to give you a fancy login page, and finally return username and password back to the hotspot, who is checking them with user manager, and finally forwarding to an external web server again, who is giving you success or failure, whatever it is. So it's very easy to have all web design capabilities without doing that on your hotspot router directly. That's not that complicated and is done frequently. And something else that many customers are not happy with it when they get their system out of the box is the way to pass the accounts to their users. If you're selling them online by PayPal or something like that, that's one thing, but usually Wi-Fi today is free, so you need to have some possibility to give account details to your user for free. You could do so at the hotel reception, but this is some extra work all the time, so most providers are actually offering an online registration, and many of them want to do SMS authentication. That's pretty popular for two reasons that we are going to look into in a second. And it's very good to understand that we have the API, the application programming interface of Router OS, to control or change the complete process when it doesn't fit our picture. So what you can do is forward the login to an external web server, and that external web server is also offering a mask for account creation. And once that account was created, you're using the API on that system to dynamically create an account in User Manager. So nobody's really touching User Manager, it's just done script-based. After that, you can, for example, have user details be sent by SMS from your web server, which is just simple scripting by today. So your user will receive username and password not on the web page, but on his mobile phone. And this is very useful for two different installations that we've seen. First one is you just want to allow your user to use 1 free hour per day, for example, and you limit that to 1 free hour per day per mobile phone number. So that's why you will need a mobile phone number. And the other reason is for legal security. Again, in Germany, this is still a pretty big topic. We're not very advanced with that. So it's a big headache for hotspot operators. Know who is using their service as good as they can, and if they know this person has access to this mobile phone number, this is a bit more of security than just having them fill out some forms in the web. So by now we have the complete service running, we have user manager, we customized HTML, we are using the API to send SMS and create user manager accounts dynamically. That is, the public service itself is running in a way that, as I said before, quite a few companies are using and selling this as a commercial cloud service to hotels and all the other potential customers. As I told you in the introduction, dual use of the Wi-Fi infrastructure is getting a bigger topic. So what we cannot do so far is we can't offer the stuff of our customer a secure access to the local network based on the same Wi-Fi infrastructure. And that's what we are looking into now. MikroTik will give you the ability to build a virtual access point on top of the physical access point. That's what you see here. You see a physical interface and you see a virtual access point with two different SSIDs. And what we do next is we force traffic of both access points into different VLANs. If you do so, we can take care by a switch that all the traffic on the guest Wi-Fi is being passed to the tunnel router and to the data center. And all the traffic of the staff VLAN is forwarded to the local network. That's what you can see here. We have two VLANs created underneath the Ether1, which is here, and over here we take care for the traffic being sent to the right bridge. That is the traffic from the SSID or the virtual access point with the SSID stuff is being pushed to VLAN 2, and so we can make sure it's going all the right way from the access point to the VLAN switch into the local network. So by this bridging VLAN and virtual access points, you can offer dual use of the infrastructure to your customer and make sure only those people who know the encryption key will be able to use the local network. For big installations, this will probably not be sufficient, as you might have 200 people in the stuff all using the same encryption key. So you can take another step and you can go ahead and use personal encryption keys bound on special MAC addresses. So only those devices with the right MAC address and the right encryption key will be able to use your Wi-Fi. That's pretty nice, as your customer will only have to disable one account and not all of the staff have to change their encryption key. And it's another possibility to use User Manager. You can provide your customer with an internal User Manager down here, which is not being used for the public Wi-Fi accounts, but only for the internal staff accounts. So what happens when your mobile device, for example, is connecting to the SSID stuff? It's going to send its MAC address automatically to the access point, as well as using a special encryption key. And the access point is going to check that MAC address with radius. That is, it's going to look for a user belonging to this MAC address and receives back the encryption key. So if the MAC address and the encryption key are correct, the user is able to use the internal network. To do so, you have to extend the wireless security profile of your access point. Over here you see you have to add MAC authentication, and you also have to configure the radio server on that access point and check the wireless checkbox so the access point knows it should also check with radius for the encryption key. By here you did build a very fancy service. You didn't pay much. All the features are for free. You did quite a bit of configuration, obviously. But this is a service that you can reuse with all of your customers. Everything is set up centrally in the data center. You have customized HTML and customized account creation processes. And you also have dual use, that is, your staff users can use the internal network without need of any additional software on their devices by a pretty good security. Oh, that's what I forgot. Sorry, that's the user manager end. So in the user manager, you will create an account using the MAC address as a username, and you're setting up the pre-shared key over here. So that gives you the infrastructure of user or MAC-based authentication keys. So now we want to have a look and build the same service using CapsMan and understand where CapsMan is giving us advantages. First of all, a short general theory to CapsMan. The naming is Controlled Access Point System Manager. That's the, let's say, Wi-Fi controller. And we have our caps down here. These are the access points. And the CAPS manager is providing different services for the access points. First of all, it's doing the Wi-Fi provisioning, so it sends the access point all the configuration. It can do its router OS updates, so you can force the access point to be updated if it connects to CAPSMAN. It can run ACLs, and it can take care or will take care of the complete client authentication. As I said in the beginning, there are two forwarding modes. Either the access points, the CAPs, are forwarding their traffic to CAPSMAN. That's manager forwarding mode. That'll be the standard that you're using. But you can also use local forwarding mode, and you will need that to build, for example, the Wi-Fi infrastructure for this stuff. There are three possibilities how the CAPs will connect to their CAPSMAN. There's a layer 2 discovery. That is, if you enable the discover interface in the access point in the CAP, it will check the layer 2 network if it's going to find a CAPS manager, and if it does so, it can use it straight away. So that way you're not going to need any IP configuration on your access point. It doesn't need an IP, it'll do all it needs by checking for CAPSMAN. The second possibility, and that's, I think, very handy, and that's what we're going to use for the public Wi-Fi service, is to use a DHCP option. You can have your DHCP server also pass the CAPSMAN IP address to the CAPS. So that way, all you have to do on the CAPS is to enable the DHCP client. It will receive an IP address and also receive the IP address of the CAPS manager. That does not have to be in the layer 2 network anymore. It can be layer 3, so it can be in the data center. Third possibility would be to give a static IP address of the CAPSMAN to the CAPS. It's least flexible, but probably there are also some situations where you want to do that. So if you want to rebuild the complete service that we've seen before based on CAPSMAN, we have two advantages. We have fast and easy setup of the complete infrastructure, and we have an automatic provisioning of the access points. What we have to do is to install CAPSMAN on the hotspot device, or we don't have to install it there, but it will be most convenient in the data center. We'll install User Manager and finally configure CAPSMAN, hotspot, and User Manager. After that, you will install the access points, set up the DHCP client on the access point, and have your local DHCP server send the CAPSMAN IP address. For CAPSMAN, there are two different versions right now. There's version 1 and version 2. They are not backwards compatible, so you have to decide which one you're going to use. If you're going with version 2, what we're doing right here in the example, you have to install the wireless CM2 package, which is an extra package that you download from MikroTik.com. And after you installed it, all you have to do, or the minimum setup, will be to enable CAPSMAN on the hotspot device. On site, you have to do two steps. You have to configure your DHCP server so to pass the CAPSMAN IP addresses. That's what you see here. It's just an option by now in the configuration dialog of your DHCP network. So you can enter one or more CAPSMAN addresses here. And on your access point, you will also have to install the CAPSMAN 2 package and check that button here in the wireless cables. Enable CAPSMAN, choose which interfaces should be dynamically configured by CAPSMAN, and that's all it takes on the access point. So that's what we got by now. With our local CAPs, which receive their IP address and their CAPSMAN IP address by DHCP, which will automatically get their configuration, which we're doing in the next step from the CAPSMAN, which are automatically tunneling their traffic, as we see later on, to the CAPSMAN. We don't have to build any tunnels ourselves. All of this is being done by the CAP and the CAPSMAN. Of course, you can add more sites to that structure too, so it's the same flexibility that you had in the remote setup that we saw without CAPSMAN. Actually, we're just missing the provisioning itself, so how is your Wi-Fi going to be configured? And this is the provisioning theory to CAPS Manager. You build up multiple provisioning sets, and each provisioning set will contain one or more links, and it will contain rules that need to match for this provisioning set to be in place. So what happens is that you go from the first to the last provisioning set for each interface which is being managed, and the first provisioning set that matches is going to be used. So in our example here, the first one has a matching rule. A rule could be, for example, a MAC address, or technical aspects like only 5 gigahertz access points or only 2.4 gigahertz access points. So let's say that one is matching, and once we found out it's matching, we look at its master config. The master config is a link to a given configuration, what you see down here. And if we found that master configuration, the first interface is going to be configured. The physical interface of the access point is going to use the master configuration in the provisioning set that has a matching rule. After that, we check for slave configuration, and a slave configuration will result in a virtual access point. The master configuration is the physical access point, or the physical interface, and the slave configuration is a virtual access point. So what happens now is we found another configuration, and we will set up a virtual access point here. That can continue for more steps. In this example, I did choose 2 slave configurations, and so a second virtual access point is going to pop up. Now let's have a look at a real example. What we want to do is one SSID called guest Wi-Fi for all interfaces, then an extra SSID for all 2.4 interfaces, which you will see here, and an extra SSID for the 5 gigahertz interfaces. This will allow your customers to choose if they want to make sure they're using the 5 gigahertz access points, for example. Down here you can see all the dynamic interfaces which are being created on the CAPS manager, 2 master interfaces and 2 slave interfaces. And here this is the resulting Wi-Fi structure. 2 Wi-Fis with guest Wi-Fi as an SSID, 1 with 5 gigahertz and 1 2.4. Please take care, this is not how it's really going to look. This is just an example on a real CAPS managed access points. All the interfaces will be disabled, and we'll see a real screenshot later. To do that, you create 2 provisioning sets, 1 for hardware modes that support B standard, and 1 for hardware modes that support A standard. You give them the same master configuration, but different slave configurations. In the configuration itself, you only have different SSIDs. You will make sure that the data path, that is the way the traffic is forwarded on the CAPSman, is set to the bridge that is connected to the hotspot, and you don't need any security. And this is going to be your result. This is the real screenshot from a CAP, from an access point. You see all the interfaces are disabled. You see only some red lines that inform you that this device is remotely managed. And here you can see 1, 2 physical interfaces and 1, 2 virtual interfaces beneath. If you go into the details, you will not be able to do any changes. Actually, the only setting from the local access point that is being looked at by CAPS Manager is the antenna gain. So that's actually something that you can set on your local device before you enable CAP, and it's going to be looked at since antenna gain might be different on different access points. So far you did rebuild the complete infrastructure that we've seen before. You have central CAPS Manager. You don't have to care for the tunnels. These are built automatically from your customer side to the data center. You have different SSIDs. You don't have to take care of the deployment of the access points. All that you have to do is enable CAPS there, tell them to use the HTTP client, and tell them that both of their interfaces are going to be managed by CAPS. And maybe you want to set a password, obviously. So there's one thing left to discuss. That's the last thing. That is a virtual interface for our stuff also possible? We've seen that we can do multiple virtual access points by using multiple slave configurations, but the local traffic for the local stuff, or the traffic for the local stuff, should be forwarded locally. And there's one problem in that, that is the virtual interfaces are not going, or the traffic flow for the virtual interfaces on the access points are not going to be controlled by your CAPS manager. So you have to control it locally. As these interfaces are dynamically configured, they will just pop up during the provisioning process, so you cannot add them to a given bridge when you roll out your system. So what you have to do is you add a third or a second slave configuration over here, and that slave configuration is a little bit different. You will do security configuration to have an encryption key, and in the data forwarding or data path configuration, you will add the local forwarding. You don't forward to the central CAPS anymore. And on your access point, and that's important to understand, you also have to do one change. You have to add the local bridge here. You have to tell that access point traffic on the staff interface is going to be forwarded locally. It should be, the interface should be pushed to this bridge here dynamically. And you see these interfaces in local forwarding that are not going to be disabled. They're enabled, and so you can handle the traffic flow on the access point locally. That's basically it. I think I probably did overshoot in time anyway. So thanks for listening. Enjoy your lunch. If you have any questions, I'll be around in the exhibition area. And yes, thanks for listening. Have a good night.
Nee, maar je hebt besteld bij Koes, dus 5 minuutjes. Heel de wereld kijkt mee, man. Ja? Nog iets verder, je moet deze kant op komen. Nee, we staan nu al goed, denk ik. Ik ga niet verder. Let op. Mooi hè? Mooi hè? Die Frank. Dit is helemaal de deuk, man. Nou, wij gaan even een hapje. Oké, we gaan even een hapje eten, dus we gaan hier weglopen en we gaan even schijnen Frank. 1, 2, 3. Dag. Zo. Nee, we gaan, ja, schiet maar op.
But I think he was anxious to have some MikroTik representation there.
some minutes for preparation. We should start in a few minutes.
Hello, everybody. I hope you all had lunch and are ready, because we are starting the presentations now. The first presentation will be about denial of service attacks by Alfredo Giordano and Matthew Ciantar. So if you are outside, so please come back inside so we can start with the second part of the first Monday.
Thank you. Hello, everybody. Was lunch good? Okay, so presentation will be again about DOS and DDoS. There's a little bit of overlap here, but we will look at it from a different kind of perspective. Okay. So for anybody that doesn't know us, we are Alfredo. It's Alfredo Giordano. I work in Italy, mostly, as an internet provider, and I joined the MikroTik community recently, about a couple of years ago, basically. And my colleague here is Matthew Ciantar, that's by himself.
Hi, my name is Matthew Ciantar. I've been dealing with MikroTik for quite a while, since 2002. Moved there to become a trainer, as well as a consultant as well. My background is not strictly related to service provisioning, ISP and work like that. It's more on the other side, on basically I work in the field of betting, in the betting industry. So it's more looking at it from a corporate perspective and what you can do in this regard when it comes to DDoS, what we can do from our end. I'm originally from Malta, but recently relocated to Dublin, well, already there since 2 years. Probably this must have been an issue with myself and Tom getting the idea of living close to each other in Dublin. Coincidentally, we got a bit an overlapping here on DDoS, but like I'm saying, this presentation was covering more from an ISP perspective and a larger bandwidth. We're all including a bit as well what one can do from a client side or from a solution when you are installing your MikroTiks as a CP user at your clients to avoid certain situations as much as possible, where possible, basically. Alfredo and myself started working together, providing training and consultancy. After we had trained the trainer together, we decided to start this joint venture. Also, we provide training in many cases, try and do it together. So, in our opinion, is being two trainers in a session helps even more to cover the material as best as possible. Okay, so jumping right in, denial of service attack. So, basically an attack on a computer network that prevents legitimate use of its resources. So basically, we have someone who's going to try and affect our environment, right? Maybe on purpose, trying to affect us by blocking services which we are trying to provide to our customers or to ourselves if we are a corporate environment, basically. How does this affect us? It affects software systems. If we're running a web server, if we're running a load balancer, we're running a web server, then if network equipment, it could affect routers, switches, load balancers. We're going to see how big the OS attacks can basically be and how this can affect us. It also affects, obviously, servers and end-users' PCs. Usually, in many cases, we see that denial of service attacks originally start from hacked systems, hacked servers, or hacked end-user PCs.
So anybody might think that, okay, but this is not happening to me. This is not happening right now. Do you have an idea of how many attacks are actually happening at the moment? We have prepared something for you to have a simple sketch up of the situation. This is an action map from a service called the Norse, and it's actually taken from alive from their client around the world. They do what is basically called the IDS. They pick up the tunnel the traffic to you, they pick it up and they clean it for you. It is an expensive service, but it serves us now to understand how many attacks are actually going on at the moment. And this is only a perspective from their point of view, which is pretty big because they serve pretty big ISPs around the world. But as you can see, United States is being targeted, and now also Europe at this very moment. We can look at the main nation on attack origins on the left side, and on the country targeted on the other side.
Also shows us some the service type of attacks the system is currently seeing at the moment. Okay.
So going back to the presentation, basically every attack, every anatomy of an attack, and the detection of it has to start from where the network begins. And network, to my point of view, and it begins from the OSI layer. An attack can basically occur at any level of the OSI. The OSI is always a good starting point to understand and troubleshoot any network behavior. And this is especially true when, like we've seen in the morning, network is under particular stress, like under a DDoS attack. So let's do a little analysis of how an attack can occur at any level of the OSI. Basically, you can attack the application level, and we are familiar with that kind of attack. Basically, you attack the program that is running the server. So basically, post large PPF gets. Then you can attack the presentation layer. That gets complicated because presentation level can be SSL, and SSL inspection is pretty heavy. Then you can attack basically any level like telnet, and also you can conduct an attack directly to the stack, which is basically level 4. Then where you can find some SYN. ICP offloading is also. That when it comes to level 2 and level 1, then we are talking about somebody inside on the network, basically. And when we are talking about level 1, we are basically talking about bonds. Somebody has to come there and actually pull the cables. Okay? So let's go over it. DOS attack are normally unable to attack large bandwidth websites. One upstream client cannot generate enough bandwidth to cripple major websites with larger bandwidth capabilities. This is normal. If you want to attack Google, you won't expect to do it with a very small pipe of bandwidth, okay? But this is related to DOS attack. So it's an attack that points to deny some certain service that is running on a server. But what about distributed attacks? So when we can actually amplify the attack and distribute it around the world. As described by Wikipedia, DDoS is a type of DOS attack where multiple compromised systems known as bots or zombies, which are usually infected with computers infected with Trojan, are used to target a single system, causing a denial of service attack. DOS can be a very large scale, potentially bringing down a whole network or an internet service provider. But how big this can get?
We can check a bit what happened in the past years. Maybe, from what Tom was explaining on his network, you can easily, especially nowadays, we're saying, okay, we have one user tries to do a DOS attack on his own. Well, with just his upstream provider, upstream bandwidth which is available, maybe has 1 megabit, maybe has 20 megabits, it's not really enough to do such an attack. But maybe once you manage to have a system where, as soon as we put SSH, we put a Linux server on, we see people trying to get access to it. Once we get a lot of systems which have been compromised, all these systems together, especially nowadays with more and more upstream bandwidth being given to the end user, it's becoming more possible to launch such an attacks. So basically we can see one of the real-life examples taking back 27 March 2013, where there was an attack on Spam House which reached around 300 gigabits per second, which is massive. I mean, when looking a bit of a graph, sometimes you have a provider has 1 gigabit, 2 gigabits, 3 gigabits. Here we're speaking about 300 gigs in total, basically. And again, this was a DNS reflection where servers out there, it could be, even as we're saying down here, it could have been MikroTik devices with DNS allowed on the WAN interface, on the public. Someone sends a request with a fake source, and MikroTik back as a bigger packet to this address. And that would affect the DNS reflection at such a size, basically. We have another example, which is even bigger than that, which was directed against Cloudflare, which the idea of Cloudflare itself is exactly that, to try and help people avoid the situation of being DDoSed. There was a DDoS target directly to them, reaching 400 gigabits per second. In this case, the NTP reflection was used. Okay? And it is the situation which we are trying to bring knowledge about in this case, where we have installed a couple of MikroTiks, they're on the internet, they have internet connection, and the client starts calling us, listen, my internet is not working well, or it's crashing, or it's not working and then it stops. Then we go in and we notice either the CPU usage of the MikroTik has gone up, or, I mean, it could be any device, basically. So what's happening in that case, someone is attacking our services, our legitimate services, which should be working well, but because they are not well protected, they're being abused to launch an attack. Okay? Are we at such risks for such an attacks? Yeah. I mean, especially if you are a bigger an ISP, or if you are a corporate, a company doing something which might annoy someone else, like we're saying, you can easily be a target. And if you're an ISP and one of your clients is a target, then it is going to affect you, and it's going to affect even other clients within your network. So a botnet, also known as zombie army, is a resource which is easily available to be used against us. These are infected computers located around the world which can be rented to launch such an attack. Just by putting out a Google search, we can get a return of such websites which have a list of such servers which have been hacked, and you can pay for them. You can pay, for example, $180 and you get computers in the US. Then you can pay $240 and you get some other computers which are located in the United Kingdom. You can pay $35 and you get some around 1,000 affected computers which are located randomly around the world.
Please take your ticket for the reservation.
Yeah.
So what's happening here? As we were saying before, the attack can be conducted on any level. Let's concentrate on router level, where we are actually working at layer 3 and 4, and at firewall level, where we are actually looking at the level from 4 to 7. So what are the DOS protection can be implemented? RP filter, already mentioned by Tom this morning, routing black hole as well. And on the firewall we have address list, session limit, sync cookies. So what happens at router level? Kind of attack that can be mitigated. We find Smurf attack, IP address spoofing, malformed trace route attack. So Smurf attacks are not an army of actually zombies, blue mans. It's actually the name of an old program used to conduct such an attack. Nowadays not very much common because the protocol has switched off the requirement of forwarding the broadcast address. Basically was an attack conducted against the broadcast address. Every router would forward that broadcast to the internal network that would be saturated with packets. IP address spoofing is one instead of the most common techniques, and we will see something about that. You can actually spoof, so utilize, forge a packet with an IP address of your own AS or some other AS to actually pretend you're something else. So you are actually injecting the request, so the reply will come to the original source, which is normally the target. As well, as Tom was saying this morning, every protocol that triggers a response, a reply that is bigger than actually the request can be used as a DOS amplification. And this was also the case of traceroute, while traceroute was not actually handling very well the response time, and you can actually have traceroute send UDP or ICMP packets and not waiting for the response forever. One of the solutions, unicast reverse part forwarding, also stated in the RFC 3704, is used to stop spoof attacks on the outbound side. The related settings from MikroTik we can find in the IP settings menu. If somebody you are used to the old version, they were actually in the firewall part, but now they are in the new menu IP settings. We have three options there. Default is no, so it's disabled. We have the strict and the loose version. Basically what's happening here. So the router will ask to itself, do I have a matching entry for the source IP on the routing table? Okay, so I will accept that packet, and that's the loose version. Okay, we'll just check if there are matching entry on the routing table. That's default routing on the border gateway is not just good. So in the strict version, what happens is the router will also check if the packet is arriving on the same interface the router would use to reach the originator of the packet. That's the strict version. Strict version usage is limited. Why? Because the nature of the internet, the nature of the routing of the internet is asymmetric. So most of the time, for the routing table, the router will try to send out the packet as fast as possible, the best route he has, but we receive the packet coming in from another interface, and that's actually a limit. The underlying principle of RP filter is to block outbound traffic if the IP does not belong to the subnet that resides on the line. What are the drawbacks of this? To be truly effective, RP filter should be implemented in front of any potential source of attack. If asymmetric routing is taking place on the border gateway, then only loose method can be used. And there is the bad one is actually that sometimes the attacker can spoof source IPs from within the same autonomous system, making this strategy easily vulnerable. And the bigger the autonomous system is, the bigger the problem becomes, because he can actually spoof a lot of IPs, and they are within the AS, so you cannot intercept them on the border gateways. Okay, so Matthew?
Maybe to add, yeah, I'll go on the black hole to add to this one, the last part. Well, basically what we are saying here is that you are an ISP and you have thousands of IPs, and the same one of your own clients is faking the IP address of the other clients. So basically, when you put the filters on your gateway routers so that nothing leaves your network which doesn't belong to you, still someone is doing that maliciously. Why? Because he's taking your own IPs, because he's your client, but instead of using his own IP, he's taking the IPs of other clients on the network, faking them, spoofing them. So then, you can't really identify straight away what is happening. Obviously, it is easier in that case to try and identify who is doing this. But it, yet again, takes more work, and this feature will not help us in that case to solve such a problem. The other option we have is routing black hole. The underlying idea is to black hole offending AS from the local network, so traffic is not routed from the border router to the LAN. So basically, this will help us internally. We say, okay, this is sending malicious traffic, so we add it in the black hole list, so then everyone in our network will ignore it, basically. The IP being targeted is no longer reachable, but the rest of the network stays up. Okay? We have advantages and disadvantages of routing black hole as well. Our attacked IP range will appear dead to the attacker. Why? Because the only thing we could do, we could say, listen, this range, this IP address which is being attacked on our network is no longer reachable. So our client has gone offline, and that is basically what the attacker is trying to achieve. But In that case, what we're doing, we are making them think that they have succeeded, while we can still exchange data with everyone else. The disadvantage, depending on the type of attack, lots of packets could be sent using spoof source IP addresses. It could be the case that if we also have servers with the same flow, we have equipment, network, router servers, which have a bot on them, basically, or a misconfigured DNS service or a misconfigured NTP service, these would be targeted on our network, so packets, a small packet is sent to them, and the bigger packet is sent out, basically causing a root reflection from our network. So basically, we would be helping the attacker on the other end. Our network would be doing that. So we have to be aware, and it is why monitoring is important, to try and understand and figure out what's happening in the traffic in our network.
So basically, what's happening here that the network you are accusing is actually the victim. It's not really attacking the network, because you will see the attack coming from that network, but it's not the original network that's been spoofed. Okay. So in this case, that won't help very much. And then we step to the firewall level, right? Okay. So what kind of attack can we mitigate at firewall level? SIM floats, the third packet attack, SIM+SEC, and reduce the impact of the reflection attack. So, do you think it's so hard to conduct such an attack? Because it is really not. Do you think we can actually make this router go off using only 20-25% of CPU of this other router? Shall I check? Okay, so we have prepared for you two simple routers, nothing special, wireless disabled, no special rules, no special services, nothing. CPUs, you can look at it, it's almost 0% of both, so nothing is running on them. And in our forgery, we have prepared some special SYN injection forged packet here to inject to the other router. So we'll be basically targeting this router here. Which is actually injecting also power, so it's just rebooted. Okay, from this router here. And we will not use more than 30% CPU to do that. It's coming up. 2 bips, 2 MikroTik bips. So, 2 simple routers. Let's start. Let's take a look at CPU values. So we are using a traffic generator to inject packets. As you can see, we are injecting around 20,000 packets per second. A little bit more, 30, okay. So look at the CPU of the second router. It's spiking up. And let's have a look at the connection tracking. It's not coming up, isn't it? So we're actually conducting here the attack towards the stack. Okay, you can see that the CPU is 100%, the router is not really responsive. If we increase a little bit the amount of packets to be injected, it will be actually, and it did last time, reboot. Okay. Look at the CPU of the other router. That's what we are using to actually generate the packets is 25%. Not so much, really. And the packet we have used is a simple SYN packet that we have created using a template of the traffic generator. And another thing is that you can see all the entries in the connection tracking. Of course, we have to manipulate the little bit the source port to make it so big. Okay, we'll go. Go back to the presentation.
So basically, as we said at the firewall level, this could be an attack done to us on any equipment, which basically there is a TCP. This was an example of a TCP SYN attack. So this could happen to any TCP listening TCP port. It could be if we leave, for example, MikroTik port 80 for the management. It could be for the Winbox management on port 8291. We're going to now look into what issues we have, what things we can use to help us in this situation. And one of them would be the address list. The purpose of an address list is to use the group block of IP addresses. The nice thing about it is that such addresses can be added to these lists both statically and dynamically. And when we're starting to speak about adding such IP addresses dynamically to a list, it's when things start to become interesting. Requirements. The requirement is to identify the host network exceeding our parameters and block them accordingly. So basically, if we have monitoring tools, if we know what the standard type of traffic of our network is, for example, I know our network usually is generating around 200 megabits per second and has, 60,000 packets per second, we can use those as a metric to identify how our network is usually operating. And then we can use such rules, we can use firewall rules to say, listen, if we're getting more traffic than we'd normally get, we can then consider these as being an attack, and we could work accordingly.
Relevant router OS comments. Let's make it bigger. That's right. Yeah, that's it. So, So, what's happening here? We are the command that related to this. What are we doing here? We are just adding to a list that we call suspicious for any destination port 23 for further elaboration in another part of the firewall. In this case, it was the filter part, where we can actually do something with this. The most important thing is that we can actually use all the matching powerful functions of the MikroTik to identify an IP address, and we can put such an IP address into a list, and then we can do anything we want with that basically with that list. In this case, we just use it to log for something. It's just an example. Doesn't have to be. Doesn't mean anything about the solution. Okay. What do we need to understand if the system was under attack? What was the first thing we did to look at when we were looking at the other router was actually the CPU. So the CPU, and we have another nice tool in MikroTik, which is System Profile. It will tell us actually what is happening and which part of the router OS is taking most of the CPU. Then we can look at the stats, and we can look at the connection. Just as we did before, but we have to take care when looking at the connections. Why? Because the same fact that we are actually pulling the connection from the router will put some overload on the CPU itself. So the fact that we are actually looking at the connection, the table of the connection is coming towards us, will put the router some work. Okay? So another tool that is widely used to protect internal servers is the network address translation. I would say used with care. I would say why? It enables the translation of an IP address used within a network to a different IP address known within a network. As Tom would say, NAT saves a lot of S's, okay, around the world. That's probably why IPv6 is not really, being pushed, because maybe you don't want to expose any internal network, all the internal network to the internet. So what happens here is the commands are IP firewall NAT. What's the base idea? The base idea is we are using a a server on the local network. This server has a dedicated process on it, that's a mission critical service. So good guys are allowed to be DNetted, are allowed to access from the outside to the server. Bad guys, no DNet. So connection stops on the router. Net is commonly accepted as a basic way to avoid DOS attack, not DDoS. It does not really solve the problem. It does not solve the problem. It moves it away by stopping unsolicited inbound traffic from reaching the host on the LAN. Depending on the intensity of the attack, net might turn against you. That's why I tell you, use with care. So if you don't have an enough powerful router, actually what will happen that you will create a single bottleneck for the attacker, a single point to attack. So you're just like exposing your target, okay? And that would be the NAT router itself.
Another thing we can do with NAT basically, from the corporate perspective, we have a service running, a website which is running in our corporate environment, and we have one internet connection, and we are hiding our server behind a NAT. Basically, it's an DMZ. And basically, the internet connection which we have is being attacked. Hopefully, if we want this setup to be up and running, we would have a second internet connection. In many cases, if we are the service provider, I mean, there's nothing much we can do. It's a big attack. We have to speak to someone else. The same if you're the client and your link is being attacked. You have to call your ISP. If you have two links, basically what you could do, you could help yourself with DNS before speaking to your ISP, and let me change the IP of my service from internet connection 1 to internet connection 2. Hopefully the person attacking you at that point in time, if he's really targeting you, until he notices you change your service to a different IP address, it gives you some time for your service to be back up and running on the other internet connection. It could be obviously that this guy decides to start attacking you as well on the other internet connection. But maybe by that time, you have spoken to your first ISP and told him, listen, I'm being attacked. This is the guy attacking me. Can you black hole the IP address? And maybe that can take place. So
give us some time.
These are options which we can do as the end user, as the last end, to try and avoid a situation with a DOS. And the next feature we have, which helps in situations like the TCP SYN attack, which we showed earlier, is the feature which is called TCP SYN cookie. The TCP SYN cookie is a technique used to resist SYN flood attacks by manipulating the sequence number in the TCP header. Basically, it's an option which does have a performance implication. So in general, this option should be avoided, should be left off. But in cases where we are seeing a high number of SYN attacks coming against us or coming to our network, it's an option, it's a feature which we could enable to try and reduce this effect.
So what is actually happening, how SYN cookies are implemented just in brief, is what is happening that we are actually receiving the SYN, and we are manipulating the sequence number, so we are actually hiding, using a part of the header in the response to actually encode the sequence number and an SHA, which is a key that requires some process to be elaborate. And so we will know when the third packet's coming, the SYN plus SEC packet, that it was from the original server that sent it. So basically we are authenticating the three-way handshake with SYN cookie. But this has some big performance implications that you won't see probably, but your client will, because it doesn't really break the protocol, but without all the TCP options available, it will lead to a reduction in performance, especially for the Windows scale. It would be nice if it could be enabled on port basis. That means I want TCP SYN cookies only for service that is running on this port, but this is nowadays cannot be done yet because it's a limitation within the Linux kernel. Okay? We have just two options in mind, just yes and no. Another tool that we can use, not actually to mitigate DOS attacks, but to detect them, is the PSD, port scan detection. It's a firewall matcher included in root OS used to detect TCP and UDP scans. How does it work? Basically, what it does is assigns a weight to low port range and another weight to high port range, and it will try to detect if the connections are coming from the same source to the same destination within a certain range of time, which is actually the delay threshold that you can see here. So if that, or if the sum of that goes over the threshold, then we will match with the rule. This is actually what is happening. So what this means, if the structure you are seeing on the screen means if a SIM packet on 1024, then assign a weight of 3. And a SIM packet with a port higher than 1024, then assign a weight of 1. Sum the weights if the packet has been seen within 2 seconds, which is actually the timeout that you can see here. And if we reach a total of 18, then match. What do we do with that match? We are basically normally adding that to an address list. What have you seen in this morning presentation, Tom's? Actually, it was kind of the attacker was studying Tom networks. No, there was a first attack towards the network, like to see how the network would respond to such an attack. And then there was the real attack that led about 1 gigabit of throughput. Okay? So if we can detect the attack first, if we can actually at least alert us that somebody is conducting a port scan to understand how our internal network works, then we can basically be in alert and avoid this. So it's not a true aid against the DDoS attack, but it can be useful to identify the offending networks. It can be used in combination with address list, provided that the connection tracking is already enabled on your firewall. PSD does not have an impact on resources such as CPU. But the best match to identify the flows that exceed a given limit is the DST limit. I mean, the best amount limit as well. So IP firewall, chain prelude in this case, what are we, product is with DST limit 25.1. So what are we doing? Match packets until a given packet per second limit is exceeded for every destination IP address and IP destination and combination. So in this case, the matching is reversed. We are always matching until certain level has. Okay, so we are matching, we are accepting a small level of connection. For example, in this case, we are using accept. And then whatever is over this limit that we set, we don't match anymore. So there must be another rule that basically stops it. So let's see if Matthew can help us in putting everything together.
So basically, the first slide we have here is an example which can be taken from MikroTik Wiki, which is basically doing exactly that. So our aim here is to try and avoid people trying to brute force our services, trying to find a flaw. So when we're talking about port scan detection, the first thing we are trying to do is say, listen, if someone is trying to find flaws in our network, maybe open DNS servers, maybe open NTP servers, we try not to give him that advantage. So if we want, we try and say, okay, this guy is hammering too much port 53, or this guy is trying to connect too much to port 123. So we want to allow him, in the case of the destination feature, to connect up to 5 times in a period of time. If he's trying to connect this port more often, it means that he's trying to do something harmful, because the standard protocol, the standard approach would be to make a DNS query, for example, and then fetch the website, or request the time, and that's basically it. You don't need to request the time over and over again. You know, so we're trying to look into this information and try and identify these IPs which are potentially harmful. Because if we manage to collect these in an address list, we could, even if we had the first attack, if it wasn't big enough, if we can contain it, avoid that this attack affects us again if it comes again at a later stage from the same set of IP addresses, because the guys who are trying to attack us have a pool of IPs, and it's very difficult that in the second attack they have a different pool of IPs. So we try and avoid that situation. So what do we use here?
So this is a solution that is actually has been implemented into the router we were seeing before. So we should now, the slide will be available, so you don't have to take pictures or something. We don't want to go over all the comments. It's basically a repeating of what we were saying before. We're using just a separate chain here. So let's do it practically within the MikroTik router. So see our
So we have the left router, which was the attacking router before, and the right router, which is the one which was attacked, which had the TCP issue. Okay. So
I think it's the wrong thing.
Oh, sorry. Thank you. So the left one was the attacking one, and the right one was the one which was flooded with the SYN attack. So basically, so there we have the profiler as well, so we can see. And over here we have the script, okay, in this chain. We call it a DDoS chain, which is basically, first of all, we have the two rules, because this was taken from a live environment. The first rules is basically taking two address lists, which will ignore DDoSes coming again from our own IPs. We're saying, listen, from our own IPs within our own network, we shouldn't be getting any DDoS, basically. So we're ignoring them from here. Rule number 2 here is the one which is using the DST limit feature, which is basically saying, listen, I'm going to allow up to a rate of 25 connections per second, and if I see this type of connection coming and taking my network, I will basically add the source address to an address list. Okay. Once that happens, okay, basically this rule all it's doing is accepting the first 25 connections. If more than that happen, then the address is going to go into an addresses, which is going, in this case, the DOS flood. In our environment here, we're sending a SYN attack directly to MikroTik itself. So basically, we have to filter that, we have to catch that in the input chain. Okay? At this point in time, the first rule will say drop anything which has been added to that chain. Okay? But before, the chain was disabled. So since it was disabled, we're not doing any better matching. So at this point in time, we're going to add that chain again. We're going to enable it so it is being checked. And again, we're going to launch an attack. Okay. So in this case, we still have a CPU which is high, but our situation is now handling the problem, because if we go to the connection tracking, we can see that some of the connections were picked up when the attack first started, okay? But exactly after the attack started, MikroTik realized, oh, there's something wrong, this guy is attacking me. So the address of the attacker has gone into an address list. And actually that is an address list, an address which is being spoofed.
So look at actually the rules that are matching. This one was matching until the connections reached a certain level. Now it's not matching anymore because it's matching until certain. And now that address has gone into the address list. And so because it's on the address list, it basically gets dropped now. It is on the input chain. There it is. Okay? So let's go. Let's stop the attack. Otherwise, my MikroTik has basically. Okay, you see? CPU now go 2%. Start again. it's handling pretty well.
Obviously, like in the same way we can protect our own MikroTik, like we're doing here, we would protect any other service which would be running behind our network. In this case, obviously, we're seeing higher CPU because the IP being attacked is the IP of the MikroTik itself. But we could have servers behind it, which the MikroTik is protecting, and this would avoid the packets ever reaching our equipment, basically.
So, fancy ideas. One Matthew already discovered, DNS plus NAT. So the idea is needs to have two feeds, two completely separate feeds, and our DNS with a very short time to live. So what's happening? The server will be known as one IP, but if that IP is under attack, we will basically switch the DNS supply to the other IP. And our attacker will keep on going on that IP. And our server will be serving normally other clients from the other IP, the correct response. The remotely triggered black hole, basically the idea is to inject a new route into our BGP. Now I'm talking about our BGP. So that way we don't have to deal with address list because it will automatically block all the offending IPs, all the offending prefix within the IS without having to elaborate any access list. And the other idea is that requires the upstream provider cooperation, but we know they will cooperate because basically we save them bandwidth, is to create a BGP community that our stream can black hole. So we basically are communicating to our upstream provider, I don't want to receive traffic from those IPs, so black hole them for me. Having an external source feed with details of common trees originating prefix on the internet updated via BGP. One example is, for example, Team Simbro. That's a really, really nice solution too, because they keep it updated. They don't only have bogon IPs, they also have IP that have not been assigned. They also have IP that are commonly originating some thread. And that will help us to avoid have to use complex address lists like IP, non-routable IP lists, etc., etc. Basically, as we've seen, DOS and DDoS attacks can be conducted at any level. There are few solutions to mitigate DOS attack at both the router level and the firewall level. However, almost any service may be overloaded by a very large number of requests. Hardware here plays again an important part. A faster router, a faster server, a bigger bandwidth channel will make a huge difference when trying to resist a DDoS attack. Those are the references. The diagram was taken from US CERT, and thank you to Norse for their map. Thank you. That will be all. If there are any questions, I'll be available to answer.
While the next presentation is being set up, I wanted to remind you that these videos, these presentations are being recorded and will be available on our webpage. And also you can tell your colleagues and friends that we have live video streaming of this event. You can go to our MikroTik webpage. On the main page there is a link to the live video stream. And your colleagues can see these presentations online in real time. I also wanted to remind you that if you have any questions about hardware or software, you can ask the MikroTik people in the red staff shirts, and we have a MikroTik table with the new hardware in the exhibits hall. So right on the right side when you enter the first table on the right, my colleagues Martins and Yanis will answer all your questions about our products.
Okay, good afternoon everybody. Have we got the good audio at the back? Can you hear me guys at the back? So you haven't fallen asleep yet? Give me half an hour, you'll be fast asleep. I hope not, only joking. Okay, I'm from the UK, I'm from England, and hopefully I'm going to give you a little bit of insight into sort of the RF, the actual radio wireless side of the MikroTik products, what's actually being radiated and some of the problems you might have. So where have I come from? At vast government expense, I was trained and worked in the UK government on various wireless projects and gained my skills from that, and then eventually at the prime age of about 45 years of age, the government decided they didn't want to pay out such large amounts of money for radio engineers anymore. They were way too expensive, so they got rid of a whole load of us in a mass redundancy plan, which paid off my mortgage on my house, so thank you very much for all your taxes that you've paid to pay off my house for me, thank you. But then I got involved in doing consultancy and doing training, because all that knowledge and experience that got inside my head, I wanted to pass that on. I'm not someone who believes in keeping it all to myself. I think it's more important that we pass this information on and this trade. And certainly the black art of wireless is something that can be very much of a mystery because it's difficult to see. I'm talking about difficult to see, I can't even see my own laptop. Okay. One of the other things is I'm a member of a sort of like a little mini exclusive club of MikroTik consultants on a website called rootedworld.com, where you can see some of the really big major projects that we've been involved in all the way around the world. So go and have a look at the website, and I think that one of my colleagues in the team will be talking about that on another talk. Okay, I'm now currently working for a MikroTik distributor in the UK called LinITX. I know it looks like it says Linitics, but it isn't, it's LinITX. We are the largest MikroTik distributor in the United Kingdom. We have the largest number of MikroTik consultants, and we provide quite a lot of support, third line support, even in some cases first line support for wireless ISPs and also the more traditional ISPs who are using now the latest ranges of cloud core routers in their data centers for shifting quite large amounts of gigabits of traffic. Multiple peers with BGP all running on cloud core routers without any issues at all at substantially reduced price compared to other vendors. So that's our business, that's where we've come from. Why am I here today? Teach you a little bit about wireless. finish the sales, straight into wireless. It's not something that you can see. If it's certainly a high enough transmitter power, you can feel it. But normally you can't see it, it's invisible. You need some tools to actually help you to work out what's going on. You may have point-to-point links, point-to-multipoint links that are failing, causing you high levels of CCQ, creating errors, and you can't immediately understand why this is the case. You may have changed frequency, thinking, oh, it's an interference problem. There's possibly someone on the same channel as me. I'll move the frequency to somewhere else. What tools do you use? And you might be using the snooper tool, wireless scanning tools. You might be using the Dude with its spectrum analyzer. Very, very powerful built-in function, totally provided free with the product. That might guide you to a quieter frequency, but you're still getting errors. You've still got poor CCQ. So what you might then think about doing is you climb the tower, you change the equipment for a brand new piece of kit, and the problem goes away. And the products are such low cost that you throw that in the bin, you throw that in the trash can, your problems are finished, you go on to the next problem after that. But as a distributor, we do get some of these products returned back to us on RMA. Fortunately, MikroTik has a very, very low RMA rate. We find they're very reliable, but the cards that we do get come back, I get to have a little play with them when I've got some spare time, and it's very illuminating as to what's actually physically happened to them when they have failed. The part of the wireless card that is working the hardest and is generating the most amount of heat is the transmitter. When they get hot, they will eventually fail. That's the one thing about electronics. We know it is guaranteed, absolutely, that at some point in time in the future, it will fail. Now all we have to figure out is the precise moment when it will fail. That is a lot more difficult. So we know it's going to fail, and when it does, we get them come back to us, possibly because it's still under warranty, and then we go and have a look, find out what's gone on. So I've got some nice pretty pictures of what we've discovered. If you want to do this for yourself, you might actually use the free tools that are provided by MikroTik, like the built-in spectrum analyzer tool in the Dude, which is very, very good. You might use some expensive equipment from HP and from Rohde & Schwarz, which is what we do. Or you might go for some more of the lower cost independent third-party solutions that can provide you with some quite good tools at a very low cost. The benefit of using the MikroTik built-in spectrum analyzer in Router OS is you are actually using the real link itself. You're actually looking down the antenna bore, you're looking down the shot of where that antenna is looking. So you are now beamed on where your problems may be coming from. So it's a very, very good way of figuring out what's going on with a link. But obviously you need the Dude, and you need then to run the spectrum analyzer view. Quick hands up, how many people are using the Dudes in their network? Yeah, damn good proportion of you. Great. But ultimately, if you've got the card on your bench, if you've got it back in the lab, if you get it back to us, we'll put it on a analyzer and actually have a look, see what's going on. It could be that the card hasn't actually gone faulty. It could be that you're operating the card in a mode, in a manner that is not recommended. Just because you can type in values into the settings for the card to say you're doing it correctly. MikroTik trusts you to know what you are doing. They provide you the tools. They provide you with the power to be able to do these things, but ultimately it's up to you to be intelligent and knowledgeable enough to put the correct settings into the wireless card to make sure it functions optimally. I hope at the end of my talk you'll have a better idea of what those values are going to be and how you should set it up correctly. So you might think you want to set it up in a certain way, that's your theory. You want to run it at a certain transmitter power. You may have done the link calculations, you have a link budget, you know what your country's own internal regulatory transmitter power limits are, and you've now made sure that everything is all legit, you've got all the settings correct, but things still don't quite work as well as you expected. So what's happening? It could be that something has failed. It does happen. You ever seen those traditional graphs they draw of the failure rate over time, and it looks like a bell curve that the manufacturer will say that the majority of the failures will occur after so many years, but there will still be a small percentage that fail on day one. It happens. But the majority will fail at some time in the future. It could be that the card has not actually completely, totally failed. It could be that it's not as simple and as straightforward as that it just doesn't work. Those are easy to figure out, because the link won't come up. And you change the card for a new one, it works beautiful. You have a broken, completely zero output transmitter. That's an easy one. But what if the transmitter is not actually transmitting at full power, it's transmitting low power? That starts to get a little bit more difficult to figure out. What if the transmitter is not just transmitting on the channel that you've set it to, but it's also generating what's called spurious transmissions all the way up and down the band, and is then affecting and causing interference to other co-located users in the spectrum band that you're using? It's very, very difficult to figure out. So what I did, I used a calibrated Roden-Schwarz spectrum analyzer with attenuators and just connected it to one of the chains at a time. It is quite possible that just one of the chains, one of the output feeds, has failed, not one or all of them. You have to check them all. So if it's the net metal triple chain, you're going to have to test all three outputs. So I did that, and I also made sure that I put the other outputs onto a dummy load. 50 ohm resistive load, and that then made sure that even if it was accidentally transmitting some RF out of the other ports I wasn't testing, it wouldn't affect the results. So how about some of the lovely things that I've seen? Now, you've all seen the diagrams. For those who are interested in looking at this in deeper detail, you've looked at the diagrams of what a typical 802.11n or AC radio transmission shape should look like. Fairly flat at the top, with a little notch in the middle, fast rolling off sides, and then a slope down the sides further down. But what the hell is that thing going up at on the lower frequency end? The card has a built-in EEPROM chipset which stores a data table of what transmitter powers should be coming out of the card for which frequency. So something has gone wrong with this card because it is incorrectly setting the transmitter power at a higher level at one part of its transmission compared to the rest. Same again. It's gone a bit wonky, it's not flat anymore. Now that's going to cause, all these sort of shapes are going to cause errors within the radio transmission. You will look at the signal levels, and the actual number of dBms that you find in the status information in router OS will probably give quite a healthy signal strength level. But because you can't see the strange, weird shape that it's got, that's going to cause errors. You're going to get what's actually called a very high EVM, an error vector magnitude value. The actual higher data rates will not sync up, and it will only stay at the low rates. You'll never be able to get the thing to rise up to the higher modulation rates, because the errors become so great in being able to decode the constellation diagram of the QAM modulation system. Too many errors, it falls over and drops to a lower speed. What's happened here? Here is another card that the way in which the actual QAM, the quadrature amplitude modulation system, is generated is done from two subcarriers, which are then mixed together 90 degrees out of phase with each other. If that mixing process in the chipset fails and doesn't work correctly, you end up with a spurious RF radio carrier right slap in the middle. Even though that's a faulty transmission, you can see there's a notch in the middle. In that one, there is a notch in the middle. That's not a notch. That's actually radiating power in the very, very center of the frequency, which there should not be any carrier there. That should be no transmission at all. This one, the power amplifier, the PA, the power amplifier, the transistors that actually boost the transmitter power coming out of the Atheros chip, has failed. You can see that that is not as small a radio transmission as you would expect to see from the traditional diagrams you've seen. It certainly doesn't look as nice and shaped like that, with the flat sides or the slowly sloping off sides. That's going to cause a lot of interference to other users, or maybe even your own sectors and your own point-to-point links on adjacent channels, isn't it? It's spreading quite a long way to each side. If you look at a really, really much wider view, if we zoom out and look at the radio spectrum coming from a card, which is perfectly healthy, this is a good working card. It's a 5 gig transmission. We're looking at a 1 gigahertz span across the whole of the analyzer. I don't see any other radio transmissions coming from that card. That's a faulty one. So once again, that's going to be causing problems to co-located adjacent channel or anyone else in the same band as you. And the levels at which these are being transmitted at are, as you can see, 40 odd dB down. Some distance away from the site, those little spurious subcarriers will probably be undetectable. But if you're using the same site with other frequencies in the band, especially lower down than this one was on, that's going to cause you a lot of interference. If you're operating a 40 megahertz system, you have a main control channel on the main 20 megahertz channel that you've set the frequency to, and then you have an additional 20 megahertz channel as an extension channel. Very crudely, very simply, you're bonding 2 channels together to double the bandwidth, to double the throughput. But what's happened here is that when the chipset has generated the extension channel, it's at a completely different power level to the main control channel. They should be absolutely flat with each other, but it's not. It's actually gone and dropped it by about 3 dB. If I went into the router OS settings and I changed it from upper to lower, so as to move the extension channel to either be above or below the main control channel, well then the thing flips over and just looks, but always has one higher than the other by about 3 dB, so that's not right either. Because then when you go to the higher data rates and you go to the higher MCS codes, and you're trying to go up to the 300 megabits per second data radio rates, you're never going to achieve it with as good a throughput as a working good quality card, because you're dropped by 3 dB in the extension channel. So those are some of the faults that you might be able to find. Now let's have a look at what happens when you set the actual transmitter power on the card and how you should be setting it correctly. You type a number in, you put 15 in, 15 dBm. Type the number 15 in, what are you going to get out? You're going to get 15 dBm out? Can you guess where this is going? You don't really know unless you measure it. And there's also some little tricks about tolerance. I'll show you a table, for example, that Atheros says about what power you put in and what you're actually going to get in reality. But there is a feature. When the AC chipsets came in, MikroTik wrote the wireless FP package to provide the AC drivers, but the way in which the power is displayed is slightly different. If it is running a traditional N chipset, then the 2 chains will add together to give you an extra 3 dB power. So it will say to you, for example, that one of the chains is 27 dBm, the other one is 27 dBm. In the status information, you have to add those 2 together to know that in reality it's actually genuinely putting into your antenna 30 dBm, because it's adding 2 chains together. And if we double the power from the 2 chains, we're doubling the power, that's a 3 dB increase. But that's not the case if you're running AC mode. The AC modes, the AC chipsets, if you set it to 27 dBm, it will automatically compensate for when you add the additional chains. So if you add a second chain by having an extension channel, it will display in the status information that it is still 27 dBm. But the reality is it's actually now 2 lots of 24, making 27. So you need to bear that in mind when you are doing your regulatory EIRP calculations. So then we come down to one of the best chipset manufacturers that MikroTik's using, the Atheros, the Qualcomm Atheros chipsets. What do they actually say is their guaranteed manufacturer's output power? You notice, if you can see that, it says that they will guarantee that the chips will generate an output power that is within plus or minus 2 dB. In good old wet finger out there in the real world values, that's nearly-ish double. Plus or minus 2 dB is actually a 4 dB range, so it could be that you're getting out from your card 2 dB less than what you set it to. Maybe that might help you with some of your links, so that when your regulatory engineer comes to visit you, you say, oh, I've taken into account that the card is running 2 dB down. And then he says, yeah, but I'm taking into account that it's running 2 dB up. But that straight away is telling you already that what you type in is not necessarily what you get. The other thing is that if you're going to measure the transmitter power, there's actually very, very limited amount of tools available. There aren't very, very good, high quality, low cost transmitter power meters. So the only way you're going to really, really know for sure what your transmitter power is and what your EIRP is out of the antenna is if you actually measure it with something that is trusted, calibrated and traceable back to a national standard. In the UK, the equipment can be calibrated back to a standard that's maintained by the National Physics Laboratory. I mean, in the States it's NIST. So let's have a little question about making measurements and actually having a value. Which is the most accurate of the two? If I write down that the transmitter power is 23.4376, is that more accurate than 23.4? Put your hands up if you think that A is more accurate. Put your hands up if you think A is more accurate. And put your hands up if you think B is more accurate. The answer is you don't know. You don't know because we don't know what's called the uncertainty value is. What is the uncertainty? Uncertainty is a value which can be provided by a manufacturer of the test equipment to say, do you know, I don't really know exactly what value I'm measuring within a range of plus or minus so many dB. I know it's roughly this value, but it could be in error by plus or minus so many dB. This is a calibrated, accurate, I don't know. But that's the only thing we can do. So you're actually taking a piece of equipment to a laboratory and asking them to calibrate it and to tell you what is the uncertainty value. How much they think it is most likely to be in error by. And various equipment manufacturers will quote that. So I've been using a Rohde & Schwarz FSH 828, which goes up to 8 gigahertz. And it has some tools built into it for measuring power, which is cool, because one of the things about Wi-Fi, because ultimately that's what all this stuff is, I know we're using NV2 and it's a TDMA-based protocol, but ultimately it's still using the standard Atheros Wi-Fi chipsets. They're pulsed. They are not 100% duty cycle. They're roughly 50% duty cycle. So to measure the power of something that is only there for half the time is not really as straightforward as it first appears. So that luckily, Rohde & Schwarz at enormous expense have provided the tools there for me. So I can feed a NV2 TDMA-based transmission system into this and it will tell me exactly how much power I'm feeding into it. But how accurate do I know it is? I can look it up. So even though the equipment's got a calibration certificate, Roden Forge states that if I'm making measurements at around 2.4 gigs, they believe that the equipment is likely to be better than 1 dB. So what they display on the screen will be within 1 dB of reality. But typically, most of the time, if it's been calibrated and adjusted correctly by the laboratory at the calibration house, you should be able to achieve an accuracy of 0.5 dB. So that's the uncertainty value. At 5 gigs, it goes up to double that. They say typically should be within 1 dB of what you've measured. So if you've got something that says, I've measured the value as 23.4376 dBm, because that's what it says on the screen, we now know that that's rubbish, that's stupid, because the uncertainty value is 1 dB. So really all we can say is 23. It's neither of those. So once again, I connected the equipment up and I had a look at see what was going on with transmitter powers. So I had a look at setting the card to 10 dBm. I entered in 10, and then I measured the power across the frequency band of 2.4 gigs from a typical MikroTik card, an R52HN. A good workhorse, it's proved to be very reliable. And what I've actually measured is within 1 dB. Remember the 1 dB in uncertainty of my measurement, so that is a measurement of within plus or minus 1 dB or so. So that's good. That means that if you operate that card across the 2.4 gigahertz band, it's going to get roughly the same amount of power across, no matter what frequency you use, it's going to output the same amount of power. What happens when we do it on 5 gigs? It looks more scary than it is, because the scaling of that is quite detailed. It's going from 17 to 12, that's a 5 dBm range on the vertical axis. But across the 5 gigahertz Wi-Fi, the international 5 gigahertz spectrum, that's within plus or minus 2 dB. But it's not a flat line, is it? It's curved in a very strange and odd way. There's nothing wrong with that. It's perfectly normal. But remember what I said at the beginning, that what you get is not necessarily what you thought you were going to get. Now let's have a look what happens if I again use 2.4 gigs, but I change the transmitter power setting. Start from a very low value and go up to the whatever is the maximum card transmitter power, which I think in this case was 23 dBm. That's fine. That's still within spec. Don't forget all the slides will be available on the MikroTik wiki, so you can get much better screenshots from this offline. Or no, online. The problem comes when you actually start to go down in power. So the previous ones, I stopped these measurements at 5 dBm. It's well within spec. Fairly flat line. Down below 5 dBm, things start to go a little crazy. The reality is, if I draw it as a curve, that's not a nice diagonal straight line. It's not linear. It flattens out at the top, and it definitely flattens out at the bottom. That's because the information that the manufacturer has stored within the EEPROM chipset part of the Atheros chip, the electrically erasable PROM, says you can't go more than that power, whatever it is, 23 dBm, because that's all the card is being manufactured to generate, is 23 dBm. If you try and push the electronics beyond 23 dBm, it will fail the ETSI technical parameters, and then it will lose its certification. A wireless card in the States under the FCC regulations, and here in Europe for the CE, the Euro the directives. So they have forcibly stopped you. So even though you can type in a higher value, you're not going to get it. And likewise at the bottom end, you can type in very, very low values. For example, I typed in -30. Did I get -30? No, I got -2, because it had already flattened out. I'd already got to the bottom of the curve, and the Atheros electronics has said, if you go any lower than that, it will cause problems with our certification. You are now taking the card outside of its devices. And Router OS and MikroTik as a company are actually taking that information that Atheros is providing them in that PROM chip and saying, well, if that's what you're telling us that this card can do, we'll believe you. And that's why you get this strange, weird shape. But the Router OS system does allow you to type in some crazy numbers. But that's not necessarily going to give you the right output. So if you're running a very, very high antenna gain on a point-to-point link, maybe 30 dBi gain, in the United Kingdom, the maximum allowed number of power, the maximum power is 36 dBm. So with a 30 dBi antenna, I need to set the transmitter power to 6 dBm. I can do that because luckily, if I set it to 6 dBm, I will get 6 dBm. So that means I can sleep at night and know that I'm not going to be overpowered. If you was to put a much higher gain antenna on such a card, and you did the calculations and it came out and said, I've worked out I need to put in 2 dBm, you can type it in, but you're not going to get it. You'll get more than that, because it's already limited and flattened out at the bottom. But you know, if you want to pay thousands of dollars for a card, you can get a much linear range, you can get a much greater amount of performance and much flatter line, and it'll be every single card will come off the production line and having been calibrated and tested and come with a certificate. But that's not the kind of money that you guys are paying, is it? $40, $50, $60 for a card, you're getting everything within the quoted specification from the manufacturer. No lies being told here, you just need to dig out the information and find it. Okay, another little thing that I'd like to touch on. 2.4 gigs. Can I have some hands up? How many of you guys are deploying enterprise, educationally, in buildings, Wi-Fi on 2.4 gigs? Putting Wi-Fi in for customers, large enterprise deployments perhaps. Following Leo's talk this morning about using Capsman, very easy to deploy Wi-Fi, but you have to go back to each of the radios and set them to the correct radio channel so they don't overlap. You can't very easily maintain a reliable network with a single channel architecture. You can't have the whole site on channel 1 or the whole site on channel 6. They'll all interfere with each other. So we know these plans by now, don't we, guys? We've seen the books, we've seen the movie. We make sure that we deploy our access points on 3 non-overlapping radio channels. 1, 6, 11. We know that, don't we? But are they actually non-overlapping? What I've done here is I've got 3 access points. They are overlapping. At very low down levels, I admit, about 30 dB down, they are definitely overlapping with each other. There's no trickery in this. So if you co-locate 3 access points in the same room, they're going to be seeing each other. Even though you have put them on 1, 6 and 11, you will find that there will be cross interference between 1 and 6 and also between 6 and 11. The only ones that you can really truly have as no interference at all is if you put it on 1 and 11. Makes it pretty damn hard though to deploy just 2 channels in a building, doesn't it? But just bear that in mind, okay? They are actually still overlapping. So the diagrams, that's a little bit fairyland. Fairyland says they are not overlapping at all, but the reality is that they still do. You need to put some distance between the channels, both physically in meters across the ground, or by putting building attenuation in the way. You need to get the overlap section right down so that they overlap at very, very low levels indeed, maybe at around 50, 60 dB down. On 5 gigs, if you are co-locating on 5 gigs, the problem has still not gone away, even though there's approximately 19 odd channels available in Europe for deploying Wi-Fi on 5 gigs. And the channels are now 4 channels apart because the channel numbering is 5 megahertz. So that's why it goes 36, 40, 44. They're actually jumping in 4 channels at a time, which is giving us a 20 megahertz channel step. If you put 2 access points in the same location on, say, 36 and 40, they'll interfere with each other. So you need to make sure that you move the channels further away, so in the same room you could deploy 36 and 44. So put a 20 megahertz gap in between the upper edge and the lower edge so that there's no overlap. Same thing applies if you're doing sectorial deployments. 3 sectors on a mast, you can't put them radiating on 3 adjacent channels. They will overlap, they will interfere, and you will get slower data rates. The other thing is, I don't know if that can be seen. Yes, it can. Good. Pigtails. You've got the blue MikroTik ones that are provided with antennas like the MAN 30, and there's loads of other pigtails available. Quite low loss usually, less than a dB loss, but the actual loss is not statically flat right across the band. It has actually got some resonances built into it due to reflections that occur between the 2 ends of the pigtail connections. You will get radio waves bouncing backwards and forwards, causing various reflections, and there's also the property of the length of the cable may be related to some fractional part of a wavelength. You'll always get a curve. And again, it is actually going up and down by about plus or minus half a dB. That's another dB of uncertainty thrown in. So when you're trying to calculate the EIRP, how do you know what you're really doing? There's a lot, yes, there is some guesswork in this, but try not to get too paranoid every single last decibel. To be honest, if your point-to-point link can't lose a few dB without it failing, you've done your job wrong in the first place. Because we all know about fade margins, we know that signals, the longer the link, the longer the distance of the link, the more fade there will be. You need to make sure you build in a budget, enough margin, so that your links stay up. So don't go chasing that one last dB. It really is not going to make any difference to the ultimate quality performance of the link. Okay, the last thing I'm going to mention is that what I've discovered from some of our customers is there's some confusion about the newer cards and the newer chipsets and recent versions of Router OS, and it's also mentioned is that you have to set the transmit power mode to all rates fixed. You don't actually have to set it to all rates fixed. You can set it to default. And there's a big difference between the way they work. If you leave it set at default, then it will totally take in the regulatory settings that you've inputted, and hopefully you have put in a country, and set it to regulatory domain. It will take that information from the chip as to what transmitter powers and frequencies are allowed in your country, and it will make sure that it performs correctly with the maximum transmitter power and the frequencies, but also there is another section built into the chipset that if you set it to default, it makes sure that when you go to the higher modulation data rates, it brings the transmitter power down. It forcibly reduces the power. So even though you have programmed in plus 23, you may find you're not getting 23, you're You could be getting 17. Because the card manufacturer has said for us to maintain compliance, to meet the specification provided by ETSI, we need to bring the transmitter power down to stop the transmission widening up and spreading across into the adjacent channels, which would then mean that the card would then fail the CE certification and wouldn't be allowed to be sold or distributed in Europe. Same rules would apply in the States under the FCC regulations. So it takes that into account when you use default. If you use all rates fixed, that overrides that, and it says if you've typed in 20, you're going to get 20. If you type in 23, you will get 23, regardless of what modulation data rate it has risen up to. That then means that the ETSI spectral mask, you can find this in a very boring, long technical document on ETSI's website, but there is a spectral mask that all these transmissions must exactly fit into. Basically, if it's a 20 meg transmission, it's supposed to fit inside a 20 megahertz channel and not spread out into the adjacent channels. But you can see it still does, and they allow it to have these shoulders or these skirts that spread out slightly from the centre of the channel. That's allowed. You wouldn't be able to get the higher data rates if it didn't. So what's going to happen if I start increasing the transmitter power? I've set a card to all rates fixed. It's an R52NM, and I'm going to increase the transmitter power by 2 dB steps. So at 15 dBm, life is good. It's well within the spec of the card. I'm actually using traffic generator to artificially make it transmit broadcast traffic so as to push the data rate up to the highest data rates. So the card is nice and easily fits within the ETSI spectral mask and would therefore comply. We now start increasing the transmitter power. Oh dear. And that's what's actually happening now. You don't know that it's happening, you can't see that it's happening, but I can tell you that it is. If you use all rates fixed, and you use the higher transmitter powers, where normally, at the higher data rates, it would reduce the transmitter power automatically for you, you've overridden it, you've forced it not to do that, your channels will spread a lot further than perhaps you were thinking that they were. So there you go. There are still a couple of places left on my MTCWE training course next week. Quick bit of sales. I've got 2 seats left on the MTCW next week. If you want to learn a bit more about wireless and get more goodies out of my brain, feel free to be trained by me next week. If you come to me, I'll even give you a special discount. Included within the MTCWE training is a free net metal triple chain, which we'll take away with you because it saves me taking it back on my aeroplane, because they're heavy. So, thank you very much. You can now see that you don't always get what you want.
Okay, next presentation by Warner Maia from Brazil, Network Simulation.
Thank you. I would like to start introducing myself. My name is Warner Maia. I'm from Brazil, and I am an electronic and telecommunications engineer. I've been working as internet service provider since 1995, and in training business since 2002. As MikroTik trainer since 2007, and I am the CTO of MD Brazil, IT and Telecom, and member of the board of directors of LACNIC, the Internet Registry for Latin American and Caribbean. MD Brazil, IT and Telecom is a Brazilian company in São Paulo State, Brazil. We also MikroTik and we other brands like Gyros, Antennas. And we are a MikroTik training center since 2007, and we do consulting services worldwide, mainly in MikroTik, but also in another systems. More details about our company you can find in the URL. So this is my second time in Prague. It's eighth participation in months. I have some presentations more related to security, like my friend Paul Smith like to talk about security. But today I will try a different subject related more to network simulation. And the network simulation we will do with a software called GNS3 with focus in MikroTik OS. And the goals of this presentation is to share our experience in our company using GNS3 for the work and for the trainings, and to foster the use of simulators as a prediction tool and as a learning tool. And I would like to try to present a tutorial on how to install the software, how to use the software, and you see that it's very, very interesting. It's important to mention that other trainers had similar subjects in Indonesia and USA. This simulation tool was subject for presentations using Windows, and one using the Kik emulator and other using VirtualBox. Our presentation is another little bit different approach. We will try to install all the stuff in a Linux, Ubuntu, and we also make available an image for the ones that don't want to install on their machines. It's important to mention that GNS3 is not the only simulator. There are a lot of simulators like Glonix, Core, Marionette, Mininet, and you can find a lot of network simulators. This is an excellent link to see about open source simulators. Of course, each one has advantages for some situations. In our case, we choose GNS3 because it fits better in the kind of networks, IP networks that we work. So, our agenda today will be divided in 5 parts. The first part, we will talk a general talk and the motivations to talk about network simulators. And the second part, we will see how to install. We'll try to make a tutorial. And then we will create a simple project to see how easy it is to create projects in GNS3. And we'll do also a more complex scenario, a traffic engineering scenario, and see the advantages of using GNS3 as a learning tool. And final considerations and the links to download all the stuff. So, starting with the motivations, why use network simulators? Of course, we love to work with real routers, but in some cases it's better to use simulators. One of the reasons that I thought about this presentation was 2 years ago in Zagreb. I did a presentation about BGP filtering, and with this scenario here. And to simulate this scenario, I have to use 5 real routers, and I bring from Brazil with me 5 routers with a lot of cables, with power supplies, and stuff to join all the power supplies. It's a good bag to transport everything. In 2014, I decided to make a presentation about VPN. VPN is MPLS VPNs, the security of MPLS VPNs, and the scenario will be with 9 routers. So, to bring 9 routers with the cables, with the power supplies, etc., would be a mess. So I decided to research about the simulator, and we decided to start to work with simulators. So, with simulator, last year, with no physical routers, no cable, no power supply, we can do all the demonstrations without any problem. And on the backstage, after the presentation, several questions were asked about the tool we use to simulate it. So we decided this is a good subject to talk about simulation. We are using a network simulator in 2 areas, as a prediction tool and as a teaching and learning tool. As a prediction tool, the operators can simulate how some scenarios will behave before going to the real world. You can place the scenario, see how things work, and then go to the real world. You can also test software versions. When, for example, MikroTik releases a new version of Router OS, you can test it before going to the real routers. Interoperation with other vendors, because the software, in the same software, we can interact with Cisco, with Juniper, with other brands of Unix, all the stuff we can put in GNS3, and without any equipment, any physical equipment, we can test, we can make our labs. And in consulting services, is make fast and low cost proof of concept to the customers. You make the picture of the scenario, you put all the things to work and show to your customer, and then you can show how the things will work. So, a successful case in Brazil was one customer. They hired us to do a job, a consulting service. It was Brazilian Army, one part of Brazilian Army that takes care of the Amazon rainforest, and they have a big network with fiber, with radios, and the network interconnects several units, many in hard-to-reach locations. Some locations you have to go through the forest 3 or 4 days to get to that location. So our challenge was to implement in that network dynamic routing, IPsec encryption, POS, and other things like firewall without any interruption. Of course, it's a big work, and before we go to the real network, we place all the stuff working, we simulate the network, and it was very useful to us to decide how steps should be done first before go into the real implementation. As a teaching or a learning tool, the trainers can easily explain protocols, how protocols work, and trainers can explain scenarios without the need of lots of equipments. And students can have the labs on their pockets. They can go to a classroom and they go with the lab in his computer, and he can simulate the things in their houses. In online trainings, you can send the scenarios to the students, and the students can test, can interact with all the scenarios. In our company, we are using, during this year, mainly this year, the last year and this year, we are using a lot of GNS3 for our trainings. For example, we do a BGP class today with a virtual environment simulating the real internet. So the students can connect to sites, to remote sites as they are real, and so they can see how BGP works without the need of the internet, because every time we need the internet in some hotels, it's not possible because the link is very bad. So we cannot depend on the internet, and with a virtual environment, you can give such type of classes without any problem. MPLS labs are other kinds of labs that there are so many details in the configuration, and it's much more productive to show the scenario working before the students manipulate the real routers. We show a scenario, how it works and what we expect of the lab, and then the students go with the physical equipment and make the same. It's very, very useful for teaching. We intend to do this year new labs that in the past was impossible because of the time of the trainings. So, who will benefit with this? Trainers, of course, because they can improve the methods. The students, because they can get more from the trainings. The operators, that they can predict how things will work. And MikroTik community in general can share information using simulators, because it's very common to see in the forums some setups that are not working, and you can send the individual configuration of the routers, but it's much better if you send the scenario. I'm trying this scenario here, is not working. The other side can see and can see how which is wrong. So, the second part will show how to install. This is a tutorial, how to install all the stuff to simulate any type of network. So, we'll use these three tools here. GNS3, Quick Emulator, and the Dude. All the stuff installed over, you go to Gnome 14.04. GNS3 was originally developed for Cisco routers. It uses a software called Dynamips that emulates Cisco routers. And GNS3 offers also support for virtualization using Quick Emulator and VirtualBox. Quick Emulator is an open source software that can be used as an emulator or as a virtualization system. As an emulator, it can run direct on the PC, and as a virtualization system, it runs in the gas system directly using KVM. And several architectures of hardware can be supported, like MIPS, like ARM, PowerPC, and x86. So, we can simulate router OS we using QEMU or using VirtualBox. We did a lot of tests. In our tests, we decided to use QEMU because it's faster, it saves CPU, and our tests QEMU behave better. At the end of this presentation, we append some tests that we do. So, and the DUD will be used only as a front end for the simulations. In fact, the DUD will be used to hide some details, to make the scenarios cleaner, to make the facility of accessing directly the routers through the DUD. And then we use, it's not mandatory to use the DUD, but it's very interesting to use it in the simulations. So, to install all the things, here is step-to-step, and all the commands you go should be as a super user. So I suggest you first to being super user, and then this is a very important suggestion, because to make the process of exchange the projects between different machines is possible if they are in different paths. But if they are the same path, we can share the projects immediately. So I suggest to make a /SNGNS3 and put all the stuff in that directory. Is that way that we work in our company, and then we can share easily the projects each one is developing. So, in Ubuntu, you have to install all these dependencies, this stuff here and here. You have to install also Python and support for i386. You have to install Dynamips. Dynamips is to emulate Cisco routers, but even if you don't want to emulate Cisco routers, you need to install, because GNS3 needs some dependencies of Dynamips to work. So it's very interesting that we install Dynamips to make GNS3 work correctly. So, to test if the installation was successful, you do this command here, and you receive an output like that. GNS3 we will install from the source. The current version, by the time of this writing, is 1.2.3. You can change this if there is a new version. And you install also GNS3 GUI, and IOU is to emulate Cisco routers in Unix systems. So there's a step to create a license if you intend to work also with Cisco routers. You have to follow these steps. All you have to do is to copy and paste this file here and make it executable. And if you type this command here, you will receive an output like that. And this is the key that you put in this text file, and the license for Cisco is okay. So, after that, you have to install the QEMU, Keep Emulator, and the dude you have to install, follow the wiki. If you don't have Wine, install first Wine, and you won't have problems to install the dude. So, to launch GNS 3, it will be launched every time as super user. You go here and okay. If all the things were installed that way, you receive this screen here. So back to the presentation. Okay. The step now is to create the router OS image to GNS 3. You have to create an image. Keep Emulator supports a lot of type of images, and the preferred image is this one. We call it 2 because it is more portable and it saves space, because you will define, for example, this size of file, but it will use only the space needed. The image grows as necessary. So you can also use the raw format. We did some tests and we didn't notice some difference in performance nor in space. Of course, is different. So and then you can install using this command here. So this is the creation, and then now the system is installing the MikroTik. Of course, previously I downloaded the .iso image from MikroTik website. It's in the same directory, and you get a screen like that. If you want to install all this stuff, you can click here. We will install only the minimum for the demonstrations only. You install on the system. Install. Yes, yes. Okay. The system is installing as usual. And now we have sorry. Okay, at this moment we will have a MikroTik installed, and you have to access this Sorry. Okay, you have the image, the level 0, the image 24 hours for use without license. And then, if you want to put this image in GNS3, it's ready. But every time you create a new router, the time will count and you can lose your project. So it's very interesting to license one image to put first and then put in GNS3 to preserve the projects. So you can license here. In this stage, we don't have contact with my machine with this image, and the only way is to place manually the license, that big amount of characters, but we will see how to access this image without the need of putting that way. So, but it's very interesting that we license the image now. So, if we skip this step, every time we want to go and to open the image, the QEMU image, we can type this command here, and we'll get the same access to the image. So, very important to mention is that the interface Ethernet is the same MAC address. When you put it in GNS3, is the same MAC address, and in GNS3, Ether 0 is Ether 1 of router OS, and Ether 1 of router OS will have every time the same MAC address, so you have to reset the MAC address every time you create a new router to avoid conflicts. So, let's see how to insert the image in GNS3 and create a base project. So, the steps to insert the image are shown here. You go to tab General, QEMU VMs, and a name of the VM. I usually use only R, and define the amount of memory, and the path to the binary of QEMU, and the number of the adapters. By default, QEMU generates an image with only one adapter and only one Ethernet, but you probably will five is a good number to work, but you can place any number here. So, and now the path to the image we create. So, I already did all the steps in my computer to gain time, and finally using the Dude as a front end to the virtual environment. As you can see, the projects will be a lot of links, and we don't want to show some links like our access to manipulate all the routers. So we use the Dude to hide some details and to make things more friendly to use. So now I will show how to create a simple project and interact with them. And in the presentation, there are all the steps, but I will do manually here because it's very interesting to see. So, we start with new project, name test, We'll create one router, another router. We'll need also a switch, and we'll need the cloud. So the switch, obviously, is to connect everything. And this device here, the cloud, in fact, is a silk device that is, we use it to connect all the stuff with our machine. So I will start configuring. So Linux use a tap interface to connect to this environment. So I add a tap here, and then before I configure the routers, configure the links, I will do a very important thing, that is reset MAC address and put an IP address in all the routers. So I can start the routers here. If I click here, all the active image will start, and then I can enter and configure the router. Admin, without password. Very important command. Reset MAC address. Ether. Before I will show you. I will show the MAC address. So this is the MAC address that is the same for all installations. So we will reset. Ether 1, and we will add an IP address, then 100.0.1/24. Interface Ether 2. That's Ether 1 for router Ether 1 for DNS3. So this is the first one, and then admin, interface, Ethernet, set MAC address, Ether 1, IP address, add address, then 100.0.2/24, interface Ether 1. Okay? So, now I will stop the devices and I will make the links. I click here, and then Ether 0 to port 1, Ether 0 to port 2, and the tap to port 8. I will make a link between the two routers here, Ether 1 and Ether 1, and that's it. Our scenario is pre-configured, and then the next step is see how we can interact with this scenario. So we want now to bind our machine to the virtual environment, and then for this we need to have some support for bridging and user mode Linux. And here we have a script. You can copy and paste this script, and all the things will be configured when you run this script. Of course, you have to give execution permissions. So after the running the script, you check the bridge and tab configuration, and if you get an output like that, the things are okay. I'm running that script, so the bridge is okay. And the IP addresses, the IP address of this mic equipment, I configure 10s, 100, 0, and then something's wrong. Something is wrong with my second route, my first router. Admin. Oh, sorry. Effect. The IP address is Ethernet 1. Remove 1. The address. Then 100.01/24 interface Ethernet 1. I think I have to stop and start. No, it's okay. So now we can launch the dude. And here, I think is a matter of time. That's okay. The dude is okay here. And now we can access the router directly from the dude. Much more comfortable. I will get rid of the full IP address, and I will do. Suppose we want to show to a student how to configure a simple BGP section between two routers. Okay? I will have address here 1111/13 after 2 outing BGP. This AS is AS100, for example. Outer ID 1111 is peering with outer 2 1112 200. Okay. And now I will configure the other router. One 2/13 3 AS200 router ID 1112 spearing with R1 1112 1. Sorry. Remote AS 100. So the session is established here. This is a simple demonstration. You see how useful is this kind of tool to to teach things like that. So, as a hint to avoid mistakes, like my mistake, configuring the IP address. As a hint, you can you can have a base project doing all the things necessary, doing the resetting the MAC address, configuring the IP addresses, etc., etc. And you can have, for example, in this machine, in the old version of GNS3, I run 20 routers. I create a base project, and I run 20 routers at the same time without any problem. And then when I want to create a new project, I go to this base project, I save with another name, and get rid of the routers I don't want, and then it saves time to create new scenarios. There's a problem with this version, 1.2.3 here, is because I try to do the same 20 routers at the same time, and I have some problems when the routers are starting all at the same time. So I try to starting manually each one, there's no problem. I can run with the 20 routers, but starting at the same time, I have some problems here. And I tried this configuration here, but it's not working. This configuration is to delay the start of the machines in some amount of time. So, but unfortunately, it's not working. I reported to the GNS3 guys already. So, to finish our demonstration with GNS3, I would like to show you a real case demonstration, a real case, a real lab that we use in some labs in our trainings, our routing trainings, that is related with traffic engineering. So, at first I will start the project to gain some time. Is this scenario here? Because of the screen resolution, we won't see we don't see the whole picture, but I will show in the presentation. So I will start now because it takes some time. There are 9 routers. So while the routers are starting, we will see some background about what we will do here. And this is a class about traffic engineering, the tunnel, not using LTP nor BGP, because with MPLS we have 3 ways to distribute the labels: with LTP, with RSVPT, and with BGP. This is using RSVPT. RSVPT is an extension of the protocol RSVP, and it supports reservation of resources along the path, and it supports some limitations. It's a very practical and efficient way to make bandwidth control using RSVP, and we also can define how which we want to one type of traffic. So some words about the naming. Here is the customer edge router, the CE router. The ingress router is MPLS router, egress router, and in the middle, the RLSR routers. So, RSVP works that way. The ingress router sends RSVP messages, path messages with the necessary constraints, and the internal routers only propagate the messages, and the egress routers send back the RSVP messages, reserving the resources for the tunnel and all the routers along the path. So in this example, we will see we are doing some things like OSPF is operational in all the routers. The tunnel is established between ingress and egress router using loopback interface because of reasons of redundancy. And the path we define administratively, and the path of the tunnel is not following OSPF routes, but our routes. And when we, for some reason, we lose some path, OSPF can be used as an alternative. Is this a scenario that we reproduce here? We have a tunnel between this router and this router, and this router, and OSPF pass is through this router, but we, for some reason, we decide that traffic must be through this 3 hops route. So the tunnel is established, and the path, the primary path, is defined here. In case of failure of some router, then this other path will be used. So is this scenario that we are running here. So we go to the dude. I think I lost the contact because of that. Okay, no. Okay. The tap tunnel was outside the bridge when I initialized the software here. So now the routers are coming up. I will show you. Router 1 configuration is the ingress router. OSPF is a simple setup here. Only networks, only backbone area, very simple setup. And MPLS doesn't have an LDP enabled. And traffic eng has two paths, one primary, and this primary path is where we defined the strict hops that we want the traffic goes through. So we define with all the IP address, the ingress IP address and the address IP address of each router, and we define the path. And this configuration will define that the flow goes through that sequence of routers here. And the second path, we use the path established by OSPF. So, let's see. No, I will do something different. I will go from a CE router. So, you see that we have 3 hops here to go to 4 hops, in fact, 4 hops, to go to the end of the tunnel. Okay? And then I will do, I didn't show you the limitations. The limitations are established here. We placed a limit of 10 megabits for this tunnel and a margin of 5% of 10 megabits. So theoretically, these links could be reach 10.5 megabits. Going back to the other router, I will do a bandwidth test now. The tunnel is one direction. If I want the tunnel in the other direction, I have to configure the other router. So I will send the traffic only. And that's it. The traffic here is shaped in 10.4 megabits, 10.5. So, now I will simulate if something goes wrong with this router here, for example. I will disable this interface and see what happens with the traffic. The traffic lost some packets here, a little bit, and then the trace route is only one step through the upper router. If the link comes up for some time, it takes some time to recover the original path, to recover the tunnel. Okay. Now is the original path. So, of course, in this lab, we have a lot of things to do and a lot of things to show. This is a simple example because of the time, but of course, in a real classroom, we can limit and guarantee services by type of service. A lot of things we can improve, and this is possible when we have scenarios like that. To do this in a real classroom with real routers takes a lot of time, and a lot of mistakes can be made. Of course, I'm not defending that we need only to use virtual routers, but it's a tool to help in the teaching skill. So, in this presentation, the configurations are here. But this scenario, also the image and other things are available for download, and you can install and reproduce the scenario and can see things more interesting than only the limitation. So, as final considerations, we have to mention about the limitations and the issues. Of course, some scenarios that are related to physical capabilities like wireless, like switching, cannot be reproduced in a virtual environment, so it's a limitation. That presentation in the morning from Rio, of course, cannot be made because it's a presentation with wireless capabilities, etc. Also problems related to interface negotiations, some problems that we, in practice, we have cannot be reproduced in a virtual environment. About the installation, we usually don't have problems installing on Ubuntu, following that steps, but some students reported some problems because of some type of machine. I don't know exactly, but and to use simulators in a classroom is better if before the training we ask the people to go to the training with all stuff installed and working, because we can lose a lot of time trying to debug some issues on installations. So, and to circumvent such issues, we developed an image in a USB stick and an image using Ubuntu 14.04 long-term support with 32-bit, and this image is available for download, and you can install it in a USB if you don't want to start the routers to install in our system. You can start via USB stick. I prepared some USB sticks here. I have 10. If someone wants, I can give you the image pre-installed. So the reference for this work, they are listed here. Maybe I forgot some reference, and I would like to thank some people here, some persons. My colleague from Brazil who worked with me, Sergio, who helped a lot of debugging the scenarios, the installations. Tom Smith and Patrick Schaub, that we have a commercial cooperation, technical information exchange, and our Czech friend Jaromir for the usual hospitality and for the efforts with the Routed World project. So, the presentation and related material can be obtained in this URL. Here we have the ISO image, the USB installer for Windows, the OS image, the tutorial for installation in Windows. This tutorial is in Portuguese, but I think the pictures are enough to make the understand. So, and at the final, I append some slides that are research about the comparison of QEMU and VirtualBox and why we decided to Quick Emulator instead of VirtualBox. And that's it. I thank you for your patience, your attention, and you can on the backstage ask me questions. Okay, thank you.
Thanks to Warner Maya. Next presentation will start after a few minutes by Tomasz Körner.
Slyšíš mě? Jo, jestli už se slyšíme líp? Jo, ale prosím. Jenom chci říct, že jsem tam volal na to AVGčko a paní mi tvrdila, že to není možné, že ta cena, co tam máte, prostě od ní nabídnutá. Tak určitě od ní nabídnutá nebyla, ale přesto jsem teda dovolil, bez svého dovolení vlastně, vzal ten e-mail a přeposlal jsem jí ho přímo, až se to tam teda vyřeší. A psala mi tedy, že to přeposlala na kolegyni k vyjádření, tedy na tu kolegyni, co dala cenu mě, a na tu kolegyni, co dala cenu tobě. A očekávám, že zpátky přijde, že samozřejmě ta vaše cena, ať už teda byla správně přirozená nebo nebyla, tak bude ta cena finální. Čili v tuhle chvíli zatím žádný informace, než kromě toho, že to tam řeší, nemám. Zatím si myslím, že jo, že jako, když se chytou za hlavu, tak to nejspíš skončí tak, že uznají a cenu budete mít nižší a nemůže v zásadě to asi dopadnout jinak. dá to gregerovat. Bez úpravy, jako jedna, přesně kdybych to upravoval, tak by to pak vypadalo, jako že se z nich střílím, tak to prostě vypadá, jak to říkám, prostě přirozeně. Jo, takže v tuhle chvíli prostě tam mají přidaný, mluvil jsem s nima a čekám, že prostě se pozve. Jo, jakmile se tam jedna i ta druhá vyjádří, tej třetí, protože ten třetí nebude tak. Jo. Celku jedno, ale jako v každém případě obě dvě identifikovala ten třetí, to znamená, ode mě tam měla předposlaný e-mail, že vždycky byla jako vyříkat, že jeden dělá si tím má, no a tu druhou chvíli bych dokázal identifikovat, tam mám zápětí na 5 minut, že jsem ten e-mail poslal nebo odepisovala, že obě dvě kolegyně byly požádané o vyjádření. Jo, takhle. Jo.
Next and final presentation for today by Tomáš Kirnák from Slovakia, monitoring and visualizing your MikroTik networks.
Welcome. So, as said before, monitoring and visualization of your MikroTik networks. So this is a monitoring deep dive, hopefully, presentation. So a little bit about me. My name is Thomas. I do network design and security, Ethernet, wireless, fiber, everything. A lot of servers and virtualization these days, and a lot of network management and monitoring, hence this presentation. I'm a MikroTik certified trainer and a certified consultant. I'm here with RF Elements. If you don't know us, you can come and visit us on our stand. So our agenda. First, we are going to look a bit at SNMP, then we are going to look at syslog. Then how to configure SNMP and syslog on MikroTik. Some useful ideas on MikroTik. We will look at the monitoring software, so the do dynamic SMS, and a few gotchas and things that don't work and how they work, etc. So first, a little poll. Pardon the pun there, if somebody notices it. I would actually like to know how many of you do not have any monitoring at all. If you can raise your hands. Okay, just one. Very good. 2 people. Okay, just a couple of people. Very good. This is a very good audience then. So, how of you do have monitoring? Come on, stretch a bit. Very good. Okay, very good. So, those of you that have monitoring, keep those hands up. Come on, hands up, hands up, hands up. Okay, so keep the hands up if you actually monitor CPU, RAM, and hard drive usage. If you actually monitor traffic on all of your interfaces, and here I'm saying packets per second and bits per second, okay? Less hands. If you actually have proper thresholds and actually monitor these values with thresholds and generate proper alerts, okay, so now we have, okay, still a few hands, okay. If you have email and SMS alerts on threshold violation, okay, about 20 people still. Okay, so this was level 1. You passed level 1. Let's go to level 2. So keep your hands up if you collect SNMP threats and alert based on those SNMP threats, and if you collect syslog and alert based on syslog. How are we doing? Okay, about 10, 11 people, I would guess. Okay, so that was level 2. And the special level, level maps. So how many of you actually have maps of on your network? This doesn't matter on the previous stuff. So raise your hands up if you have maps. Okay, a lot of people can. Okay, and are those maps still actually accurate? Because networks change every day. So are your maps actually accurate? Okay, less hands. Do you have separate layer 2 and separate layer 3 maps? Because those are 2 completely different and separate things. Okay, very good. We have a couple of people in the back. All right. And do you have dynamic layer 2 and layer 3 maps that actually adapt to your environment? And if you change something, they actually adapt dynamically. Anybody? 1 person, 2 people. Good. All right, so the rest of you have at least something to learn from this presentation, I hope. So, why all these questions and why did we do this little poll in the beginning here? Because monitoring is amongst the most important things in networking and in IT in general. And I really feel like this topic gets underplayed and undervalued a lot. So the monitoring is the difference between I think everything is okay and I think my network is working and I know everything is okay for a fact. And it might not seem like a lot, but this is a huge difference and it allows you to sleep at night much better. So these questions were actually aimed at a few things. First of all, that the monitoring system that doesn't monitor necessary things is not very useful. Hence all of those questions, if you monitor this and this, etc. And a proper monitoring system needs to actually be independent, which means that you should not even have to look at your monitoring system unless there is a problem. The system should tell you when there is a problem, and you should look at it only when there is a problem. The monitoring system that you constantly have to look at and constantly have to monitor, so monitoring the monitoring system, that's not a thing that you want to do. And regarding maps and why I was talking about maps, network maps are actually a very useful addition to your documentation. And why the addition there is in bold letters, because network maps are not your documentation. We all have network documentation, right? Which is not maps, right? Everybody? So network maps actually help you visualize your network very well and help visualize breakpoints. They help new employees to understand your network faster and especially help consultants help you faster. But network maps are not documentation per se. So what are we actually doing here at this presentation? So hopefully the outcome of this presentation is that all of you by the end will know enough, at least basics, to have all of these nice things. So let's actually start with some theory, and this is the dry part of the presentation, so if you fall asleep, I will not blame you, because this is a bit technical. And if you like that, then very good. So SNMP, Simple Network Management Protocol Basics. So SNMP is a layer 7 protocol used for management of networking devices, and it is used to actually get management information and data and statistics from the devices, and SNMP can actually be used to set configuration of the device as well. But what you need to actually remember is that for this presentation, we use SNMP to collect data like CPU usage, like CPU statistics, etc. from our MikroTik devices. If you remember just this one sentence from this slide, you'll be okay. So how SNMP works, and this is a totally technically correct diagram, if you can see it. It took all of my MS Paint skills to make this. So the device runs an SNMP agent, and this is a piece of software providing the SNMP service. You could call it an SNMP server, but please don't, because that's not correct. But just to help you understand, SNMP agent is simply another service that runs inside of your router OS, inside of the operating system. Then you have the network management software. So we have an NMS, Network Management, Network Monitoring System. And we also call this an SNMP manager, and it retrieves information from the device. And it also has an SNMP trap collector. So this trap collector is simply there to receive traps from the device. So it's a service that runs inside of your software. And again, you can see the perfectly technically correct representation of software right there. So SNMP set and get, and what are these things? So SNMP, as we said, can be used to get information from a device, and this is the most common usage of SNMP, of course. But very often forgotten, SNMP can also be used to set some device configuration. These are just a few examples. It can actually turn the interfaces on and off. It can manage the SNMP agent itself, so it can actually change SNMP credentials using SNMP. It can reboot the device and many other things, but this is out of scope for this presentation. Just please remember that SNMP is actually fully read and write and can be used that way. So again, completely technically accurate graph. This is how it actually works. So the NMS software actually sends get requests or send requests to the device is SNMP agent, and the SNMP agent responds to those requests. And the SNMP agents can also send traps to the trap receiver inside of the NMS software. Just a note here that responses are not actually traps. Responses are just responses back into those requests. Traps are a separate thing. Okay, so that's all and easy. You say that's SNMP basics. It's how all client-server software works, pretty much. So let's get a bit more technical. So there are 3 versions of SNMP, version 1, version 2C, and version 3. So let's take a closer look at these 3 versions. So SNMP v1, and on purpose I put a year there, SNMP version 1 is from 1988. Okay, I guess most of the people here were born in that year already, but that's pretty old. So that was the first standardized SNMP version. And why I'm saying that it's really old is simply because don't use it. And if somebody still uses SNMP v1, please stop. It's extremely old. Don't do it anymore. So it was the first standardized version. Authentication using a community string, which is basically a pre-shared key. And you can have separate communities for get and set, so you can have separate pre-shared keys for get and set. And it was a great start, but for 1988 it was a great start, but today we are 27 or something years later, so it has many issues for usage today, and that's mainly 32-bit counters. So maximal 32-bit unsigned integer is 4 gigabyte. So if you have a 1 gigabit interface, the counter will actually overflow in 4 seconds. Hence, please do not use SNMP version 1 anymore, under any circumstance, hopefully. So let's move to SNMP version 2C. If you are wondering, yes, there was an SNMP version 2, but today pretty much nobody uses that. There is only SNMP version 2C. So it's SNMP getting better. There are a lot of performance improvements. You have bulk, bulk, and stuff that we will get into in a second. And mainly support for 64-bit counters. Yay, it doesn't overflow anymore. And why the C in the name? Because it still uses a community string for authentication. So that's version 2 community. And now we finally get to the good stuff, SNMP version 3, which keeps all the good things from version 2C, but with a new security model. So it actually supports full username password authentication, supports integrity message check, verification, MD5, or SAH1. It actually supports message encryption, and it has 3 security models. As I said, if we weren't technical enough before, I hope this is getting a bit better now by this point. So you actually have 3 security modes. No authentication, no privacy, so no integrity check, no encryption. This is pretty much useless, so MikroTik or any other devices, please don't use this if you don't have to. Authentication, no privacy, this is a good one, so you have integrity check, so the message is actually protected against spoofing, against injection, etc., etc. But you don't have encryption, which can be good, because encryption, of course, is CPU intensive. And then you have authentication and privacy, which provides integrity check of the message and encryption. But this is CPU heavy, of course, because of the encryption. So SNMP best practice, what to do with all of these versions. Again, if you remember nothing else from this, just remember this slide. Do not use version 1 under any circumstance. Every device today, I would hope, supports at least version 2C. So, but still, use version 2C only if you have to. And use version 3, probably the best to use authentication, no privacy. So you don't do encryption directly in the SNMP engine. But then run the SNMP communication over VPN, not over public internet. If you have to run SNMP over public internet, use, of course, version 3 with encryption. But generally, you should be using authentication, no privacy, and then encrypt only the transport link, which leads over the internet. So this is the basic stuff. Do a site-to-site VPN, and then poll all your devices using SNMP without the additional encryption inside of SNMP, since your communication is already secured by the VPN. I'm not saying the encryption inside of SNMP isn't good, or you shouldn't use it. It's completely valid, and it's good. It's AES 128 CBC, so it's good. But then again, just to avoid the unnecessary load on the CPUs, if it's only, in my opinion, it should only be used in certain situations, not always. So the best bold authentication, no privacy. So let's move a bit forward. Again, we are talking about SNMP and what it is, and about SNMP basics. So let's talk about MIBs, MIBs, Management Information Bases. So MIBs actually describe data and its organization inside of the SNMP structures. And why do they exist? Actually, SNMP structure is made to be easily expandable, extensible by the MIBs, because each vendor may need to expose different things over SNMP. For example, a server doesn't need to expose wireless access point information, but a MikroTik device, if it's running an access point, you want those information to be there inside of SNMP. So MIBs actually make the system, the SNMP system, actually quite user-friendly and quite easily expandable. So what is this MIB that I'm talking about? It's just a file you give to your NMS, Network Monitoring Management System. And the NMS will use this file to make the information you get from SNMP more useful. Again, that's the simple version. So what's the difference with and without having MIBs? So this is a screenshot without having any MIBs. And you can see we just have a bunch of numbers and some types and then some values, which what do you do with that? I don't know what that is. So this is how it looks without MIBs, and this is how it actually looks with MIBs. So this is a big difference because we can now see that those numbers that we had before are actually a UPS exposing some data to us. And for example, we can see that this number that was there before that we didn't have a clue what it was is actually UPS battery temperature given in tenths of a Celsius degree. So this all information is pulled from a MIB. That's why I said that basically MIBs, you give them to your LMS and they make the information you go from SNMP more useful by giving you context and giving you details about the data that's exposed over SNMP. So how data is structured in SNMP? So data or information in SNMP is structured as a tree. And as you work with SNMP, you will slowly learn what's located where inside of the SNMP tree. And just a few examples how it actually looks. So you have the root node, which is .1, and then you have the tree structure expanding. So .1, .3, .6, etc. is basic system information. Then if you continue down that tree, but through a different branch, you can see .1, .3 is the same, and even .6 is the same, and it actually splits somewhere down here. This is the basic interface table, and then this sequence inside of the tree, so this branching sequence inside of the SNMP tree is the advanced interface table. Don't worry if you don't understand this, we'll cover it a bit more in a few seconds. So OIDs, object identifiers. So these are actually the paths inside of the SNMP tree, you could say. So these are called the OIDs. So what we've been seeing up until now, these sequences of numbers are actually OIDs. So this sequence of numbers, we could say, is the basic system information OID. And there are many OIDs for many things. And we will look at some useful OIDs soon. One more thing which I would like to cover or explain is SNMP walking. So SNMP walking refers to getting all the data in the tree under a certain OID. So if you can imagine the tree structure, under this OID, there can be some more information, more leaves, more branches of the tree. So if I say that I'm doing an SNMP walk, I'm referring to actually getting all the information under the specific OID inside of the SNMP tree. So for example, walking this OID would give me the basic information about the device, since we said that this OID is for the basic system information. So walking.1, which is the root of the tree, which is the most upper node, would actually dump all the available information from the device over SNMP don't do this. It will take ages and possibly kill the CPU in your device, since the whole SNMP tree contains a lot of information, possibly millions of records. All right, so let's do an actual SNMP walk, or let's look at an example of an SNMP walk. So this OID that we've been mentioning up until now, the basic system information OID, if we do a walk of this OID, and you can see here I have the information of what is what from the MIB, from the MIB, I can see that the bulk of this particular OID gives me a few information. First of all, what this device is, my email, so the SNMP contact, the location, and you can see here system location, this is this one, so it's on my test bench, system name, this is this one, system contact, this is this one, etc. So what you can see here is simply a walk of this OID, and I have the MIB, so I can see all the information, and this down here is the result of the walk giving me the actual data or information about the device. Alright, so that's SNMP basics. Let's look at a bit more advanced stuff yet again, which is SNMP tables. Data in SNMP is organized in tables. Here is an example of an actual table. So we have an index, and then we have some columns inside of the table giving us some particular information. So how SNMP tables actually work? There is usually a main table index, OID. For example, this OID is the interface table index. So for example, here, if we hold the index, it will give us 1 through 7, which means we have 7 interfaces on this router. And we can then hold different OIDs to get different data about each interface. So index simply ensures that we know which data belongs to which interface. Like here, if we bulk this OID, we will get the index from 1 to 7. And then if we bulk this OID, because this OID is the interface index, and this OID is the interface description, and inside of the interface description vault, we can see the suffixes, which are really the index here. So we know that interface 1 has name Ethernet 1, and the MTU value is 1500. And just like this, you can construct an SNMP table inside of your software that looks like this. This is what it basically is, put into a single table. Okay, so that was too complicated, too much information. Why are we even talking about this? I admit, don't worry, most of this is handled internally by your NMS, but it's still good to know how it actually functions once you get into monitoring everything pretty much, which is the point of this presentation. So you just have to know, again, if you take nothing else from this part of the presentation, just know that certain data is available at a certain OID. And you can insert your favorite search engine here to find the OID of the data you're looking for. So just type in your question into whatever search engine, being OID for disk usage, and it will come up with an OID you can use. Alright, so that's it for SNMP. Now let's look at syslog. How many people do we have asleep here yet? Oh, there is, okay, 1, 2, no, they are raising their hands, so they are not asleep. Good job, people. Alright, so syslog. And syslog is easy, don't worry, we won't be talking for another 20 minutes about syslog, because syslog is easy. And on a basic level, syslog is just a standard to transfer logs over the network. So using syslog, you can actually dump all your logs from your device that your device generates into an NMS. And this is very useful, and you should do it. So why? Why syslog? Why should I do it? You have logs which are stored locally in your device. This is a simple MikroTik log. You can see that some links went up and down, your CPU is refreshed, etc. But these logs are lost on reboot because they are stored in device's memory. Yes, you could configure logs to go into the device's hard drive, but what if that dies? So if a device goes down, if the logs are in the memory, it is useful to see why the device went down, and the logs can actually tell you. So an NMS can keep a long history of logs, and the device has limited memory. And like I said, even if you dump your logs to a file on the device's hard drive, that is, again, very limited. And also, with the right network monitoring management system, you can really do nice searching and filtering of logs. And you can do it instantly. You type a certain search query into the NMS, and it will give you all the logs matching from all of your devices. So syslog is very useful. And like I mentioned before, you can actually generate alerts and alarms based on the logs. So for example, if an invalid login happens more than 3 times in 5 minutes, send me an email. This probably is a very nice thing to have. So how many of you have seen logs like this? Yeah. So this is bad, and you should probably know when this is happening. But unless you log into this device, you wouldn't know and you wouldn't see this. So that's why it is very useful to dump your syslog into the NMS, so your log into the NMS using syslog. And then the NMS can actually generate alerts when this happens. Which, again, you should probably know if this is happening, because this is not good. All right, so let's look at some configuration. So configuring SNMP on MikroTik. This is SNMP version 3, made easy, so you can just copy all of this, replace what's in red, paste it into your MikroTik CLI, so over SSH or whatever, and boom, you have SNMP version 3 ready. With the username and password that are here, and this is using authorization no encryption. And the slides will be posted publicly after the presentation, so you can copy this. Okay, so configuring syslog on MikroTik. This is made very easy as well. Apparently, spellcheck has made it east. Okay, so that's supposed to be syslog made easy. So you can see you can just paste all of this into your MikroTik again, change this for your NMS IP address, and there you go. And your MikroTiks will now actually dump their logs onto the syslog server. So like I promised, here are some useful OIDs on MikroTik. For example, CPU usage of each individual CPU core is located on this OID. Router OS version is right here at this OID. Health table, so temperatures, voltages, wattage, so power usage, all the different temperature sensors that MikroTik has. Right here under this is actually a table, so the 3 under this OID, if you do a Volk, you will see all of it. Storage table, so you can see disk and RAM usage under this OID, and interface table, so you can see interface data. There is a lot of interface data and statistics under this OID, including bytes per second and packets per second transferred, received, and sent on an interface. Useful wireless OIDs, for example, wireless card frequency is right here. Total number of wireless clients. If you are in access point mode, you can get a lot of per client data, like signal strength on every individual chain, signal to noise ratios, everything, speed of every single user, after modulation. There is a lot of data under this OID. And you can even get useful things like the number of PPP clients for your PPP-only concentrators or for your VPN concentrators. That's under this OID. And these are just a few examples. There is a lot of things inside of SNMP, of course. And if you want to see everything that MikroTik provides that's MikroTik specific, you simply download MikroTik's MIB, MikroTik's MIB. You plug that MIB into the NMS, and you will be able to see all of the data that the MikroTik could provide. So what should you actually aim for with your monitoring system? And this is just a recap of the things that we said before. First of all, you should aim to have monitoring. So that's the most important thing. Without monitoring, you just get it, please, do me a favor, and you will thank me later. And you should aim to collect CPU, RAM, hard drive usage, traffic on interfaces on your devices, not just MikroTiks, your server, your servers, your routers, your switches, everything. Monitor, of course, temperature, voltage, and actual watt, power usage of your boards, and to actually have proper thresholds on all of these boards and generate alerts on threshold violation. Then it would be, of course, useful to have email alerts on certain alarms and on certain thresholds, and even have SMS text message alerting on alarms with high severity. So if your core router is down, or one of your two core routers is down, because you should have redundancy, so 2 core routers, please. So if one of those is down, you definitely want to get a text message. If you only have one, you are probably not going to get that text message because it's not going to get out to the internet. So that was, again, our aim level 1, and our aim level 2, to have more nice things like collect SMP traps, and then alert based on those SMP traps, collect syslog and alert based on syslog messages and syslog severity, and a really nice thing to have is dynamic layer 2 and layer 3 maps. So here we are talking that, again, this is all using SNMP, so a network monitoring system should actually be topology aware and should be able to get enough things from your SNMP, and it can, to actually generate dynamic layer 2 and layer 3 maps of your topology. So if you add a device, the NMS will actually dynamically add the device and connect it properly topologically onto the map. And we will look at this in a second. So what I'm trying to say is monitor all the things, monitor everything. So why all of this? Why did we even bother? Because this sounds like a lot of work, right? So why do we bother? Just to have the peace of mind and to know for a fact that your network is fine, not just assume that your network is fine. Because if you just assume your network is fine and it's based on no fact, then what's the truth? So, and we really need to have an independent system, or you need to have an independent system that will let you know when something is wrong, rather than you having to look at it and monitor the monitoring system. So now we will take a look at some NMSs and how to achieve all of this. And just to say, there are many NMSs, and you have many choices in this regard. I have actually took 2 NMSs to show you here on this presentation. So first of all is the Dude, which is a MikroTik NMS. It's free. It's very easy to pick up and learn, and very fast to get started and get some results. So let's do a little Dude demo. If my VPN allows me to connect. Alright, here we go. So this is the Dude. You have probably seen it even in the previous presentation. And if you've been with MikroTik for any amount of time, hopefully you've seen the Dude by now. It's going to connect, get some stuff. This will probably take a minute because this Dude installation is quite large. Come on, getting stuff. And like I said, you have many options here, many NMSs. But one thing I want to point about the Dude is, like I said, the simplicity. It's completely graphic, so it's a completely GUI-driven experience. It's really fast and easy to set up, and the actual amount of work, the actual amount, the price-performance ratio with Dude, so to speak, is really high. So you simply can have it completely running in about an hour, and great, you have at least some monitoring. It's still downloading and connecting. Courtesy of Conference Internet. Next slide. there we go. We're getting there. All right, so this is an example dude installation. This is actually kind of our network. So we can see that we have a bunch of devices here. And we have 2 uplinks. We have some VPN connected here. This is a wireless link, and there is a lot of stuff, and things are green and blue. Yay! A couple of things are red, so that's probably not good. So what I'm trying to say is that just looking at this, you can already see with a single glance that this is very graphical. It's actually, like I said, very easy to set up. And the dude can do some pretty powerful monitoring. If you, for example, look at this network, it's actually not giving us the information about the UPS in our rack because, it's 64-bit counters. Next slide will explain why this is not working. But you can see that really easily you can see the CPU usage, memory usage, hard drive usage of a couple of servers here. You can see some switches again. This is our infrastructure basically. Oh, let's do. So this probably would take you, if you didn't know Doot at all, this would take you, I would say, 2 to 3 hours to make something like this, which is a pretty good result for a fast time investment. And you can see it has nice graphs, it has history, it has a lot of things. And the Doot can even do things like syslog collection, which we mentioned. But there are some disadvantages. And I'm not going to spend a lot of time on the Doot because, like I said, probably most of you have already seen it. If not, it's really easy to pick up. So, yes, the Doot has some disadvantages though. And it's no longer maintained. So the last release of the Doot was about 4 years ago. Ever since then, MikroTik has been saying it's not dead, it will be patched, it's still alive, but the fact is that it has not been patched for about 4 years now. There are no templates. It's really tedious to set up some things like syslog. It works, it's there, and it does its job, but it's tedious to set up. Also, custom monitoring and stuff like that is tedious to set up. 64-bit counters break a lot. 2 gigabyte database limit, and it's a node size, SQLite database, Windows only, blah, blah, blah. I could go on. Like I said, it's a really good system, fast to learn, fast to do, but it has many faults. And that's why I actually chose another LMS to show you, which is NetXMS. NetXMS is an enterprise-grade LMS. It's free and open source software. It's extremely powerful and extremely versatile. If you have never heard of NetXMS before, I hope what I show you you will like. Just to say here, I actually reviewed Nagios, Zabbix, Xenos, Observium, and a lot of network monitoring solutions. And NetXMS is the one I particularly chose and like, so I encourage you to take a look into it. So I think I don't need to read all of this. Linux, Windows, Solaris, blah, 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 full multi-platform, multi-database, unified web and dedicated client, templates, blah, blah, blah. It does a lot of stuff. So I want to show you NetXMS with MikroTik and the power you can have using MikroTik devices and a proper NMS system. So this is our NetXMS system. And there we go. You can see I have a bunch of devices here. Again, most of the things are green, some are other colors. And I'll just step down here so it's easier. So first of all, a few things I want to show you, which is why I mentioned SNMP and monitoring. If we go into our MikroTik devices, so router OS, you can see I have a bunch of them here. Let's look at our IPsec access concentrator. And you can see that on our IPsec access concentrator, I actually monitor the CPU, come on mouse, the CPU average load for both cores, how many cores the router has, CPU usage on every single core, board temperature, CPU temperature, all the health variables, how many active EPP clients there are, RAM size, usage, router OS version, a lot of things. And as you can see, actual packets per second and bits per second on every single interface. So this is probably enough. I'm not saying I couldn't do better. I could monitor many more things. But these are the basics that you at least should aim to monitor. And actually have thresholds, and alarms, and alerts, and SMS, text messages, etc. on threshold violation. What I want to show you is these things, which are some nice graphs you can see here. So RAM, this is when I connected my VPN client from here for this presentation, so you can see the number of VPN clients went up. So here are some nice graphs. And you can see that we monitor every single interface on this device. So you can see this is pulled straight from SNMP, being the SNMP interface table. And we actually monitor every single interface on this router, and we expect every single interface to be in a specified state. So if somebody unplugs one of my interfaces, I definitely want to know. And if somebody plugs in a cable somewhere that's not supposed to be there, I also definitely want to know. So you can see we monitor every single interface on our devices, and we just take care to know how our network is. And as I said, a lot of other things. And you can see if I do here this, you can see that we actually have thresholds on, let's say, CPU usage, or let's say RAM usage. So from RAM usage, for example, you have thresholds. This is at 90%. So if RAM usage on our MikroTik goes above 90%, we get an alert. I get a text message, and I know that I have to do something about it. This again goes back into saying that I shouldn't even look at this system unless something is wrong. That's the proper monitoring system. I don't look at it, at least it lets me know I need to look at it. So, for example, we can do useful things like look at the version of all our router OS devices. So let's do MikroTik, actually versions, router OS. So you can see that I have a bunch of MikroTik devices here, and I collect from SNMP the version of all of my devices, and you can see that most of my devices are on version 25 or 24. One is even on 6.1 because that's our edge router, and I don't mess with that. It works, so I don't touch it. And our BPPO access concentrator is on 6.7. Again, it works, so I don't touch it. Which, by the way, I recommend. It's a great thing. If it works, don't touch it. You know, that's the general IT rule. I recommend following that. It works. So you can see that just with a few clicks, with the proper NMS, and having all this SNMP data from my MikroTiks, I can do wonderful, wonderful things. But what I mentioned about maps and dynamic maps. So let's look at the dynamic layer 3 of our network. So this is completely dynamic. I haven't put any of the nodes, any of the things, any of the links you see there on there. This is all actually gathered from the MikroTik's routing table over SNMP. So the NMS actually is completely topologically aware. It knows what's connected where. It knows the routing tables of every single device. It knows the layer 2 connections of every single device. Again, MikroTik exposes these data over SNMP. So this is a completely dynamically constructed map. If I press refresh here, this will take a second because it's over VPN. It will actually completely rebuild. You can see it. Let's do layout. So you can see if I press refresh, it will rebuild the whole network every single time. That's how you can say it's dynamic. And you can see it even knows ECMP, equal cost multipath links. So this is a redundant link. It even knows from the routing information from my MikroTik devices, this is all MikroTik routers, how to actually construct this topology. So completely dynamic layer 3 maps, and also completely dynamic layer 2 maps. So what you can see here is a dynamic layer 2 map. Let me just get rid of all these nodes. You can see this is a dynamic layer 2 map of my topology. Again, layer 2 maps are very different from layer 3 maps because of VLANs. We have many VLANs inside of our system. Therefore, visualizing the topology on layer 2 and on layer 3 can be very useful for debugging because the topology is very different on layer 2 than on layer 3. For example, you can see that on layer 2 we have 4 core switches which are connected in a full mesh. You can see these 4 switches have a full mesh in between them. And then we have some ESXi servers which are also connected redundantly to 2 core switches. So this is a layer 2. But on layer 3, this is the core. It's a star topology of the core. So you can see here how visualizing this can help me to understand my topology, or if I have a new employee, help him understand this topology much faster. And again, this is all data from SNMP. I could show you a few more things, I guess. Again, updating my system can be as easy as clicking on the device and running a certain tool. For example, opening Winbox, one click, and I think that just opened on the other screen. There we go, now I'm connecting to my actual MikroTik. So you can see a powerful NMS combined with a powerful system like MikroTik can do a lot of things. Actually, one really cool thing I would like to show you is this. Let's say I have, let's do this one, AP Thomas. So my access point. Where is this located inside of my network? I know, but a new hire or a consultant might have no idea. So it's really nice to just be able to click on this. There is a command here which says find switch port, and magically the NMS will tell me exactly where this device is connected in my network. Again, this is because the NMS is completely topologically aware. It knows the ARP tables of every single device, it knows the IP routing of every single device, etc., etc. So I can actually see that this device, access point Thomas, is connected on Ether 1 to switch rec 1 on port 14. All right, very good. Let's find where, let's say, router 2 of wireless LAN 1S switch port. There we go. Okay, so this is connecting on the same switch to Ethernet port 32. And also what I would like to show you, we can find a wireless access point. So let's do networking, point to multi-point access points. And let's actually do topology and wireless stations. And you can see even, again, MikroTik exposes this information over SNMP. So you can actually see every single wireless station connected to this access point, which SSID is connected on, etc. So let's take things a little further, because there is a button here which says find IP address. And again, for a new employee, I simply tell him, this IP address has been causing us trouble. It has too much traffic going in or out, it's spamming or something. Go and find that device, where it is, what it is. I just know the IP address, go and solve it. So let's put in an IP address. Let's do 10.3.199. Here's my computer. And magically, it finds my computer right there by its IP address. Again, this is because the NMS is completely topologically aware. But even better, let's find the PPPoE customer, which doesn't have an IP address, or rather it has, but it's a /32, since PPPoE is a point-to-point tunnel. So even if I knew the IP address, it doesn't tell me much because it's a PPPoE thing. So NMS would see the PPPoE connection being terminated on the access concentrator, and therefore I would see the access concentrator as the owner of that IP address. So there is a button here. Okay, first of all, let's find a PPPoE customer, which can be used for the experiment. Let's look at, where's the PPPoE? Here, access concentrator, let me connect using Winbox. This is kind of hard because I don't have the screens cloned. Okay, so I will just find one PPPoE customer, and I will not show you. Let's do this one. So I just know the MAC address. And again, let's say that this is a case where a certain MAC address has been sending out a lot of layer 2 broadcasts. So it's spamming my network, it's layer 2 broadcast spam, I have no idea what the IP address is, it's an attacker, and I want to find it as fast as I can and get rid of this attacker. So I only know the MAC address, I put it in there, I press OK. And magically, the NMS will show me that this MAC address, I don't know what it is, it doesn't have an IP address, but it lives on this MikroTik access point, on this SSID, and it's a wireless client. So again, you can see how powerful this can be. With just a couple of clicks, I can find any IP address or any MAC address inside of my network, and right away I can know where it's connected, and I can go and investigate, disconnect, etc., etc. So we have gone through maps, we have gone through alerts, we have gone through some useful things. Also, what I would like to mention is that you can actually have really nice things like one button device identification and applying of the templates and of the monitoring. So you can see I have a MikroTik template here, so router OS or switch OS, MikroTik devices, both of them. And if I add a new device into this NMS, it is capable of automatically discovering the device over SNMP, figuring out what the device type is, and applying correct monitoring items, correct templates to this device. So the end effect is that you just give the NMS an IP address, and it will automatically find what needs to be monitored, what needs to be thresholded, what are the thresholds, etc., etc. So it's a completely automatic, easy-to-do system. All by the power of SNMP. All right, so let's continue. Okay, so a few gotchas. So there have been a lot of SNMP bugs in router OS. For example, bulk doesn't work in these versions. Version 3 timing problems make version 3 unusable on these versions. Storage was missing completely in SNMP in these versions. I could go on. But what I'm trying to say here is that always use the newest router OS version and make sure to also use the latest router boot version. Because some SNMP bugs are actually fixed by changes in router boot. So router boot upgrades actually fixes bugs in SNMP in router OS. So just remember that if something is not working, just use the newest version and it will most probably work. But yeah, you are not safe even right now because in 6.27 there is a bug that causes routing table not being reported over SNMP in certain cases. So this will be fixed in 6.29. Just watch out, not at 6.28, which will be coming out next, but in 6.29. So make sure to upgrade to 6.29. There are SNMP upgrades in there. And one important thing is that storage. In older versions, older than around 6.15, storage was actually reported differently on x86 router OS and on router boards. So this basically meant you needed separate monitoring templates for x86 and router boards prior to this version. So this has since been fixed. But watch out for this if you use older router OS versions. So if your NMS is not monitoring the storage usage on your router board, and the router OS version is older than this, then you need to go and look at it, see how it's implemented in the old implementation of SNMP, and create a separate template. So what can still be improved? There are still things that can be improved. For example, MikroTik does currently not support LLDP. It does not support STP MIP and BGP MIP. This is a big one, and this is a big one. So it would be really nice. I don't know if there is somebody from MikroTik here. If you are, these are my feature requests. And that's basically it. If you like this presentation, I have a couple more presentations on TikTube you can look at. And yes, if you have any questions, either ask now or find me after the presentation.
this was the last presentation for today. Next presentation will start tomorrow at 9 in the morning, and there's free beer waiting for you outside.
Jak trzeba było, to zjechał. Tak, co nie działa.
Yeah, you can actually see them move physically on the roadmap if that data is available over SNMP or in any other way you can reach it. You don't want to get disturbed. Yes, it's not as easy, but you can basically have, like you see me using RunTOS, this one, and you can have tools, and then you can have a tool which says update. But you have to do it kind of in a roundabout way, so it actually launches an SSH command on the Medics MS server that connects to the MikroTik and just does, system upgrade